Welcome to the AI Travel Assistant series. In this one, we are going to be building a bot that will forecast or predict future values of the cost of flights. Those future values will then be fed into another AI to give us the best option, to suggest the best option we should use. So let's actually take a look. First off, we're going to select our starting airport at LAX. We're going to have our destination be JFK. We're going to say it's nonstop, and we're going to go ahead and ask the bot to help us figure out the best value here. Now, all of the things you see right here are going to happen in this project. We design everything from zero all the way up to the web application itself. And this is all made possible thanks to a collaboration with MariaDB and MindsDB. So thanks to them for sponsoring this series to make it happen, because we use their tools a ton and they are both fantastic, as we'll see in just a moment. So what we've got from this example is the data coming back. Now, before you get, hey, that says 2022, that's way in the past, what are you thinking? Well, that's because we're using a data set from the past. This data set could be modified to work in the future, but that's outside the scope of what we're trying to do here. What we're trying to do is we're trying to build a foundation that we can use our own data to make forecasts on, to look into the future as to what the price could possibly be. And that price, in this case, for any given route is like 200 to 340 bucks. So if I removed that date column, I would have a really good sense as to how much this would probably cost to fly from Los Angeles to John F. Kennedy in New York. That would give me maybe about $209 as a one-way ticket. Now, the same would be true if I actually selected other airports, right? Which would also make that prediction. So what's happening behind the scenes is we're feeding in a bunch of tabular data to our database, and then from our database, we will train a forecasting model. That forecasting model will be trained in MindsDB to then give us the ability to run these predictions when we need them to be ran. Once we have the forecast options, we then, through MindsDB, use OpenAI to make a prediction as to what the recommendation will end up being. Now, all of this data is actually stored in MariaDB, a self-managed instance, an open source instance that we use and we will deploy absolutely. I'll talk about that in just a moment. The other part of this that I think is really cool is we're using a Next.js frontend, which is a React.js framework. It's really just scratching the surface of what we can do with Next.js and React, but it is there and it's definitely achievable even if you've never used React before. We're also using TailwindCSS to make this look really cool, which is also pretty achievable even if you've never used it before, thanks to a bunch of different services that are out there, in particular Tailwind and Flowbite. And then for the backend, what we're actually using in the backend is a Python web framework called FastAPI. Now, the reason we use the Python web framework is so that it can interact with our Jupyter notebooks, is where we're going to be starting with all of our analysis. So there's a lot of things that I want to cover. Let's actually take a look at just a little bit more of an overview of what we're going to be covering in this series. But thanks again to MariaDB and MindsDB for sponsoring this one. Let's go ahead and take a look at the actual overview of what we'll do. Here's an overview of what we're going to do in this project. We're going to provision an AWS EC2 instance, which is just a virtual machine. We're going to log into that virtual machine with SSH. We're going to install Docker, and then we're going to deploy our MariaDB instance. We'll set up all the security protocols necessary to make sure we can connect to it. And then boom, we have our own self-managed MariaDB instance. It's actually just that simple. Once we have that database, we can use it anywhere in the world. And in our case, we will actually load in a Kaggle dataset using Python Pandas and Jupyter notebooks. And we'll also do some aggregates with Python Pandas to make sure the dataset we're using is really prepared for MindsDB. Now, we actually end up using two different datasets so you can get a better sense as to how to create forecasting models with MindsDB and with using SQL, even if you've never done either of those things before, because they are fairly straightforward. And the MindsDB console is pretty easy to use to do these predictions as well. They also have a ton of documentation on it also. Then we'll go ahead and connect our MariaDB instance with FastAPI using SQLAlchemy and Pydantic. Now, these things are very common with FastAPI, which is built in Python. So this is all Python related things. Then we'll connect FastAPI to Next.js. That will be a Next.js heavy thing to using fetch and various client-side requests to our FastAPI backend. We will also create the necessary forms and routes to handle Next.js and App Router. App Router is the modern version of Next.js, so some of you might know of Page Router. We're using App Router in this one. But really anything we do here in the front end can be reused or repurposed for many other front ends that are out there. Especially if you set up a really solid backend with FastAPI, which is what we try to do, you will be able to then do any kind of client side, whether it's a Slack bot or a Discord bot, or even you could text message it. Once you have the foundation there, you can add in all of those other features. We're also going to make it look good, the actual front end, the web client itself with Tailwind and a bunch of references from Flowbite. We will then create a reusable airport select component using a bunch of different things. That's this right here. So in our dropdown, if I grab any given element here, let's say for instance, I put Denver in the destination, and then I put it back in the starting airport, things readjust a little bit. So that gives us a foundation to make the user interface much, much better and much more user-friendly. Then, of course, we connect FastAPI to MindsDB with REST API calls. So if we look at the code itself, we've got a way to call MindsDB directly with a SQL query, just like we do in the console. And then we can do our predictions here, which is what's going on right there, which is very straightforward. And if you know Python, this doesn't look that complicated, hopefully. If you don't know Python, but you know SQL, same thing. If you don't know either of those things, this will be a nice foray into that, really jumping into the deep end. And then finally, what we'll end up with is we want to extend the data set that we have. We want to get more of that data. Now, one of the ways we could do this is by creating a bunch of random data, or we can create synthetic data, which is exactly what we do with Gretel and Gretel.ai. Gretel will give us synthetic data so that we can actually start to emulate a data ingestion as if we were getting new and new data all of the time, which of course would be the goal of any given application like this at some point. But that's the overview, right? So be sure to check the description below. You can also jump around in here quite a bit. The code is also all available on GitHub at github.com/coding for entrepreneurs. Or if you want a shortcut to that, cfe.sh/github. That will bring you to the same place, and you'll be able to reference all of the code that we have in there for this. So now let's actually talk about the actual requirements you'll need to be successful in this course. Before we actually jump in, let's talk about the references and requirements you'll need to do well in this series. First and foremost, all of the code is at cfe.sh/github under the AI Travel Agent repository. This repository is broken up into 58 branches. Every branch corresponds to some sort of section of this series. So in other words, if you're on section 33, you have two branches that are correlated to that. The start of section 33 and the end of section 33. The end will have all of that latest code. Not every section needs to have its own branch, which is why every section does not. The main branch, the one you see here, will have all of the latest code available for the entire project. So if you wanted to just jump ahead and see everything that's coming through, this will be there. The biggest caveat is the datasets folder. The datasets folder will not have any of the datasets, so be sure to watch the parts on how to actually load in and get those datasets in order to actually use them. Next up, we are going to need Python installed on your local machine. I highly recommend that you have some experience with Python, but this is required for a number of our project-related things. That's getting Jupyter up and going, that's getting our FastAPI application up and going, and doing a bunch of different analysis there. So if you've never done Python before, or if you've never done Node.js before or JavaScript before, I also highly recommend you check out my 30 Days of Python series. This one is a really good introduction to programming in general. Once you do this, using the Node.js stuff is not going to be a whole lot different than what we do with Python. That being said, you also want to have Node.js installed, which I will touch on again, but ideally the latest version, the LTS version of Node.js to make that work. And I also highly recommend that you use Visual Studio Code for all of this. This is the open source version of Visual Studio, and it's how we're going to write all of our code, and it's really just one of the best out there. So those are the baseline things that we need to have installed. There are a few others that you might consider, and that is, of course, having an AWS account. We will provision an EC2 instance in a moment, so I'll repeat this in a moment, but you will want an AWS account. You also will want a MindsDB account, which again, I will re-reference as well. You'll want Gretel.ai. And if you want to skip the AWS of it all, then perhaps you're going to sign up for the MariaDB Sky SQL service, which is their cloud-based offering. Granted, it's not self-managed. This is a managed service, so it does have price and costs associated to it. Personally, I think using the Docker-based instance is a really good idea, so you can get a lot of that foundation out of the way and also getting up to the point where, yeah, you can then start to really leverage something like Sky SQL. Cool. So with all that in mind, let's go ahead and provision our EC2 instance on AWS right now. Now, a key component of the AI we want to build in this project is by using our own database. Once we have that database, we'll connect it to MindsDB to then start building AI things on top of it. So the database we're going to be using is MariaDB. Now, we do have a few options on how we can deploy this. Number one, we could use their enterprise-grade managed service called Sky SQL, or we can use their community free version, which is what we'll stick with. That free version also has a Docker image, an official Docker image that we can then also provision this database with, which is what I want to do. So to do this, I'm going to be using AWS and more specifically an EC2 instance, a virtual machine that is in the cloud so that it makes it really easy for me to connect to MindsDB as well as any sort of application I want to build on top of it, like a web application, which is what we'll be doing. So at this point, go ahead and sign up for AWS if you haven't already, and then sign into the console, which will look something like this. Now, if you're already familiar with creating an EC2 instance and you know how to connect to it and all that, by all means, go ahead and do those things. We'll be installing Docker soon, but what I want to do right now, for those of you who haven't ever used EC2 before or it's been a while, we're going to go ahead and configure an EC2 instance. So in the AWS console, I'm going to search for EC2. I'm going to click on this, and I'm going to go ahead and click on instances. And notice that I actually have two already terminated. Now, I did a few samples of this just to make sure everything was working good. But the idea being that you want to get familiar with creating and destroying instances as you see fit. So anytime you need a new instance, you can just create it. This is really important for the learning process, but then also just to start fresh with a brand new database whenever you need to do that. So what we want to do is we want to launch a new instance. Now, notice in my case, I'm in the Northern California region, or North California, if you want to think of it that way. But the idea being that I'm in a specific region that's not that far from me. I'm in Idaho, so it's not that far to North California. So I'm going to go ahead and launch an instance in this region. So what I want to do then is give it a name. And in my case, I'm going to call it my MariaDB, and this is going to be my Docker engine or something like that, right? I'll just call it MariaDB Docker 1. Okay. Next up, I need to select the operating system I want to use, which in my case, I'm going to be using Ubuntu. Now, I'm really familiar with Ubuntu with other cloud services, and more specifically, 22, the LTS version of Ubuntu as well. And it's also free tier eligible. Again, another reason to use it. Other versions or other operating system images probably work okay, probably work fine. I don't know about Windows, but the idea being is we want to use as many free things as we possibly can. So Ubuntu, I think, is a great choice for this. Next up, the instance type. This is the actual hardware we want to associate to this virtual machine. In my case, a T2 Micro should work just fine because it's also free tier eligible. But of course, if you need a more robust one, you can just go ahead and select one of those and just work off of that. Next up is we need a key pair login. Now, I already have one on here, but I'm going to go ahead and create a brand new one. And what this is going to be is our private key for our SSH connection, which we'll see shortly. But the idea being that I want it to be my MariaDB private key and just leave it as that. and I'll go ahead and create that key pair. Now, as you see, I have a few examples of this already being done, but this actually creates a private key in this region, which you can verify, and I will in just a moment. Next up, my network settings. I'm just going to leave these things as defaults. I don't need to change anything here. You don't necessarily need to create a security group. You can always select an existing one, but creating a new one ensures that, well, we can actually modify it to fit this project's needs. And the next thing is I can also only require specific places like my IP address, my computer, to be able to have SSH traffic, which is something you might want to do to further secure this instance itself and the connection to it. But pretty much you're going to be using a lot of defaults here. Next up, the storage itself. I'm going to go ahead and give myself 30 gigs. So when I hit 3, it actually blocks this down for some reason. But I'm going to do 30 gigs because that's what free tier is eligible for. Once again, you can always provision bigger sizes than this, or you can even attach new volumes to this, which has a lot of potential, especially when using Docker, because then you can then use those images or that size to have a more powerful database, or one that can at least store more data. So with this in mind, that's pretty much it. We've got our network settings up with the default VPC. Whatever it ends up doing, it automatically assigns a public IP address for us, and then we allow SSH traffic. We do not need HTTP traffic at all because this is not for a web application, it's for our database. So I'm going to go ahead and launch this instance now. It shouldn't take it that long to provision, but it will come up here shortly. And what it will do pretty much right away is give us this public IP address, which we can use to connect to it once that's available. I'm going to let this finish actually provisioning, so then the next part we can actually connect to this instance. Now we're going to go ahead and connect to our EC2 virtual machine instance by the public IP address and also the actual private key that we downloaded. So to do this, I'm going to open up my terminal window. I'm going to navigate into my downloads where I see that private key that I created. So to use this, I need to do chmod and 400. This gives me the correct permissions to run or use this key. And then I'll do SSH-I of that key. And then the username, which in this case is Ubuntu @ and then this IP address right here. Hit enter, and I'll see something like this. So I'll go ahead and say yes, because my computer, this local machine, has never connected here. So I'm just letting it know that this is okay, we can connect here. And so it adds it to the hosts. And now I'm in, right? So I want to be able to repeat this process over and over again. So what I did then is I created a new workspace in VS Code. The reason for this is so that I can have the actual key and a command or a script that I can run to actually connect to my SSH itself. So the idea being is I'm going to go ahead and create a folder in here called private. And this folder will then take from my downloads. I'll go ahead and bring it on over into private, that key itself. So now I have a path as to where I'm going to leave this. And since I use Git all the time, I'll initialize a Git repo in here. You don't have to do this necessarily, but the point of me doing this is to go into my Git ignore and adding in private in here because I do not want that key accidentally put on my repo itself. Whatever public repo, I don't want to share that key whatsoever because of course it gives access to it. Next up, I'm just going to go ahead and create a file called connect.sh. With this, what I'm going to do is I'm going to go ahead and say my ssh-key.pem. That way we can all have the same key name and you can just run inside of connect.sh. And if you're on Windows, you'll do ps1. Either way, it's the same command. Again, being ssh-I. In this case, it's private / ssh-key.pem. And then that same Ubuntu @ whatever that IP address was that you got, or you could use this public DNS itself. You can use either one, and then I can actually do chmod +x and connect.sh, and then I can run connect.sh. And it's just a really easy way for me to just reconnect all the time whenever I need to this instance. And so hopefully you understand this process. If you haven't done this before, do it a few times so you get the hang of it. By doing it a few times, what I mean is you go into instances, you delete an instance, create a new one, and then run with it. You won't have to actually create the same key pair all the time. You can just use the same exact one, or you can actually import your own, which is a public key, which is also ID, often ID rsa.pub inside of your .ssh folder for your user, which this is true on Linux, Mac, and Windows. All of them by default, when you do the command of ssh-keygen, it will be stored in there by default. And you absolutely only want to use the public key itself, as it says right here, because that will be installed on your instances when you go to create a new one, which is as simple as going into launch instances, and then you can do all those settings, and then you just grab the correct key pair, and then you can just use that one over and over and over again until you really get all of this done, down and dialed, so that you can do the next part, which of course will be installing Docker. So let's go ahead and take a look at that. Now we're going to go ahead and install Docker and Docker Compose onto our EC2 instance. So the first thing is, of course, we need to start an SSH session. Then we're going to go ahead and escalate our user to the root user. Then we'll go ahead and install Docker. All of these commands are referenced on this readme.md in the repo itself, but the actual git.docker.com command, or the actual script that's available to us, is really cool. So if we come in here to our browser, we can see the actual script command itself for specifically Docker Engine, as well as Docker Compose and several other things. And it also even gives you a few different things related to actually running these installation process too. Now, I really like this install script because it works on a lot of different machines, including Ubuntu, but other kinds of Linux distributions, and it's updated from time to time. In the past, this didn't include Docker Compose. Now it does. It's fantastic. So let's go ahead and do that now. In my case, I'm already in my Ubuntu user. I'm going to elevate to root with sudo su, and this just means that I'm moving into my super user account, the root user, which is not something you can log in natively or by default within EC2. Other cloud providers allow you to go and default into root. But now I'm going to go ahead and install the Docker script itself. This is going to take a few moments to actually run and install things. Now, you might need to update your system on your own, but it actually runs update for you. So you actually don't need to run really anything else other than this to install Docker. I'll let this finish, and then we'll take a look at the results. And after a couple of minutes, it looks like it finished. I'm going to go ahead and do Docker PS, and sure enough, there it is. If I type out Docker Compose, sure enough, that works. Docker Swarm should even be in here as well if you are interested in Docker Swarm. This is not something we're going to do in this one, but the idea is that Docker is installed so we can use it, so we can start actually running our database service as we see fit, which of course is going to be our MariaDB instance using Docker Compose. Now we're going to go ahead and provision our MariaDB instance using Docker and Docker Compose. So if you actually go to hub.docker.com and look at MariaDB, you will find there's a lot of different options, a lot of things available for MariaDB. I want to keep things as simple as possible. Always remember that MariaDB is a highly compatible database with MySQL, which means that a lot of the configuration is similar to MySQL, although just slightly different. So what we're going to do then is I'm going to actually design my Docker Compose file. So I'm going to come into my travel agent here, and I'm just going to go ahead and say config, and then in here I'm going to create compose.yaml. Now, this is the new format for Docker Compose. You can always do docker-compose. I like using the new format, which is just compose.yaml. And of course, you can, if you're familiar with YAML, you can use YML as well. I like putting the A in there for some reason. Anyways, we are going to now define our Docker Compose file. So before I define anything related to it, I just want to say the image itself is going to be MariaDB : LTS. So this image, it comes directly from Docker Hub itself. And notice that we've got MariaDB here. And then if I go into tags, I can actually do a quick search for LTS, which stands for long-term support. And there it is right there. This is updated regularly, but it is the one that I want to use. It's also not incredibly big as far as a Docker image is concerned. But that's the LTS. That's the image I want to use. You can use a specific version of MariaDB if you need one. And if you search through those tags, that's how you'd go about doing it. And if you find another supported version of MariaDB or another image you want to use, you could use that as well, but just be aware that the actual image, the way you declare it, is slightly different than what I have here. So that's where this is coming from. So you can also see it inside of Docker Compose. There's that image right there. I'm literally copying that exact same thing, and I'm applying it to this configuration of image. The next thing is I want this command of restart being always. So in other words, when my virtual machine restarts, I want my Docker Compose image for MariaDB to also restart. The next thing is I'm going to go ahead and declare the ports that I want to use. It's going to be 3306 mapped to 3306. I'll go into more detail here in a little bit. And the idea here being that MariaDB and MySQL are highly compatible, so they use the same port value by default. You can change this mapping, but that's not something I'm going to do at this time. Next up, I'm going to go ahead and declare something called an env file of .env. This is where I can do additional configuration for MariaDB based off of whatever project or system that I'm working on. And then the final one is going to be the volume. I actually want long-term storage for this data so that if the container itself restarts or is deleted or something like that, hopefully the data then for the database isn't touched because it's going to be stored on the instance itself. Now, I can spend a lot of time really going into depth on how this stuff works inside of Docker and Docker Compose, but we're going to spend more time just getting this up and going. So I'm going to do services and DB, and then I'll tab this in. So DB is just an arbitrary name that I'm giving this particular service according to Docker Compose. I could call it Maria, I could call it ABC, I can call it whatever I like, but the idea being that Docker Compose has unique services in here. In other words, I can also do a web one and say something like Nginx as the image, and those are now two different services as far as Docker Compose is concerned. But again, I could call this one Nginx if I wanted to or something like that. Now, we're not going to go into Docker Compose much more than what we're doing here. So what I would need to do with this volumes is I need to actually add in something called volumes. And in this case, I just declare something. In my case, I'll just do AI-DB, and then I'll attach this into my volumes here and use the default that is available for MariaDB, which is this var lib mysql, which you could verify as well by going back into the overview of MariaDB on Docker Compose, and you can see that same exact value there. Great. And I need a colon here. So here's a now valid Docker Compose file. The reason I had all those underlines and stuff like that is because VS Code has a lot of different plugins to make sure you're doing these things correctly. And of course, this is now going to be referenced on the GitHub repo for this project anyway, so you could always just copy and paste this one itself. So now that I've got this, I'm going to go ahead and copy it, and I'm going to connect to my EC2 instance with my .connect.sh command, which of course is also just doing this right here. Then I'm going to go ahead and do sudo su, go into my root user. I'm going to create with nano compose.yaml. Once again, I'll paste everything in, and I'll use Control X and then Y, enter to actually create that. And I can do cat compose.yaml, and there's that file in there. Cool. So now that I've got this, what you might attempt to do is run Docker Compose up and then in detached mode, which means it's going to run in the background, and I can hit enter. But it says there's no such file as this .env file. Now, I referenced this .env file on purpose, and I left it out on purpose so we could create it on just the server. So in here, then, I'm going to go ahead and do first off, I want to actually discuss what's going in here, but we'll go ahead and do nano.env. And I want to add in my MariaDB root password. this is going to be the password for the root user. Now, of course, I could put ABC in here, but that's not a great password. So I'll go ahead and leave it just as $sign for right now. Then I'll use a built-in feature to Python 3. Don't worry if you don't know this feature. You can just follow along with me. What it's going to do is we're going to import secrets, and we're going to print out secrets.token_URL safe, and then some length in here. We'll hit enter. This will create a secret value for you, which I will reference in here later. So create secrets, and it's just going to be this command here, just like that. Okay, so now it's referenced in there for you. So now you can use this anytime you need to create a new secret. In our case, we only want to create this secret one time. So whatever this value is, you're going to want to store somewhere, right? So you're going to want to store it securely as much as you possibly can. So I'll go ahead and copy this, and inside of README, or rather inside of my private here, I'm going to go ahead and say this is my MariaDB-pdub, and I'll just paste that in there. And we'll go ahead and save this env file. Again, we'll use cat in there, and it's in there. Now we can go ahead and run it. This time I'm going to go ahead and again do docker compose up-d, detach mode. It's going to run in the background. So what it's doing here is it's downloading the image, or in other words, MariaDB, the packaged version of MariaDB for Docker, so that it can then run. It creates a volume. This is a persistent volume based off of the virtual machine we're using and the container itself. If I do docker ps, I can see that it is running. If I wanted to take it down, I can do docker compose down. This will actually stop the instance itself, but the volume does not go away. If I wanted to take the volume away, I would do -v. That would remove the volume and thus all the data that's stored for that database. But of course, I don't want to do that. I just want it to go up. So now that I've got that, if I do docker ps, there's one critical thing that we'll look at in the next part, which is this right here. This critical thing is actually how we can connect this EC2 instance elsewhere. This means that the EC2 instance itself, that's what this is referencing. This can be on any IP address. The actual port of 3306 will now be attached to the container itself of 3306 on this virtual machine. This becomes a lot more clear when we actually try to connect to this based off of that port value, which we'll see in just a little bit. Before I take a look at that port value, I actually want to enter into this container image with docker exe-it. This is executing an interactive terminal, that's what -it does, for this particular container ID. And then if I do bin/bash, I'll be able to actually go into that container itself. So if I list things out, I'm inside of the Docker container right now. If I do docker ps, it won't work. On my virtual machine, I can make it work, but the point of this is to use MySQL. The user is going to be root. The password is just going to be -p. I hit enter. It says enter password. I can enter the password I created. I won't see it when I copy and paste it, but then I can actually enter into MariaDB. So this shows me that my Docker container is working and it's working correctly. And we can go ahead and exit out of here, exit out of the container, exit out of my root user on the virtual machine, and then exit out of the virtual machine. So now what I need to do is actually test and connect to this instance from my local machine, which I already have MySQL installed on here, the actual client itself, so I can connect to it, which we'll do in just a moment. In this one, we're going to unpack a little bit more as to why I use Docker Compose to run my MariaDB instance. And what I'm going to do to help illustrate that is by using my local machine to connect to the virtual machine, which is running the container that has MariaDB in it. That's what I want to do. So to recap how to actually go into this manually, we first off do our SSH session, which is connect.sh. Then from there, I do sudo su, so I can be in the root user. From that root user, I can do docker ps, which we see is running a version of MariaDB. This to actually enter into this, we would do docker and then exe-it. This is executing the interactive terminal for an already running container. In this case, the container ID is right there. And then we can do bin/bash, which is just a command to go into the bash shell on that one. And now I'm inside of that container, and I can do something like mysql -- version, which is this is a command line tool to connect to MySQL. So what I did was exactly this. I used my local machine to connect to my virtual machine to then go into my container and then verify that MariaDB is working, which I did in the last one as well. So if I actually separate this out into 3 different terminal windows, this is my container running, this is my root user on the virtual machine, and this is my local machine. So my local machine has MySQL, or a client for MySQL, installed. This client we need to configure to actually connect to this, containered version of it. My virtual machine itself, well, guess what? It does not have a way to connect to MySQL by default. So the virtual machine itself is really just there to run Docker, to run the Docker containers. So those are the only runtimes that really matter as far as the virtual machine is concerned. Docker, on the other hand, will run all of the images I declare in compose.yaml, and it'll do so in a way that's really efficient and really effective. In this case, we can see that it actually runs on port 3306 on my local host, which is what my actual machine, my computer, needs to connect to. So I need to connect to that local host, right? So what is that value, right? And so that value is actually going to be given to us from EC2, the actual EC2 instance itself. So what I want to do then is I want to use mysql-h and then the host. That host is going to be back into EC2. We're going to go ahead and look at our instances that are running. We're going to grab that IP address in here. I'm going to go ahead and paste that in. I'm going to use the user of root again. And then I'm going to want to prompt for the password, which is -p. I'm going to hit enter. And then I'm going to go ahead and grab this password. And it's just going to hang. It's going to hang forever. Now, this is a security feature of EC2. What it's saying is it cannot connect to this actual port value here. So we need to update our EC2 instance to be able to do that. The way you update it is by going into your security. We've got this security group here, and more specifically, the inbound rules for this security group show me that the port of 22 is available to any source. We need to modify this so that what port? 3306 also is available. So I go into these security groups here. I look at inbound rules. I'm going to go ahead and edit them. I'm going to add a rule. And in here, we can navigate down to MySQL, which defaults to 3306. Then I can use the exact same 000s to allow any connection here. In production, we probably won't want to allow any connection here. But while we're learning and while we end up using MindsDB, using any connection here makes it really, really easy on us. I'm going to go ahead and save these rules. This should take only a moment or so to end up working. I'm going to attempt to connect as well. And what do you know? Now I did exactly what I just said a little bit ago, where it was going from local machine to VM to container to MariaDB. Now, even if your local machine doesn't have the MySQL client, this should now work with any other kind of MySQL client. In this case, it's a different client than what I did inside of the container, right? Just slightly different, but different nonetheless, because MariaDB is highly compatible with MySQL, which is why you're seeing all the MySQL stuff here. So now we can actually fully connect to our MySQL instance so we can start using it in other cases. And all of this has to do with that security group there. If you do not have that security group, you will not be able to connect to it. And the reason that that port even works has to do with what we did with Docker Compose specifically. So this port right here is mapped directly to this port on our instance. So this is all about our instance. 3306 is our internal port. So if you were to change it or wanted to change it, and let's say you change it to 3301, this is a nice security measure because 3306 is well known to be a MySQL or MariaDB port. So if you change it to 3301, it would change, you would need to do it where it would change this value as well, and this value as well as 3301, where the container itself is still 3306. It's still running off of that same container port. Thus, very little additional configuration for MariaDB to have to happen just to change the port, right? It's pretty nice. I think so, at least. All right, so that's Docker Compose. Of course, if you have questions on it, let me know. If you can't connect to it in the future videos, it will likely come back to this one, and this is probably why. Something with the ports or the security groups that is not working correctly, or it's also possible that your actual container image is not running, which you can verify with Docker PS, and then you can also bring it back up with Docker Compose up and that detach mode. In my case, it's still running, so I didn't have to change anything. For working with all kinds of data and data sets, we're going to be using an interactive environment called Jupyter Notebooks. Now, the idea here is very similar to just a normal programming, but we can actually just execute small blocks of code instead of the entire thing over and over again. So that's why we use Jupyter, as we'll see in the next part. But we need to configure it first, which means that we need to download Python. So if you go to python.org/downloads, you're going to want to download Python 3.10 and above. In this case, 3.11 is available. So once you just click this button and download it, you should be good to go. If you're on Linux, Python 3.8 will probably work. But as you may have noticed, when we used the EC2 Instance version of Python 3, it was using Ubuntu. It was already installed. So you don't necessarily have to install it on Linux. But the idea being is you'll open up your command line, whether it's terminal or PowerShell, and you just want to verify that you have Python installed. And of course, if you're on Windows, it's going to be more like the absolute path to the Python executable that you would use to grab whatever Python version that you're using. Once you have that executable, whether it's Python 3 or the actual path to it, or it's Python 3.10 or whatever, once you have that executable, we want to use that to create a virtual environment in the root of our project. So we'll do Python 3-m venv venv. Again, if you're on Windows, you will use this instead of this or whatever your path is to python.exe. You'll create that virtual environment in the same way. What this will do is just help isolate your Python projects from each other and from your system at large. It's right away, once you do that, you want to add venv to your gitignore file, just like that, so it's not actually accidentally added into GitHub or anything like that. So what I want to do here is use venv/bin/activate, right? So I want to activate this virtual environment, which is how I do it with actually a source venv bin activate. And then if you're on Windows, it's ./scripts/activate, just like that. And then we're going to go ahead and use this version of Python without any paths or any numbers. It's just Python. And now will be the virtual environment version of Python, which is what we used to configure it. So with this, we'll go ahead and do Python-m pip install pip --upgrade. This is upgrading the Python package installer. And in here, I'll go ahead and create requirements.txt. The first requirement I need is simply Jupyter. We'll also be using FastAPI, we'll use Pandas, we might use Dask, which is a lot like Pandas, just slightly different and really good for big data sets. We'll use Python Decouple for env variables and a few other things related to SQL and MariaDB with the MySQL client, UVacorn for FastAPI, and Jinja for FastAPI as well, the web application backend. But first, we just want to start with Jupyter. So I'll go ahead and install this with Python-m pip install-r requirements.txt, hit enter, and things will start to install. Now, if you're a beginner, what I just did was way too fast. If you're really experienced with this, what I just did is way too slow. I try to land in the middle there just to make sure that we all are on the same page as far as what requirements we need for the Python side of things. At this time, it's really just Jupyter. We don't necessarily need all of these things. We could add them as we need them, but we will need them eventually, so I just added them now. Next up, what we're gonna do is actually activate or make sure Jupyter is working. So to do this, I'm gonna create a new folder here. I already have it on mine, but I'm gonna go ahead and recreate it as simply notebooks. And this is where I'm gonna store all of my interactive notebooks. And so to run Jupyter, we have a few different options. First off, we can just say Jupyter Notebook. And if your virtual environment is activated, that will generally work. If it's not activated, something like deactivate, you'll have to go ahead and do venv bin/Jupyter. That's another way to get this version of Jupyter. Or we can do venv bin python-m Jupyter and then notebook. The last one is almost certainly going to use the virtual environment version of Python and Jupyter, which is what I actually want. So it's only using these packages in my requirements.txt. So I'm going to go ahead and run that now. And this, of course, will start up that interactive terminal for me. I'll navigate into the notebooks folder. I'll go ahead and create a new notebook in here. And I just want to call this verify Python. And what I want to do here is in this cell, I'm going to go ahead and be able to write my interactive code here. I'm going to put an exclamation mark, type out just Python, and then do -- version and hit Shift Enter to run this command. If I'm getting this command not found, that's not a good sign. Next up, I want to go ahead and do pip freeze and run that again. And I see that there's probably things in here that aren't related to the actual virtual environment notebook that I want to use. So I'm going to go ahead and close this whole terminal out. I'll go ahead and say yes. And what I want to do now is activate that virtual environment. So source venv and then bin/activate. And now do python-m Jupyter notebook. Run that again. In this case, I'm going to refresh this notebook here that I just created and run this again. This time it actually shows me the correct version of Python from the virtual environment. And then if I do pip freeze here, so python-m pip freeze and run that, I should see the things that are related to this virtual environment as well. Now, the only reason I show you this stuff is because every once in a while, when you're not using Jupyter correctly, you get the wrong package, it's working in the wrong place, something, so on and so forth. A lot of issues can come up. So you want to just make sure that you're using the correct Python and the correct virtual environment and the correct Jupyter notebook, which is easily done by activating the virtual environment and then running the commands as we just did. So with this in mind, let's go ahead and actually load our data set into our MariaDB. Now we're going to implement a way to use Python Decouple to load a .env file into a Jupyter notebook. The idea is very similar to like what we already did with Docker Compose when we were loading in that .env file to actually configure our MariaDB and more specifically the password to it. So the idea goes like this. We go into the root of our project here and create a .env file here. Right away, make sure it's in gitignore, because this is going to be sensitive information we do not want to share. And the value I'm going to set is simply database_URL. This is a very common variable name, environment variable name for Python applications for database URLs. It's also common for Node.js applications. This is a very common syntax for it. And as you recall, MariaDB is highly compatible with MySQL. So sometimes you'll see it written out like this, where it's MariaDB : username : password @ IP address, and then sometimes /db name, something like that. And perhaps these are going to be changed slightly. And so I'm going to go ahead and comment this out and paste below and actually change it to what I think is more commonly used as MySQL. Again, MariaDB is highly compatible with it. MySQL for some packages has a little bit more support natively than MariaDB does because they know that MariaDB works essentially the same way with authentication. So we need a few things to fill out here. First off, the username. What is the username? Well, it's actually root. It's not the Ubuntu username that we logged in to configure Compose and all that, but rather what we used with MariaDB and this env file. We used the default. All we really set was the password, and that password was for the root user. Yes, you can make this more advanced and more secure by not using the root user, but we are just trying to get things up and going. You can always improve later as far as how the users are going to be used. Next, of course, is that password. So once again, I'm going to be using that password. Right now, this password is considered exposed because it's in this env file. This private folder, I probably wouldn't actually keep very long, or at least the password itself. But now that we've got our user and password, we need to update our IP address. And so, of course, to get that, we go into EC2. And of course, to get that, we go back into EC2 and grab that IP address. It actually could be the domain name or the DNS value as well. It does not have to be an IP address. So there we go. We bring that in, and this DB name, I'm actually going to leave out for right now. That's not something we need just yet, which I'll show you why in a moment. So now that we've got this env file inside of my notebooks folder here, I'm going to create a Python module called env.py. This is where I'm actually going to reference this env file and load it in using Python Decouple. So if you actually went into the Python Decouple documentation, what I'm about to do is not really that obvious, which is why I'm showing you how to do it. So the first thing is I need to actually navigate Python to know where .env file is. Now, of course, I can actually copy the absolute path and say my env file is at that path, but unfortunately that only works for my system. And it may work on your system if your user is CFE as well and you have all these things the same. But instead what we want to do is use Python pathlib. So what pathlib allows us to do is to use very similar paths but related to the project itself. So the first thing I want to do is set up our base directory, which is going to be pathlib.path of this file. This right here is going to equate to this. And of course, it's going to be slightly different for yours, but it's going to equate directly to that file path for that particular file, the env file. If I do .parent, this will then remove that and go to the notebooks folder, which is close. But then if I do .parent again, that will be the root of my project itself. And that's the path where my env file lives. So what I actually want to do is call this env file and path and set that equal to, instead of this whole string here, that base.slash. This works cross-platform. So if I sent this to you and you had it set up in the same way, whereas in the notebooks file and you've got an env file right there, this will work just like I'm about to do. So the next thing I like to do is define a method called getConfig. And the idea here is we want it to return the new config variable itself. So what python.env has is an import that we can do is like from decouple, we can import config, and then I can return it. So right now I'm actually not doing anything different here. And I'm also not using this env file, but I'm really not doing anything different, which in many ways, this is just the default. So I'm going to import config as underscore default config or decouple config. Either term works. And so the reason for this is so now I can actually say, grab this file path and say, if this exists, because it might not, then I'll go ahead and return something related to decouple and all that. So that's going to be this import right here. From decouple, we get config and repository env, and then we just use something like this right there. This and this are almost equivalent, except this one we have a specific env file path based on whether or not it exists. So with this in mind, we can now grab this configuration variable and just verify it. So let's go ahead and open up our Jupyter notebook. Let's make sure it's still running. If I refresh in here, looks like it's still running. I'm going to go ahead and create a new notebook, and we'll just call this verify env, or rather verify.env. And we'll go ahead and rename that. I'll go ahead and do from env import config. Now this is importing from env.py. This is looking for the config variable that comes from get config, right? So that env.py. If you call this something else, it would be whatever that thing is. Cool. So with that in mind, we can now say our database URL equals to config of that value, whatever that value is in the .env file. And we typically set a default in here as well, which you can set to none. And then I run it, and there is that value. So right now, this is also exposed in the notebook itself. So typically speaking, you just don't want that value to show up. And of course, if you need to change this value, what you do is you go into your env file and you can change that value. So if I comment out and switch them out and run it again, of course, it actually doesn't show that value. So I need to restart the kernel for this to happen. And then it'll actually show that other value that was in there. This value is fine to actually show, but I really just don't want to. So another way you could do is say if it's not none, and just use that kind of value in there instead, so that you just have some check going on with your .env. Now, you probably won't need to do this very often, but it's nice to know about it. And it's also nice to know that we have now decoupled our environment variables from our Jupyter notebook. And this same sort of env.py can be reused again if we need to. So in our FastAPI web application, we can reuse a lot of this exact same code, if not the whole thing, all over again to bring it in. And I want to just double check to make sure that I have all the imports correct and also the return values correct. Because if I do something like this, I still want it to look for the environment variables. So like when you go into production, if you were to push an application in production and you don't have a .env, but your production application has environment variables set otherwise, this would still work, is the point of that. Great. So with this in mind, let's go ahead and actually connect to our database using SQLAlchemy. Now we're going to go ahead and connect to MariaDB using SQLAlchemy. So what I want to use is my actual database URL in .env. And I'll also go ahead and say my housing data, or let's just do housing DB as the database name, right? So that's what we want to connect to. That's what we're going to start with. So let's go back into our virtual environment and also our Jupyter notebook here. I'm going to go ahead and close and shut down this verify.env, and we'll refresh in here. We don't need either one of these actually running right now, but I'll go ahead and leave them on as is. And then I'll go ahead and create a new notebook in here, and this will be connect to MariaDB via SQLAlchemy. Okay, so the idea here is several things. Number one, we need to get our database URL, and then we need to create a DB engine via SQLAlchemy, and then we just need to verify our connection. So that's kind of what we're doing here. But of course, this is not going to be as simple as you might think. First off, we are going to go ahead and do from env import config. Then we're going to go ahead and do from SQLAlchemy. We're going to import create engine and text. So the first one is one we've already seen, which is going to be our database URL, and that's going to be equal to config of the database URL, and the default being none. And all I want to do here is I want to verify that the database is not none. So database is not none, or the database URL is. Great. Then what I want to do is create my engine. So we'll do engine, and this is create engine from this database URL. And one of the things you might need to do is you might need to cast this as an str value, right? So if you run this again, this will ensure that this is cast as a string. Worst case scenario, you put it in as a Python string as well. So you can do both of those things. You can also cast stuff as like a Boolean value, for example, but that's not something we're going to do right now because it's not necessary in this case. Okay, so I'm going to go ahead and create this engine here. And what I want to do is create a session, just a really simple connection session to, well, just kind of select something in our database. So I'll go ahead and do with engine.connect, and I'll do as connection or as con, and we'll go ahead and hit enter underneath here, and then we'll do con.execute, and this is where I can write some SQL. So what I want to do here is, well, let's just go ahead and say I want to, let's create a new database. So we'll go ahead and do create database, and we'll call this a DB name. So I'll use some Python string substitution in here, and I'll put my DB name up here as in housing DB. Now remember, my database URL itself already has housing DB in there. So let's see what happens with this command. We'll go ahead and run it, and I get an error. Right? So if I scroll down a bit, what I get is I get unknown database housing DB. So the question is, where is this coming from? Well, I already know where it's coming from, so let's go ahead and just change this to housing DB2. Run it again. I should get that exact same error, housing DB unknown. And that's because I actually never created this database. So I'm going to go ahead and get rid of that database in there and just connect directly to no database, basically. Just have an open connection, and we'll go ahead and restart our kernel and run all cells with the new housing DB database name. And so what this will do is it will now show me, create database housing DB. It's not an executable object. This has to do with how the string is generated here. So we just turn it into a SQL text command, and there we go. Now, SQLAlchemy has a lot of nuances about it to work with SQL. We're not going to be spending a lot of time with SQLAlchemy. So if this part was a little tricky or confusing, that's okay. This is just a way to create a bunch of different databases. So we can also create one for our prices. Like, let's say, for instance, I'll go ahead and copy this again, and we'll go ahead and call this our AI travel prices. Yeah, something like that. And I'll go ahead and give this DB name too, and this will create that one. Now we can also drop these databases as well. So we can go and instead of create, we can drop this, and we run it again. That will actually drop that database in there as well. And of course I can run other SQL commands. So if I paste in here, let's get rid of this DB name here, and I do like something like show databases, like that, I can run that and it executes. There's no error, but it doesn't give me anything back. So I can also say results equal to that, and then I can print out results dot all and run that, and that shows me all of the different results that are coming in here. So really, if I wanted that travel database back and run it again, there it is again. And if I drop it again and run it again, it's gone again. Of course, it deletes everything that's inside of that database. So you probably aren't going to want to run, create, and drop database very often, but it is something that you absolutely can do. And so the reason to just show you this is that, yes, you can execute raw SQL itself. Generally speaking, you probably don't want users to have access to this. Theoretically, you could have a user be able to execute these same sort of commands, but realistically, you wouldn't want to have that happen unless it's their database, unless they're supplying a database to you and you're managing it for them. You don't want to have raw SQL being run on your databases pretty much ever. That could cause a lot of problems, including dropping and creating databases. So now that we have this done, we're going to go ahead and copy this same notebook and be able to actually load in a database directly from Pandas, or rather a database table directly from Pandas now that we've got a few of these in here. So let's just make sure that we don't drop this AI travel prices data set or the housing data set. We want to get the error of that it already exists on both of these, which is what we'll use in just a moment. One of the goals of this series is to help you find a data set, load it into a cloud database. In our case, it's the MariaDB instance running on EC2, then decide what kind of AI analysis you want to do. So the analysis itself, we don't actually have to do. We'll let the AI do it because of MindsDB. That's exactly what it does, and it does it very well. Now, in this case, we're going to be using a pre-existing tutorial that they have as a way to kind of jump into MindsDB and show you how practical it can be to just reiterate this process. So one of the things that you need to be aware of is when you are selecting a data set, what is it good for in terms of the AI analysis? Whenever you see time series, It usually means do forecasting. It usually means take the historical data, the data that happened over time, to then guess what's gonna happen. That's what time series and forecasting is all about. Whether that's sales, whether that's inventory levels, anything like that. Now we could also use this data to do something called classification. I'll explain that in just a second. But if we actually look at the data set itself and scroll down here a little bit, we see that we've got a sales date and it changes over time. So this means that that data changes over time, thus is time series. But if I didn't have that data set, let's say for instance, I just hid that data set. Let me hide it right there. And all I had was these three columns, the moving average, the type, the bedrooms. Then I could use that same data to predict what kind of category we want to assign to these things. So I'd have to make a new column with category type. Maybe we say it's expensive, we say it's a medium price, we say it's cheap. That would be the categories that we would do, and then it would be a classification problem because we wouldn't have that date anymore. But of course we do have that date, so that's what we're going to be working off of, and it also ties in really well with a pre-existing tutorial that MindsDB has. So if you get stuck at all, you can always go through that tutorial. So let's go ahead and download this data set now and load it in. So to do this, of course, you can copy this link right here, or you could go to the repo, look for the data sets itself, and then go to that link. That will bring you right here. Now, of course, if you don't have a Kaggle account, I highly encourage you to get one so you can download this data set, but also you can find many, many other data sets. And so let's go ahead and download this data set here, and we'll go ahead and unzip it. Let's open it up. Here it is unzipped. The main one I need is MA underscore and the rest. We do not need the raw sales, although you could try out the raw sales. That might be something you try out. The raw sales have more granular timestamps. The MALGA one is really just for quarterly sales and just to keep things simple for us. So I'm actually going to go ahead and drag this on over here, and I'm going to rename this my housing dataset or housing DS just to make it simple for me. Again, same exact data, same columns, all of that stuff. Cool. So now that we've got a data set, let's go ahead and make sure that our Jupyter Notebook server is running still. In my case, it is. Here it is right here. But even if it's not, let's go ahead and just run it again. Again, with the virtual environment activated, I'll just run Jupyter Notebook, and then that will open up my home here. And then I can go into my notebooks and we'll go ahead and we want to actually duplicate the connect to MariaDB because we will be connecting as well. And this time I'm going to go ahead and call this, let's rename it to load house data to MariaDB via Pandas. Cool. So let's go ahead and open this one up. And what we'll have is a lot of the same things that we had before. Now, I actually want to be able to access that data set, so I'm going to bring in base dir from my env, and I can just verify that. Let's go ahead and run a few cells here with Shift-Enter like before. This time, I'm just going to show base dir, and I don't need these other ones, so I can just select them and hit DD, and that will delete them. So I've got this base directory here. What I need is my data set dir, and that's going to be equal to that base directory / and data sets. And then we can go ahead and say whether or not it exists. In this case, it does. Then we want to get the actual data set itself. So I'll go ahead and copy this relative path here. And it's really just to get the name of the data set. So we'll go ahead and do the housing or house CSV, and I'll go ahead and do dataset dir / housing CFE, and we'll do exists again, and we'll hit enter. Of course, if you didn't download it and you don't have it actually in this correct location with the right name, this will say false, which will give us indication on whether or not we want to use it. So the idea here is I want to import pandas, so we'll go ahead and import pandas as PD. Now, if you're not familiar with pandas, what it does is it allows us to analyze data sets or CSV files or Excel files right inside of Python, and it really makes it easy inside of Jupyter. So think of this as kind of like Excel for Python. It's not Excel for Python, but it's a lot like that. It can take a look at a lot of different data sets in this way. So to actually read the CFV file, we're going to set it to the variable of df. This is very common with pandas. We're going to do pd.read_csv, and then we grab the path itself. Now, in some cases, some Python packages, whenever you use pathlib, you want to just put the string around it just to make sure that it is a string. And then once I have that loaded in, I'm going to do pd.head, and I'm going to get the first 10 rows in here. So I load this, and there we go. I can now see this data. It's the same data that we just looked at, but the idea being that we have the columns declared in here, and then we've got rows in here. And then what Pandas does, it also adds a index column here, which is not something you necessarily need. So we've got this data in here. It's ready to go. What I need to do then is use this engine here to load this data into my database. And that's it. So to do this, we do df.toSQL, and we're going to go ahead and grab a table name. So in my case, I'll call this my Kaggle house data. And then I'll go ahead and grab the engine itself, which is going to be connected to our database URL. And then I'm going to go ahead and say if exists, we're going to replace this data. This is just so I don't have any issues whatsoever with adding this data in. You could always append this data, but in my case, I do not want to append it. I just want this data set. This is the only one that I want. And then I'll also go ahead and say index being false. So if I did this correctly, this will load this data into this table on the correct database. If I run this, I think I'll run into an error. So I'll scroll down here, and it says like, I don't even see what the error is really. But I do know what the error is based off of something that we'll talk about in just a second. Yeah, so it doesn't give me a very good output as far as what the error is. But I know what the error is, and it's related to the database URL, and more specifically, the database that we chose. So if we actually look back into when we first connected to MariaDB, what we did was we actually created a database here, and we created a database here. Those databases were created on purpose so that we could use them in this case. So going back into our .env file, I've got this database URL here, but it does not have a database name. So I'm going to go ahead and actually use one of those database names now. And so we could also just call this our housing database URL, just to make it a little bit different than the one we're going to use in the end, which is going to be different, and we'll address that later. But I'll call this the housing database URL. We'll save that and go back into our load house data in here. Now the configuration will be the housing database URL. We're going to go ahead and restart this kernel because we need to reload that data in, and then I can run all of the cells. I can do it one by one just to make sure everything is looking good. So far, so good. Now I'll go ahead and create this table. To be a little bit more explicit, we can go ahead and say table name equals to this table here. And there we go. And we'll run that again. This time we get all of those records coming in. It's not very many records, but it is a number of records anyway. And what I want to do is actually run that connection again and just verify that there are rows in there from the table using SQLAlchemy again. So we'll go ahead and do with engine.connect as the con or the connection. Then we'll hit enter, con.execute. And once again, we want to do text, and then it's going to be an F string select all from our table name. So that's why I also declared the table name there. And I'll go ahead and do limit of 10, and we'll close off the string as well as the connection. And we'll do results equals to that. And then I just want to print out the results.all. Run that again. There's the same exact data from our database as well. We can just verify that with the first row here. We got that first row, everything looks the same. Cool. So in this case, we now have this data set loaded into MariaDB, and it's ready to be used. Of course, we can repeat this process, and we will for other data sets as well. But notice that I have very little understanding of pandas from this. I just know that I can read a CSV file, and then I can dump it into a database with those 2 lines or those 3 lines, whatever. The idea being that it's really, really simple to do this. Now, if you get a data set that's super, super big, Pandas is not going to be what you'll use. You'll use something like Dask, because Dask can actually chunk these things quite a bit. When I mean super big, I mean tens of thousands of rows, probably even just millions of rows. In this case, we had 347. Now, there is one other check that you might want to know about in terms of Pandas itself is df.shape. What this will show us is the number of rows, that's this first one, and then the number of columns. The reason there's 4 columns is because of these 4 columns right here, not because of the index column. That doesn't actually count in here. So another way to think of this is rows and columns, and we just can print those things out as well. Cool. Same data, but Pandas has a lot of features that I'm just not even going to be covering because the analysis is going to be done with MindsDB and AI. Let's take a look. Now we're going to go ahead and create a new MariaDB user. This user will have very specific permissions to the various databases that we've created, and then also have the ability to create new databases. Now, of course, this is going to help secure our MariaDB instance more than just giving away the root user and the root user password, which can just create new users, new databases. You can do everything. So generally speaking, when I have new services connecting to my database, it's always a good idea to create a new user for that specific service, whether it's a web application or it's a third-party service like MindsDB. So let's go ahead and make our new user now. Going back into Jupyter, I still have it running. I'm going to go ahead and duplicate my connect to MariaDB, and I'll just call this create MariaDB users. And we'll go ahead and open this one up. And so what I need here is definitely this database URL, which is the root user, and it goes into the root of the database. It doesn't go into a specific database like we saw before. So I definitely need that. We're going to create an engine, and then we're going to connect and do a number of things related to this. So we don't need the database name, and I probably don't need it. Actually, we do want the database name. So we'll go ahead and say DBs equals to, and I want to have the list of databases that I want to give permission to. So those are the 2 databases right there. Okay, great. And then I'll go ahead and delete these other things with DD. And we can still show those databases as well if need be. Okay, so with this, we've got our databases. Next up, we're going to go ahead and do our new username. And this is going to be simply MindsDB. And then we also want a new password. Now for this one, I'm going to go ahead and bring in another import directly from Python. It's going to be from getPass. We're going to import the getPass prompt. And so with that, I will actually put these above here like this. Okay, so let's go ahead and do a few imports here. And so it's going to automatically look for a password for me. So I actually need to create a new password. So I'll open up Terminal. And I'm in my root. It doesn't actually matter where I am, but I'm in the downloads right now. I'm going to run Python 3-C, import secrets, and then print secrets.token URL safe 32. For those of you paying attention, this is the exact same command I used before to create the other secret. So I'm going to go ahead and bring this in here and save it. That is the new password. I'm not going to touch it just yet, but I will go back into my repo, and now I'll go ahead and say MariaDB MindsDB user pdub, and just paste this in here just to make sure that I've got it, right? Cool. Now that I've got this, let's go ahead and come back and do the different actual SQL queries we'll need. The first one is our create user SQL, which is going to be a string. Just like before, this is going to be simply create user, and then it's going to be our new username. Okay. And then what we do is we want to wrap it into a string here, a single quoted string at, and then we will go ahead and allow it to be on any host, right? So create user at any host. It could be any value here. Typically speaking, you'll see something like localhost, but we'll leave it in as any value. and then identified by also single strings, and then closing it off with a double string. And this is going to be our new password. Okay, so there is the SQL we want to execute. So I'll go ahead and execute it like that. Okay, so before I go any further, I want to also create permission to each one of these databases. So I'll go ahead and do for DB in DBs. Then I'll go ahead and say DB SQL perms equals to, again, another string. We'll do grant all privileges on, and this time it's going to be our DB dot all. So what this is going to do is it's going to be the database that we created and all of the tables associated to it. And then we'll go ahead and do to, and it's going to be the same user connection right here. So username at with that percent sign on there with all of those single quotes as well. And so once again, we will go ahead and execute this string here. We'll put a semicolon at the end of this just to make sure it is valid SQL. And that should do both databases because it's looping through each one. Next up, we're going to go ahead and grant it, or say we'll do DB SQL new DBs. And this is going to be grant create on star dot star to, once again, that same user with those double quotes at the end. And then we will execute that one as well. And then the final one is just to flush all of these permissions. So we'll do con.execute and text, and then flush privileges, which just updates the privileges on the database. Okay, so there we go. Creating a user, granting all permissions, and then allowing the user to create new databases. We don't need to grant additional permissions. So in other words, if a user creates a database, they have permission to that database. That's what's happening here. So I don't have to continuously grant new permissions to them if they create a new database. So with this in mind, let's go ahead and run it. And it looks like I have a parentheses missing at the end here. And there we go. So now we have this new user with access to these database information. And there's my databases. So these two actually do exist in here. And of course, if I try to run this again, I'll get an error because this user already exists, right? And it also shows that error, which is not great. I wish it didn't, but it does. So all I'm going to do here is I'm going to restart the kernel and clear out the outputs so that that is not in there any longer. Great. So with this in mind, we now have a new user, a new password, and that user have access to these various databases. So we can actually check this one more time by changing the database URL or just start integrating it into MindsDB, which is what I want to do. Now we're going to go ahead and integrate MariaDB with MindsDB. To do this, jump into mindsdb.com, click on Getting Started, and just create a free account. Once you create that account and you log in, you'll see something like this. Go ahead and stick with that demo version. Yes, you can absolutely do an open source one. The demo one I have found to be pretty easy to use and a quick way to get up and going. But overall, the way that it works, whether it's the demo or the self-hosted version, is essentially the same. I've just had better luck with the cloud managed version and this free demo version. And so now we're in the MindsDB cloud editor. So what we're going to be doing in here is we're going to write a bunch of SQL commands. Now, if you're not familiar with SQL, it's okay. Most of what we're going to be doing here is really basic SQL, and it's not a whole lot different than what we've already done with creating our user and granting privileges and all that. So what we want to start with is we want to create our data integration connection or a data source. So if we click on add here, we see new data source. I'm going to go ahead and click on that, and then I'll do a quick search for MariaDB. I click on this, and we've got a bunch of different things in here. So what you might notice is the name of our connection. This is going to be specific to MindsDB, the database name, the actual database we want to connect to with MariaDB, the host, in our case it's going to be the IP address, as we'll see, the port, this should look familiar, username and password, what do you know? We just created a brand new username and password. And then we also see these IP whitelist, these static IPs here for MindsDB. We'll talk about that in a moment too. Now, first off, we're going to name our connection. This one, I'm going to call it Housing Prices Con, or the Housing Prices Connection, right? So that's really the idea here. I use those underscores there based off of the syntax we'll use in a moment. Next up is the database name. Now, if you don't remember what it is, you could always go back into your Jupyter notebook and take a look at the DBs here. Or, of course, you could run the connection itself and then just show all of your databases so you can see all of the various ones there. So in our case, the actual database itself is HousingDB. So there we go. We've got HousingDB here. This is not the same thing as the database table, as we'll see shortly. Next up is the host. We'll find this value in our EC2 instance. Of course, it's specifically the IP address. The port, we never changed it, so it should be 3306. The username is directly correlated to the user we created in that recent one. So we'll go ahead and grab that username. And then this password, in my case, I stored as a document, just a blank document here that I will never check in, just so I can reference it later and test this connection out. And there we go. So we are connected. And it's specifically to this database, as we'll see right now. So I'll go ahead and save it. Don't worry, I'll talk about those IP addresses in just a moment. What you see here is this MariaDB here and our housing prices connection, and then the table of Kaggle house data. Look at this. We have a command right there. That is a SQL command I can copy and I could paste it in here, and I can run Shift Enter to actually run that single line, that single SQL command. And there is all of that data and the same number of rows as before. So now that we've got this, we might as well add in our other database as well, which I actually don't have yet, but we can still add in. I don't have a table yet, but I do have the database itself. So we'll go ahead and add another source here, and we'll do MariaDB. This time it's going to be AI agent, or let's call it AI travel agent, so it's not confusing. The database name itself, again, we had it here, AI travel prices. There's our database name. Once again, we'll get that same IP address itself, and we'll go here. And then the username is, once again, MindsDB. And then I think I still have that other password. No, I do not have it copied. So let's go ahead and copy it, paste it in here, test connection. This time it failed here. So I got MindsDB. So we test it again, successful. And of course, if that connection didn't work, your user was probably not created correctly. Maybe you have the wrong password or something like that. In that case, try out the root user and just see if that ends up connecting. Because if it does, then you can just go back to this notebook and run through it again. Now, these IP addresses, this whitelist here is really important as well. This is another potential as to why you might not be able to connect based off of what you put for your IP addresses for this port. Now, that comes directly from EC2, and it might cause a little bit of an issue because it's not painfully obvious where to white label your various IP addresses. How would you go about doing it? Well, if you scroll down to security and you see this security groups here, I can actually select this security groups and I can edit my inbound rules, and I can add a new rule in here for the MySQL one. So if we go down to MySQL and Aurora, this is where I can actually add in those IPs. So I can come in here, add this IP in, and this is going to give me all of them. So we would do one at a time. Let's go ahead and get rid of that. All three of them. And then we could do 32. And then you repeat this process for each one, and then that would grant access to it. Now, the reason I didn't have to do that is because I have this 0000 that allows anything to access it as you see fit, right? But of course, if you didn't have all those zeros, then you would have to add in the IP addresses one by one and then test that connection again, in which case you should be able to connect just fine and be able to come back in here. And so now back into my queries here, I can actually look inside, and now I have both different databases and their relevant tables, if there are relevant tables. In this case, I only have one relevant table, but it is in there. Okay, so there is one more thing that you might accidentally do. I know you might accidentally do it because I've done it many different times. So when you come in here, you name your connection, you might be like, oh, my EC2 instance, something like that. And then the database name, once again, you would use one of the database names like AI travel prices, and then you would use the IP address in here. Let's go back into our EC2 instance and grab that IP address. And there it is. Okay, IP address, my MindsDB user, and then that same password again, and test connection. Everything should be good to go. I hit save and continue, and then I look in my MindsDB, database connections, and I see it says EC2 instance, which is fine, but it's also not great. So I don't want this EC2 instance here. So to get rid of it, we can just do drop database and use those backticks, EC2 instance, backticks again. That would allow me to get rid of ones with spaces in it. And then I can hit shift enter right there. And that should delete that single line, that misnamed one. And we just use underscores from now on so that we can, hit show databases and it will show all of the different MindsDB databases, right? This is definitely different. The way this is named is different than how our actual database works. But it's close. It's very similar. But how I named it was just the connection inside of MindsDB, which definitely tripped me up a little bit. But now that we've got this, we have a way to start working with this data, which is exactly what we want to do. Let's get started right now. In a moment, we're going to go ahead and create a forecasting model with MindsDB. But before we do, let's review the data a little bit. So in here, I'm going to go ahead and grab that selector command that we've seen before. If you don't have a new query, you can always open up a new one and just paste that in. You can discard the old ones as you see fit. And so I'm going to go ahead and run this with shift enter. And of course, that will give me a bunch of data back. Now I can run all sorts of SQL commands in here, something like limit being 10, which will only give me back 10 items, right? What I could also do in here is something like order by, and then the column name that I want to order it by. In this case, we have sale date. I go ahead and run that, and I see something a little strange. I see that it says 2007, which seems okay, but then we have a big leap to 2008, and it's basically the same data. It's still happening in June, which it shouldn't be. This should be quarterly data, so I should have a bunch of lines for 2007. And if I scroll down, I still see some peculiar ordering. If I go to the next page, not any different, then I see 2007 again. That's not good. I want it to be ordered by the actual date because this is time series data. Now, there's many different ways on how we can go about solving this. How I'm going to solve it is through Pandas. So back into Jupyter, I'm going to open up this load house data to MariaDB. And we're going to come back in here and just load everything up again. And I really just want to see the data. There it is right there. Everything's looking about what I expect. But what I haven't looked at is the data types. So if I do df.dtypes, this is built directly into Pandas, shift enter, I see that my sale date is listed as an object. Now, this may or may not be what you want. In this case, it's not what I want. I want it to be an actual date. So I'm going to make a brand new column called date. And I'm going to set this equal to, well, roughly the sale date. Roughly. When I say roughly, it's going to be based off of the sale date. This would be exactly the sale date. If I want to convert this into the correct data type, I can use pd.to and underscore date time of that column. So this is just treating every line in that column as a datetime object. And then I can also pass in the format that is happening in here. And this format is based off of %d, lowercase d, / %m, lowercase m, and then %y. This format translates to the exact same format that's here. You can always look these things up. It's a very common way to format things inside of Python using datetime objects. So if I run this now, I should have no errors in here, but I'm going to go ahead and do df.dtypes now. and I see that my date is now a datetime object. Definitely different than the sale date object itself. Once again, I've got this table name. I can go ahead and run this again. This should, in theory, replace everything that was in that table originally. So now if I jump back into MindsDB and take a look at the data and run it again, I should get a new column in here for date. This time I do. And if I order it by date this time and run it, I should see much different data coming through in here. And sure enough, I do. Now, I do want to go back a page, and there we go, 2007. Looks like we've got the first quarter that's available, and then the second quarter, the third quarter, and so on. It's now ordered much better. But I also have these columns that I really just don't need anymore. I only need these columns in here. So I'm going to go ahead and get rid of these extra columns. So back into our load data set here. What I'm going to do is I'm just going to go ahead and come in right above here, and we'll say df equals to df, or let's go ahead and call this my out df. And this is going to be what we'll use in a moment. So I'll copy the current data frame, and then we'll grab the columns that we need, which is going to be date, price, type, and bedroom. And that's how we copy them, with those two brackets just like that. And bedrooms, plural. And there we go. And now I'm going to go ahead and run this again. Everything should be okay now. And so we come back into MindsDB, run this again, and this time I only have a few columns in here. Now the reason for this is we don't need all of that extra data because we need to understand what's going on with this data. First and foremost, we have multiple attributes going towards one specific key value. That key value is the price. So date, type, and bedrooms, or number of bedrooms, all of those feed into really describing the price. So in other words, these are all features of what comes to the outcome of the price. Now in data science speak, these are features of the label. The price being the label, the date being a feature, the type being a feature, the bedrooms being a feature. So we can have a lot more features in here, as you might imagine, with bedrooms or with houses especially, like if there's a pool, yes or no. If there's a big backyard, yes or no. Those sorts of things, are square footage, another one. All of those would be just general features that would then feed into the ultimate thing of the price. Now in this case, this is an average price. This is not the actual price of a 3-bedroom house, but just the average, which is fine in this case. But the point is that this data, except for the price, all describes the price. That's how we're going to create our model. Now you can review this as well on their documentation. All of these things are in here, but we just changed them to make, to me, a lot more sense than what we had before. Now we're going to go ahead and create our first model, our first predictor here. So inside of the editor, I'm going to type out create. Notice that I've got a few options in here. In this case, I want to create a model. So it gives me the syntax that I need to fill in. The model name itself, in this case, I'll do MindsDB dot house sales predictor, and that's directly coming from their documentation. The source itself is going to be our connection. That's this right here. The table that we're using is this one. So there we go. We can do that just like that. So this command is basically the same as this, but just slightly modified to fit with this create model. Next up is, what are we predicting? What's the target? What's the value that we want? Of course, that is going to be price. How are we doing it? By date. And then finally, what other features do we want to add in here that make up price? In addition to date, date is ordering it. We don't need to include date. We would just include our type and bedrooms. Right? So those two right there. Now we can go one step further in here, and that is we can add in something called a window, and I'll do 8, and then horizon, and I'll do 4. Now, once again, this is coming from their documentation, but the idea here is the window itself is going to be basically 8 rows, if you will, or 8 groups behind. What are those 8 groups? Well, remember, the dates are quarterly data. So this would be 8 quarters, which is the same thing as saying 2 years. So it's going to go back 2 years, and then it's going to project one. It's going to make a prediction for the next 1 year based off of this other data. So this is going to be our model. Let's go ahead and run it with Shift Enter. And this will take a little bit of time to happen. But what we can do is we can actually write out describe and put in the predictor. And I don't need .features, but rather just MindsDB house sales predictor. I can run that. This will describe it for me once it's done. So you might actually run into errors with actually doing this prediction because there's a lot of variables in here that could potentially go wrong. Perhaps this actual selector is incorrect. Perhaps you're using the wrong columns in here, or the wrong ordering, or the wrong grouping, or the wrong windows. A lot of those things could absolutely go wrong. But of course, if you're going with what I've been doing, it shouldn't take that long to actually make the predictor in here. And so once we describe it, we can see the completeness of it. It is incredibly accurate. I'm thinking this might be overfit to the data, but it is incredibly accurate, and it is doing stuff that, well, I didn't have to do. I didn't have to think about any of this, which is fantastic. It's now time to make a prediction based off of our previous data. So what we're going to do here is take a look at our recent data by reordering it with descending order. So we see the most recent data in this database table is 2019. Granted, that's years ago, but the idea being that that's the most recent data. It's not from 2007, as it says here. So what we want to do with this data is we want to get the recent set that sort of makes sense for the predictor. We'll actually see what this means in just a second. So that data is going to be mixed with our select, and we're going to go ahead and do select all from MindsDB dot our house sales predictor. Okay, so this is now going to be going into our model itself. This is typically declared as M. And then what we can do is we can come down and join this with our house prices in here. M as in model. And then as T as in target. And then we can do where T.date, that is, of course, the target. That's this data as .date, which is one of these, is greater than the latest data, and T.type equals to, let's say, unit, and T.bedrooms equals to, let's say, 2. And I can go ahead and run this, and what it will do is it will make a prediction for me based off of this. Now, what the prediction is 4 quarters into the future. The next quarter will be this. As we saw with this one, we saw that it was 2019, September 30th. So if we take that logic for the next quarter, it's going to be in December. So the end of that quarter is in December. And then the next one after that is April, and then July, and then October, right? So we've got a number of things in here that's going based off of that data. Granted, these aren't perfect quarters, but it's going based off of the data itself. So the idea here is now we've got all of this data coming through. So you might be wondering, why do I do as M? Well, what we could do here is we could just select the data that we want. So say, for instance, we want the price to come back. So we can do m.price, and then we could also do m.price as forecast even, which is probably the value you might want. And then we also might want to have the price being explained, or the price confidence. Right, so we've got our price confidence right here. That might be another one. So we could do price and confidence. Right, so now if I run this, I will see just those values. Right, and that might be what you want. Or you also might want to have m.date in here because you have that date, or you could do as future date or something like that. So really we're just selecting the columns that we want right here in our results, whatever those might end up being. But see, the thing is, I actually want more than 4 values in here. How do I actually make this work with more than 4 values? So what I'm going to do is I'm going to come back into my create predictor here. This is just what I named these queries, but basically going back to this query, and I'm going to go ahead and copy it again, and I'll go ahead and give this a dose, or maybe we'll say 2 years. So instead of 1 year, we'll do 2 years. We don't need to describe it yet. We'll leave that description up there as is. And change this to 2 years. And this to 2 years. Okay, so now we need to just change the horizon. We can change the horizon to 8. Maybe the window now is 12, so it goes back 3 years. So we'll go ahead and create that model, and we'll create this sales predictor of 2 years. This will take a minute to actually run. But as it's running, I'll go back into my use the predictor itself and just change the model itself in here. And then after this is done, then we'll go ahead and run this, which we'll do in just a moment. Okay, and I went back to check whether or not it was complete, and there it is. It's now complete. So I'll go ahead and give this a shot with the new predictor here, and we'll go ahead and run this now. And this should now do a prediction into the future, well into the future, and it's now predicting out 2 years for this data. And so, of course, we can change this unit to house and change this to like three bedrooms or something like that. And this gives me that forecast as well with really good confidence. So I'm guessing this is probably way overfit, but the idea being that we now have a way to train a model, adjust it a little bit, and then do some new predictions, which I think is pretty simple to do. Granted, if you don't know SQL that well, this might be a little tricky to just manipulate and modify and work around. But just the idea here is, I think, fairly straightforward. And if we can get this working on a regular basis, we could see new data coming through all the time. That is, we're doing it on a regular basis where we train a new predictor after a quarter ends, so then we can make new predictions for the future, which is so cool. So let's go ahead and get started on the new AI model. Now let's go ahead and load in our flight prices dataset. Now this is a sample dataset from a much bigger one. The much bigger one is millions of rows, which would require a lot of compute power just to do some basic analysis on it. So we want to use a sample of that data set, a much smaller sample at that, so we can do analysis, and then also our MariaDB instance doesn't need to be scaled up. Our MindsDB account doesn't need to be scaled up. We can do a lot with just what's in this flight prices sample. So let's go ahead and download that now. Of course, the link itself is in the README. It's the minimum one. It's this one right here. And that will give you this sample data set. And we will go ahead and load that in just a moment. Now, before we do, I want to mention the big difference between this data set and the previous one that we did with the house property sales is how the data is presented. The house property sales is aggregate data. We have a bunch of averages in here. We have something called a column in here was MA, moving average price, right? So it actually already did some analysis for us that we could almost plug and play and use this data set. There is one called raw sales that we could have used to come up with the same data, which is something we'll probably have to do because a lot of this data is going to be overlapping to some degree, as in the destination airport and the flight date and maybe the actual airline. Those things all might be the same because multiple people are going to fly in a plane. So we might have multiple instances of those things. So having an average might be a good idea when it comes to doing our forecasting for any given route or something like that. So we'll have a lot of stuff to talk about as far as this data set is concerned. But a big part of the reason I wanted to show you this house property sales one, because it's very much plug and play, where our new data set isn't so much that. We have to do some analysis on it before we really get some value out of it, I think. Not too much analysis, but we do have to think through things to make sure it works. Okay, so with my data set being downloaded, or hopefully it is downloaded, I'm going to go ahead and unpack it here. And there it is right here. I've got 3 different data sets, right? So they're basically the same data, but just expanded, right? So 250 has all of the other ones, and then so on and so forth. Okay, or at least it should be about that. The important part is not actually the data. The important part is that they are much smaller, thus much easier to work with, and the actual shape of the data. the columns, the way the columns are named, the rows, all of that stuff is the same, so that when we try to use this data or do analysis on it, we'll be able to fairly straightforward and easily. Okay, so now in a Jupyter, we're going to go ahead and open up our notebooks here. What I want to do is I want to duplicate this load house data, and this time we're going to rename it to being load, not house data, but rather load. It's not letting me do it there, so I'm going to open it up and we'll do load price data or flight price data. And via pandas as well. We don't need that copy there. Can leave that out. Great. Okay, so the data itself, the housing data database URL, incorrect. What we want to do also is I'm going to go ahead and open up my create or connected DB. I think we did it in here where we created the databases to connect to MariaDB. We had our housing DB. We're not going to be using that one right now. Instead, we're going to use the AI travel prices. It probably should just be called travel prices, but that's going to be the database name that we want to use. And we'll go ahead and jump into our env file here. And I'm going to go ahead and paste this one in here. And we'll go ahead and copy the same thing and we'll bring it in. And this one will be our flight prices database URL. Great. Okay, so with this in mind, let's go back into our Jupyter Notebook here, and we'll change that one. We just want to make sure it's not none, which it probably will be none, potentially, depending on how quickly you ran the kernel and all that. If you have to restart the kernel, just go ahead and do that. Okay, so next thing is we've got our data sets. That's good. This is not our houses CSV anymore, but rather our flight prices CSV, and we want to just grab one of them. I'm going to start with the 50,000 one. So we'll go ahead and copy that or relative path or the name, whatever. We're going to go ahead and bring this in. And itineraries is loosely what it is, but we'll leave it in there. So I will be able to easily change this out to the other ones is the point here. Okay, so now I'm going to go ahead and run this, and we want to load in the correct data set here. Let's read it. Looks like everything's okay. The data types themselves, very odd data types in the sense that, well, we're going to need to make some changes here. This analysis we're not going to do just yet, so I'm going to go ahead and leave out some of the analysis we did previously for what we had with our other data set. And we'll just leave in our current data set as is, our outdf, the actual final data set we will also leave in as just the original one. And I'll go ahead and comment that one out. Now the table name itself is going to be our flight prices table. That's it, just flight prices, and we'll go ahead and run that. And this will take a little bit longer than the previous one, and a big part of that is when we look at the shape itself, we will be able to see just how much bigger it ends up being, right? Which is 50,000 rows, right? So it's going to take a lot longer for this to load into our database, right? And so if we didn't provision a big enough database, that might actually cause an issue for us right here as well. You would know that as soon as possible, basically. But there we go. We're able to actually see it. We've got our 50,000 rows, 27 columns. We definitely won't need all of those columns. And then I can actually do a quick, select all from that table with a limit of 10. And what do you know? There you go. That actually goes really fast. Not surprisingly, it goes really fast. The loading of the data is sort of expected to take a little while, whereas actually selecting or reading the data should be pretty quick, as we saw here. Okay, so now that we've got that, it's time to actually figure out what items are going to be features and what items are going to be labels, or what item is going to be a label for when we actually start doing our forecasting with this price data. Now we're going to go ahead and transform our flight data just slightly so that when we go to make a predictor, it makes a little bit more sense based off of the data we have. So what I want to do here is I'm going to duplicate this load data here, and we're going to open up this duplicate. You don't have to duplicate it. I'm doing it so I have different versions based off of what I'm looking for. So instead of load data, we'll go ahead and do transform flight data, and we can leave it via pandas and all that. I'm just going to get rid of this -copy1. Make sure you keep the IPython notebook there. Otherwise, you'll have some, extension problems later. But for now, I've got this. I'm going to go ahead and run these just to make sure that I'm still getting the same sort of data out with those data types. Okay, great. So I'm going to stop here for a second and be like, okay, well, what is it that I'm trying to do? At the end of the day, I want to project or guess what the total fare is going to be based off of where I start and where I'm going. That's like the key part of all of this, right? And one of the other key factors of this, especially when it comes to forecasting, is actually when that date's going to happen, when the flight is going to happen. So I now have my 4 key column values that I want to use. So the first one is we want to change our data frame, our date, the flight date into a datetime object, much like we saw before. So go ahead and do that. I probably don't need to add the format in here. We'll see in just a moment. But if I go ahead and run this, I should get the flight date in here, and that gives me that correct format. Great. So what are the columns that I want? So let's say, for instance, I'm going to go ahead and call these my group by columns. I'll explain why it's group by in a moment. And I want to go ahead and grab the flight date, the next one being the starting airport, the next one being the destination airport. Okay, so that's the group by columns. This is the data that's going to feed into what? The target column. So we'll go ahead and call this the target column, or you could call it columns as well. So we could leave it in as a list, kind of like that. So we've got our group by columns and our target columns. To make things simple, let's just call it our target column just to make it easier to identify. We have one column in this case that we're going to stick with just one. Okay, so how do I actually grab this particular data? So what I will do is I'll go ahead and say subdf equals to df.copy. And we want to grab the group by columns, of course, but we also want to grab in the target column. So all this is doing is creating a new list of the columns that I want. So we can call this our desired columns, for example, and just bring it in like that. That way we can see what this data looks like. So if I do subdf.head, I can see some of the data. And what we got right off the bat, this might not always be true, but in this case it is. Right off the bat, I've got a lot of repeating data. That's because the actual fare for each flight in this case is the same. Like I said, this is not always going to be true, right? So if we look at the tail, it is also true. So maybe it's true a lot. So what this tells me is I need to bundle this data up a lot more. I need to actually aggregate the data a lot more than I currently have. In other words, I don't want to repeat the same data over and over and over again because it's not necessary. So when I'm talking about bundling the data, this is exactly what was given to us with that house data. It's already bundled by quarter, and they did it for a very similar reason. We don't need the same data repeated over and over. What would be better is the averages, the average total fare based off of that destination in this case, right? So the starting point airport and the destination airport. So we have the average total fare. Now to do this, we actually have to group the data together, the data we're trying to average out essentially, which is why I called this group by columns. I want to group the flight date and the actual, destination or the path that this flight is going to be going on. So what this means is then in our subdf, we'll go ahead and do another one as subdf equaling to the original subdf, the subdata frame, and then we'll go ahead and do group by these group by columns. So this is just going to group all this data together. Then what we could do is we can get the target column, the one that we want to average out, by doing mean, and then we can reset the index itself. This is a Pandas thing, but that's this index value right here. You probably don't even necessarily need to reset the index because when we send it to our database, we ignore the index. So resetting the index is really just a way to look at this data a little bit better inside of our Jupyter Notebook and in Pandas in this case. So we'll go ahead and run this. And now when I reset it, I see the average price from Atlanta to Boston is now $306, right? This might be all we need. This might be all we need to make predictions. It should be all we need. So let's go ahead and start off with this. We'll make advanced versions of this in a little bit, but we'll start off with this. So we've got our subdf here. This is now going to be our df out. We also might want to see our data types. So we'll do subdf dtypes. And we just want to make sure that our flight date is a datetime object here because of when we go into our database. So now in the outdf, I can now just copy the subdf or that subdata frame. I don't need to modify it any more than that. I'm just copying it mostly to follow along with the previous format we had for loading our flight data. Notice that there's significantly less data than there was. It was 50,000, now there's 1,200. So with this grouping, we can now start to see that that main data set, hey, maybe that actually would be something we could do. Given our local performance, we might be able to update it quite a bit. Okay, so with that, I'm gonna go ahead and load it into there. I'll go ahead and run my number of columns and rows based off of my out DF now, not my original one. And there we go, so we've got 4 columns, no big deal. And I can also look things up, and there we go. Everything, hopefully, that you may have expected from this. Okay, so with this in mind, we're gonna go ahead and create our first predictor based off of really just the destination, the starting point and the destination and the total fare. So we need to keep these items in mind when we go into MindsDB. Okay, so now into MindsDB, we're gonna go ahead and look into our MariaDB instance here. We're gonna get our travel data. We've got a new database in here that we can use. So let's go ahead and open that up, and I wanna copy this in, paste it in here, and I'll go ahead and run that. And we should see all of that data coming through. And then of course we want to order it by the flight date. So we'll do order by and flight date. And we run this again. And now I've got my flight date in here coming through as we expect. So if I change it into descending order, I can now see the most recent one is going to be in April. And of course, what I see here is my total fare. It's kind of too big of a number. So I'm going to go ahead and round it to the nearest 2 digits. And this is pretty simple. So going back into our data frame here, and we're going to go ahead and look at the sub-df data frame. We'll go ahead and do sub-df, and then the actual total fare, and set that equal to the same thing, and then just round, and we can say 2 digits. And of course, we also want to drop NA if you haven't done that already. Go ahead and run that. Now you've got your total fare just being slightly different. Now, another thing that we might want to do is change the data types of starting airport, or just to make sure that when we use those, they are going to be strings. So go ahead and grab this and then do apply lambda x, and then the string of x, or rather we'll put it into a string like this, and then I'll strip it just to make sure that that's done correctly. And let's make sure we call strip, otherwise we get that weird error. And I'll go ahead and do this same thing with our destination airport. And there we go. Just cleaned up the data a little bit more. And so now with this, we'll go ahead and make sure we send it in to our database, and everything's looking better down here. The strings should be fine now if they weren't before. But now back into MindsDB, I'll go ahead and run this, and there we go. So it's just a little bit cleaned up as far as the data is concerned. We also might want to just round this to the nearest whole number. That might be something that makes it just a little bit easier to do these predictions. So I'll go ahead and round it to the nearest whole number. So we'll do 0, and there we go. And then we'll do apply lambda x and the int of x. Run that again. And there we go. So now it's just an integer instead of that float value, and int 64. Okay, great. And I'll run that again. And just verifying inside of MindsDB. And there we go. Okay, great. So what I'm going to do in just a moment is we're going to change this into our flight price predictor. Okay, and so I want to actually create the same predictor that we did before, and then we'll use it. That's something we'll do in just a moment. Now it's time to create our flight predictor model. Of course, it's going to be based off of our current columns in here. We've got our flight date, that is going to be what it's ordered by. Then we have the group by columns, which will be starting airport and destination airport. And then of course, it's going to be predicting the total fare based off of all that. Now we already have an example we can work off of in the way of our create predictor. So I'm going to go ahead and copy a number of things related to this and bring it on over. So once again, we're going to go ahead and change the name of the model. We'll call this our flight price predictor, and we will describe it in a little bit. The connection itself is going to be from the AI travel agent connection that we have right there. And then of course our flight prices, we're going to grab everything in there. The prediction is going to be that total fare. Order by is our flight date. Group by is going to be our starting airport and our destination airport. And it's not surprising that these two values are correlated to these two values, right? So and also more specifically, the group by columns as well. So now the window in horizon. Well, if we look at our data again, we actually don't have that many values that are matching. In other words, ATL in Boston, it looks like there's only one there. So we want to have a little window, a very small window. I'm going to just do 2 and the horizon being 1. I'll just predict 1 in the future. We're going to change this in a little bit, but for now, I'll go ahead and run this and we'll let this finish. This should take only a few minutes because it's not that much data, but if it takes a while, then we'll be back once it's done. Okay, so it looks like it finished. I'm going to go ahead and describe this. The accuracy is pretty high, surprisingly, but we'll go ahead and use it now using the same thing we saw before. So I'm going to grab this from our other query and we'll paste it underneath here. This time I'll go ahead and select everything just to make it a little bit easier for the viewing purposes. And of course, we'll be using our predictor model here and then our data right here, and we'll keep it as T. The actual date that we're looking at is the flight date. And then the values, the column values, are of course based off of our other column values, which is going to be our starting airport and our destination airport. So starting airport and the destination airport. Now you might not know what these values are off of the top of your head. So one of the things you could do is come back into your data frames here and just look for one. So let's go ahead and just do df dot and our destination airport column dot value counts, hit enter, and there's all of our different possible options for the destination. So you can just grab them. So I'll do ORD as one of them. Let's jump back over here. We'll do ORD as our starting airport, and then we'll do JFK as our destination airport. And we'll do a search. So this is going to be off of the latest item in here. And we've got a total fare of 2302. Fantastic. We can also set a date here. So if I do, the year 2022, April, and the 22nd. So basically greater than that, or let's do greater than the 21st. We should probably get roughly the same data, if not the exact same data. But you can definitely put the different data types in here. And I'm getting a little server error. But if I run this again, maybe it'll work now. And yeah, I get a little server error. I'm not sure why. But the idea being we can see that there are 2 fares in here that are coming through. Not sure about that server error. But now we have the prediction running. However, I want to add additional values to my data set, the actual predictor itself, with more features, right? So right now the features are minimal. So what I want to do then is I'm going to go ahead and do my drop model of this flight price predictor. We're going to drop that one because now what we want to do is go back into our transformed flight data and start adding a few things. Our recent predictor really only took into account 2 features to make up the total price. We want to have more features than that, especially when it comes to flight data. So what we want to do is jump back into our Jupyter notebook for transforming this flight data. And we're going to scroll down a bit here. And what I want to do is I want to grab my group by columns. I want to change them a little bit to add a few other items that we might want to have. Now, one of them being we have this is refundable, is nonstop. Those 2 we absolutely might want, is basic economy. Those 3 items I'm going to go ahead and bring in. So I'll go ahead and copy that and just paste them here so I can just easily bring them into my group by columns. So what this should do is make quite a few more instances of our data. So let's get rid of this now. And just to recall, before I even run it, I just want to see that I have like 1,200 rows or so. Okay. So with this new group by data, we need to make sure that we have all of this data in here. So is nonstop, is basic economy. Let's see what's going on. Oh yeah, I missed a comma in here. Let's try that again. Okay, great. So there we go. So now even just the Boston one has 3 now. It used to have only 1. So a lot more rows here. And of course, if we now bring it out, we see that it basically doubled in size just with that alone, which does change the data altogether. And it will give us better fares or better predictions for fares because we will allowed to have like additional attributes. I could say, oh, is this a refundable flight? Yes. Is it a nonstop flight? Yes. You know, we can also add in maybe the airline itself. So how this data set currently is, we've got something for segments airlines. So if it's not nonstop, it's going to have multiple airlines potentially, or at least multiple airlines written. So we could improve this quite a bit, but I'm going to leave it just as one single segment's airline name. And this should give us quite a few more, right? Because now look at our Boston ones. We have quite a few more airlines listed in here. Now, again, what I would probably do with this data set is I would separate maybe the starting airline with the final airline. The vast majority of these flights don't have 3 airlines. They don't have 3 legs that you're going to be using. And I would also argue that the vast majority of flights that do stop, that have layovers, the vast majority of them are the same exact airline for those layovers as we see here. So we could, in theory, just split this data up and only use the starting airline as a benchmark. But I'm going to use these. I'm going to use them all separate and weird like this. And that's what we're going to go off of. So with this data in mind, I'm going to go ahead and copy these columns now. And I will go ahead and run all of the things. I will output it to our MariaDB instance. Notice the data set is now much higher, almost 10,000. And then we're going to go into our actual flight price data now. We'll look at this in MindsDB. And again, we see all of these values now. So our new group by, I'm going to go ahead and do all of these things as group by. Now we don't leave them in as strings. We take them out of the strings themselves. I actually don't need the flight data in here either. But of course, we're going to group all of these together just as we did when we were creating those averages in the first place, right? Okay, cool. And the final one, segments airline name. There we go. So now our window can be quite a bit bigger. So what we can look at is all of this data here. We've got a lot from Atlanta, a lot coming in on the same day. So I think we can let's just go up to a window of 20 and horizon of 10. Actually, we'll do a window of 30 and horizon of 10 because we've got a lot more data now. So I'll go ahead and create this one, assuming that I did drop the other one. This should take a little bit longer than the last one because there's quite a bit more data. So I'll let that finish and then we'll come back. Actually, while it's still working, we can update our query here as to what we might want to have. So let's say, for instance, we want to have the is nonstop. We'll say and t.isNonstop equals to 1, as in true, and we'll leave something like that. So that's all I'm going to leave. The predictor is 40% done, so it should be done pretty soon. We'll come back once it is. All right, so after a little bit of time, a few minutes, maybe 5, we get an accuracy of 99%, which is pretty high, but let's go ahead and do a prediction now using those things. So I'm going to go ahead and run this. So ORD, I'm not even sure what airport that is, to JFK, which is in New York. We're going to see what the prediction comes out with, and it should give us 10 values here, or at least up to 10. And there it is. So we look through here. We've got nonstop values, Delta 188. So ORD must be really close to JFK. Maybe it's the other one. Let's try LAX. So LAX, this is definitely on the opposite sides of the United States. One is in Los Angeles, one is in New York. So now we've got LA to JFK, American Airlines, $440 one way. Yeah, so makes sense. And all of the American Airlines ones are about the same price. The reason it's repeating is because the dates are different. So the dates are actually changing. And they're all nonstop, which is exactly what we wanted. JetBlue, similar thing. There we go. And then every once in a while, what you'll see is nothing in there. So you'll do a search and you'll find that there are no flights happening. So let's say, for instance, let's try LAX to LAX. This is a silly search, but nobody's doing this. So it automatically already says no. But let's go ahead and try, let's look at the airports themselves again. Let's do Boston, BOS to maybe San Francisco, which is SFO. I feel like there's a flight for that, but let's go ahead and try it out. So SFO and BOS. What I'm trying to do is I'm trying to find values that are $0. And when those values come up, it really just means to me that the airline itself does not fly there. Not that there's something wrong with the model, but rather the airline doesn't do it. So there we go. So we could probably actually grab a specific airline and try it that way. But what we see here is now values that, maybe they're right, maybe they're not. But the main thing here is it's actually giving us pretty good predictions based off of what we're giving, the data that we're giving it. So, of course, the key now is being able to serve these predictions in a meaningful way. So like when a user is putting this data in, not right here, but rather somewhere else, like in our FastAPI application or just somewhere else, we want to be able to access this. Now, MindsDB has the ability to do a number of things related to this data, including inserting it into our MariaDB. But for now, what I want to do is I want to actually have the ability to just do this kind of search and work towards that so I can get a prediction based off of whatever values that are currently there, right? And so one of the other things to think about is that I would actually want to update this model fairly often, maybe not all the time, maybe daily, maybe weekly, but that way I can actually make accurate predictions based off of real data. So it's one more thing that we're going to need to get in here is more up-to-date or more current data based off of what we already have, which is still going to be like machine generated. It's going to be synthetic AI data, but it's still going to be data that gets us closer to what we'd want with real production data, which is pretty cool. So as we see here, forecasting with our own data, the tricky parts about it are the window and horizon. So if you get those numbers wrong, you might accidentally just not even build your model itself. So just play around, tinker with those themselves. And then the other part is the grouping. Of course, you need to make sure you're grouping it correctly so that it's going to the same target itself. And what I wanted to show you was two different ways on how we could get that. One that's basically ready to go, and then one we have to manipulate and change just to get there, get to a point where we can realistically use it. But now let's actually start building out like an interface for this for an actual real user. All right, so now that we have a pre-existing table in our database, we need to map that table to being a model with SQLAlchemy. Now, typically speaking, when you use SQLAlchemy, you're going to be actually creating these models first and then loading data into the database based off of those models. But we're doing it sort of in reverse because we already started with the data set. So if we actually scroll down in this transform flight data, the data we want to use is the one that's currently available in that table, that flight prices table. So we already have all of the conditions necessary to create the new table, or at least the model table in SQLAlchemy. There is one thing I want to add though, is when we go to output our data frame here, I actually want to keep the index in there. I want to bring the index back because we will end up using that value here in just a little bit. So if I run this again, I see that that's a integer value or a big integer value, something we can map in our table shortly. So what I want to do now is I'm actually going to duplicate this connect to MariaDB, and we're going to go ahead and jump into here. And I want to rename this one to generate SQLAlchemy models for MariaDB. Now we also might actually say for MariaDB and FastAPI. Great. Okay, so the main thing is, first off, our database URL, that's the incorrect one. So let's go back into our env value and grab our flight price as 1. And there we go. So we've got the engine. We do not need this database name. We do not need this database name. And we probably won't necessarily need to connect in here, but it's going to be something along these lines. So I'll go ahead and delete this one as well. Okay, so the data I'm trying to map is this right here. So I'm going to bring it in here, paste it in, and I'll comment it out. There's also another field in here called index that is a integer as well, which is what we brought back in. Okay, so with this, what I'm trying to do is I'm trying to create a class called flight price, and I want to have each one of these items in there associated or directly correlated to what's in the database already. So almost identical to this. Obviously, I'll have different declarations for them, but this is just generally the idea that we're going off of here. And we're actually going to be doing this twice. So the first one is going to be for SQLAlchemy. That's going to be this one. The next one is going to be our flight price schema, and this is going to be for Pydantic, as we'll see here in just a little bit. So to create a price here, the flight price model, we need to go ahead and bring in a few new things from Pydantic. So the first thing is going to be ORM related imports. So we already have our Alchemy create engine and text here. The text we probably no longer need because we're not going to be putting in raw text. Instead, we're going to do from SQLAlchemy.orm. We're going to import session maker and the declarative base class. Now this is newer to SQLAlchemy, the declarative base class. So if you're familiar with older versions of SQLAlchemy, this is just slightly different for declaring our base class, which is just like this with a pass. And so this is going to be the base model class that we use for our various models. Great. Next, what we need is we need a few things directly from SQLAlchemy. The first one is going to be column. Now, if you think about it, all of these values here are all associated to columns. So we can declare them as such as well. So we come in here, make them all columns. Great. The index column, I'm not going to call it index anymore. I'm going to call it ID. Okay. So we're going to call this the ID, and based off of our data, it increments each time. That's how the index values work. And that's when we actually went and reset the data, reset the index here. That made sure that that actually did happen as well. Okay. So really these are aggregate flight prices, but we'll keep it in just as flight price as far as the model is concerned for SQLAlchemy. The next thing is we need to actually bring in our table name for this. And this is a pre-existing table, which we called flight prices, which we could verify back into when we actually created it, which is this table right here. Great. Next up, I'm going to go ahead and also do something else that's an optional argument, but one that's useful, and it's table and args. And we're going to go ahead and set this to a dictionary with extend existing being true. Because this is already an existing table, we are going to extend to it based off of this. Great. So the next thing is related to each one of these columns. They all have different data types. So within Pydantic, I'll just kind of mention what those are in terms of the actual data types in Python. They're very similar to this. This one's going to be a date one, right? So we're going to do from date time, import date. This starting airport, that's going to be a string. The destination airport, string. The, is basic economy, that's a Boolean value, and so on, right? So the reason I'm putting these in here has to do with the fact that this data type we also need to declare inside of a SQLAlchemy model. So we just need to come through here and find the correct data types. So all of those are actually available in the documentation. So if we go in here, we've got a big integer one. That big integer one is going to be the first one we'll use. So coming back into our model here, we're going to bring that in, and we're going to declare this ID here as a big integer. So since it's actually not ID in the table or in the database itself, it's actually in as index, we're also going to declare that. So if you ever needed to change the names here, you would change them and then declare the table name that's in there like that. Then you declare the type it is, the data type that it is. In this case, we've got a big integer. And then I can also set primary key being true. Cool. So that should be already set as the primary key based off of keeping that index value in there and how the toSQL works inside of Pandas. Cool. So next up, we've got our flight date. This is going to be an actual date object. So what we can do is we can come in here. We've got date and date time. You could probably use either one. I'm going to stick with just date. So again, we'll go back into our generate. We'll scroll up and we'll use date. And of course, there's other ones. So I'm just going to go ahead and bring them in. Integer, string, there's float even. There's also Boolean. So integer is going to be for our total fare. Right, so our total fare was an integer object. We changed it to be an integer. Next up, the string values are going to be related to the airport and the segment's airline name. And then not stop is going to be the Boolean values. Let's make sure we close off the parentheses here. And this one, of course, is a date value. And there we go. So that's now our model. Okay. So we just need to make sure that we have all of these imports run. So we can do this again. And there we go. So this is our model. Now, why do we have this? What's the purpose of creating this in addition to what we were just using with SQL, with, Pandas, whatever? Why do we even need this one in particular? Well, a big part of it is so that we aren't doing raw SQL queries, right? So this right here, this will describe this table. Whereas this one right here will grab the results from this table. We want something very similar, but we want to be a little bit more specific on how we're doing this. And also, if we don't want certain columns in here, we don't necessarily need to bring them in. Or if we need to add new columns, we can add them here and then do different table adjustments as we see fit. But the idea is a more efficient way of querying this table than writing all the SQL queries ourselves, which can be error prone, especially if you don't know SQL that well. This also gives us a more Pythonic look at things, as we'll see right now. So the first thing is we're going to go ahead and use this session maker here. I'm going to go ahead and create a local session. So we'll just say session local equals to this session maker, and we're going to bind it to the engine itself. Okay, so that's this engine right here. And so whenever you create one of these sessions, or the actual local itself will declare a session, and then at the very end, we'll close it out. So this opens it, and this closes it. This just kind of prepares it to be open, basically. And so what I want to do is I want to query the session for this data. So to do this, I'll go ahead and say my query set is equal to session.query, the model itself or the table that we're querying. I can add in a limit, let's say for instance 10, and then I can do .all, and then I can actually iterate through each one of these items. So I can say for instance or for, kind of basically row value in query set. We can then go ahead and print out the row value and whatever that might be. So row value, like one of these values in here, I can do .id, I can do row value .flight date, and so on and so forth. And if I run that, it actually does the querying for me. And this is a lot more Pythonic than what we saw before. But of course, it's not fully prepared for FastAPI. This is really just kind of for SQLAlchemy. SQLAlchemy works on a lot of different web applications out there and a lot of different Python type tools like we're doing right now. We're using it in Jupyter. So what we need to do is we need to actually convert this data into a Pydantic schema. So a Pydantic schema gives us roughly the same data, but it makes it really turn into JSON-ready data, which is really important for FastAPI, as we'll see. But when we actually create these models, it's really nice because then I can actually change things quite a bit just really quickly without really touching the database itself. So for example, I want to change is basic economy. I'll just go ahead and come in here and just like that, and we'll say is basic. Again, more Pythonic again, and then is refundable, and then is refundable, and then and so on. right? And of course, if I change those things, I will need to change them elsewhere where I intend to use them. But the idea is hopefully very clear now. It hopefully makes things a lot easier when it comes to querying these data, depending on your background. I think the vast majority of Python users will understand this pretty well, but it also means that we're not writing a bunch of SQL over and over and over again. In the last step to prepare SQLAlchemy for FastAPI, we want to actually create a schema model using Pydantic. So make sure that you have Pydantic installed. In my case, I just added it to requirements.txt and then ran a pip install, but it probably is already in there. So what Pydantic can do is it can validate incoming data before it goes into our database. It can also serialize our outgoing data, so the data from the database, right? So that's this data right here. So instead of printing out those values, we can decide which ones we want to just serialize fairly quickly. That's a big part of what Pydantic will do for us. So we're going to go ahead and do from Pydantic. We're going to import the base model. Now, hopefully the base model and all that doesn't get things too confusing. So if it does, you can say as Pydantic base model or something like that. I don't think it should be that confusing because it's different than what we did with our base declarative base model from SQLAlchemy. And when we go into FastAPI, it's definitely going to look or be placed in a lot of different places. So we're going to go ahead and bring this in here. And I already have a bunch of stuff set up, right, that's related to the flight prices data. So I'm going to leave it as is, and I'm going to go ahead and copy this right here. We're going to paste it in. I do need one more item for my base model here, and that is going to be our class config, and that's going to be from attributes as true. This, I believe, used to be from ORM, something like that, but the idea being that this is going to be coming from our ORM, our Object Relations Manager, which of course is SQLAlchemy. So in this case, instead of printing out this row, I'm going to go ahead and say data equals to that, and then from ORM, and then it's the actual value that's coming back from the ORM. And then we're going to go ahead and print out data.json and run this. And so we get an error. So if we scroll down a bit, we see we've got a missing field that's in here, and that says flight date. So this is a validation error, and it's something that you always want to have whenever you're using data that goes into the database. You want to validate that data. So that's a big part of the reason why we use Pydantic. So not only is it allowing us to validate the data that's going out, but it would also allow us to validate the data coming in. So the data that's missing, it says flight date. So that's kind of strange, but it's not that strange if we look at the schema itself, which is flight date. And then if we look at the model itself, it's flight underscore date. So we need those things to match, right? And so now that it matches, let's go ahead and try it again. This time it actually gives me JSON data. So this JSON data is what I can actually return in FastAPI. It's already ready to do that. Now, in some cases, you might want to change everything to being these underscores, right? So to be Pythonic, it would be all underscores. But to be JSONic, you would use not underscores. You would actually use it in camel case like this. Although JSON data is flexible and it can be either one, but when we actually build a front end and stuff like that, if you're using some sort of JavaScript front end like we will, you're probably going to use camel case. So it's really up to you on how you end up doing this. Generally speaking, I have my models in Python case or snake case, and then I have my schemas in camel case because that ends up being what they use. But again, that's like a big taste and preferences type thing. But once we do that, let's just make sure everything's working correctly. And sure enough, it is. So I'm pretty much keeping the exact same casing for the columns as it started out as too. That's kind of another thing I'm trying to do here is just being as consistent as possible. Certainly can change all these if we wanted to. I'm just not going to do that at this time. The other part of this too is that SQLAlchemy in this case is not actually managing the table. It's being mapped to a pre-existing table that's being managed elsewhere. In this case, it was directly from our dataset, our CSV file. So maybe in the future, SQLAlchemy will manage the table, but right now it doesn't. So we're going to go ahead and stick with just this kind of schema as it just makes the most sense, I think, at this point. And we could also, do a print statement here just to make sure that we have these things just slightly different throughout. It's pretty neat. So let's go ahead and continue. Now we're going to go ahead and configure our SQLAlchemy lookups that we'll eventually use in FastAPI. So we've got the models. Now we just need a way to look it up. So I'm going to go ahead and duplicate the generate models, and we'll go ahead and open this one up. And so we'll go ahead and now do SQLAlchemy lookup functions for MariaDB and FastAPI. That's probably fine. And then we'll go ahead and get rid of this last part. Okay, so first and foremost, what we need is we still need to have our base model here. Now, granted, I would probably want to actually import this model from a FastAPI function at some point. We just don't have it yet. So I'll bring this back up here, and there's our model. Great. And then we've got our database engine. I'm gonna go ahead and delete this. Now I've got my session local. This is something I'll still want, but for that, what I'll do is I will get rid of all of these. Now we'll go ahead and define our functions. So the first one is going to just be simply get flight prices, and it's going to take in a session, and then we can actually have some pagination going on. So we can say offset equals to 0, and the limit, the number that will return, is going to be 100. And all this is going to do is take the session, it's going to run the query on our model, and then it's going to go ahead and say the offset, and that's going to be equal to whatever this offset value is. And then we can go ahead and add the limit in here being equal to the argument of the limit, and then .all. Right, so this will give me all of those prices here. And so those values, we would say flight prices is equal to that with our session being passed in here, our actual session, not the class itself, but there we go. So we make that, and then I can go ahead and print out the flight prices, and this should give me some iterations here. But of course, if I do, something like x.id for x in those flight prices, I will see all of the different IDs that are coming through here, which in this case is 0 to 99, which actually makes sense based off of that limit. So if I change the offset, let's go ahead and do the offset is equal to 100. This now gives me the next page, thus pagination. Very simple. So the next thing, of course, would be very similar to this, but instead of it being all prices, it will be a single price, and then we'll do our flight ID, something like that, or the flight price ID rather. And then instead of having this here, we would use .filter, and then we would grab the model itself, the ID field right here, and then we would go ahead and set that equal to the argument of that price ID. And then we can do something called one or none, which is a nice method that just makes it really easy to grab something. So once again, we can grab the flight price. I'll go ahead and copy this actually and do another one below it. We'll grab the flight price, and I'll give it an ID of 108, something like that. And this will be our flight price. And we'll go ahead and print that out, .id, and maybe the flight date. Go ahead and run that, and there we go. So we've got both of those values. And then if one's not working, let's go ahead and try that once again. I don't need this session maker each time, but we can try that once again with a value that probably doesn't exist, which would be this one. In my case, I'm going to go ahead and run this, and now I get none type has attribute ID. So basically this would be if flight price is not none, then we'll go ahead and do this. In this case, it is none. So we've got nothing there, as in it's not found. Or we could also put an if clause here and say, that price is not found, or that flight not found with whatever that ID is, which is very important when it comes to building a CRUD web application, which is something we'll do very soon. Now, just having these things inside of a Jupyter notebook just gives us the ability to quickly test them to make sure that they're working as intended. In this case, they seem to be. Now, of course, what FastAPI will do is take these same functions and then automatically apply that Pydantic schema to it, so the data that's being returned actually makes a lot of sense, which is something we still need to do with FastAPI, of course. So we're gonna have to create that application now. Whoa. Before we create that FastAPI application, there is one more thing that I want to connect to Python, and that is querying the MindsDB API using SQL like we've been doing, so that we can get our predictions from any given model, and we could do so using Python directly, which we'll see in just a moment. So the idea here is we are going to be using the MindsDB API. So if you go in this AI workflow under getting started, or more specifically, the docs.mindsdb.com/rest/usage, we can see how to connect to various ways of MindsDB. The local one, the self-managed one, which is what we're not using, the MindsDB Cloud, which is exactly what we're using, and then of course there's the managed MindsDB Pro instances as well, which is something you might consider at some point. But the idea being is we want to use the cloud version, and it's going to be roughly exactly this. We're going to create a session using Python requests. That session is going to take our username and password so that we can then make calls to the API based off of that session. So we can actually call with those queries, as you see right here. The queries we've been using. So that should be any query in here. We get drop models, we can create new ones, we can describe it as in wait for the model to finish, and then we can then finally start making those predictions. So let's go ahead and get started doing this, and we're going to do it inside of a Jupyter notebook, of course. Now, I already have Python requests installed because of other packages. That's going to be what we'll use to make our requests, and that's in requirements.txt. I just added it in as well, just to make sure it's definitely in there. But of course, if for some reason request isn't working on your machine, just make sure that you install it right now. Next, of course, in .env, we want to load in our username and password, which I've set as MindsDB_UN and MindsDB_PW. These are my actual username and password to MindsDB, so I'm not going to share them. They're not going to be on here at all, just like yours shouldn't either, on here as in my video. Okay, so I want to bring these things in, and there we go. So we've got that stuff already configured. And we also have our goal, and that is calling this SQL query. So I'm going to go ahead and say SQL query equals to 3 quotes, paste this in, 3 quotes. We'll change these values in a little bit, but of course, if you're familiar with Python, you know the F string substitution. We could just come in here and change this to something like flight date like that, and then come up above and do our flight date, right? Which I had in as this value right here. It's the same exact query as it's been. Okay, cool. So the first thing I want to do is very similar to what we did with MariaDB, is we want to create a session. So I'm going to call this get MindsDB session. And what this is going to do is take in our username and password and send it into the MindsDB cloud and then get a session variable back. So the way this is done is by using session and requests.session, just like that. Now again, this is in their documentation on usage. It's this right here. This is what we're doing. We're connecting to it. So coming back, we can bring this in and we can see exactly that, right? And so this endpoint here is specific to this version of MindsDB, the one that we're using, the cloud version, right? So if we come back in here, we got MindsDB cloud. That's what we're connecting to. The other ones are going to be a little bit different, as you see. The API root in here. This is just slightly different. Something worth considering at some point, but right now we need to make sure we're using the correct one. And of course, if you have the self-managed version, you probably don't even need to authenticate at all. Okay, cool. So next up, we've got this going, and then we're going to go ahead and put in our variables here. So change this from email to your MindsDB username, which will probably be an email, and then your MindsDB password, which you should keep hidden. And then we'll return our session. Great. So what this will allow me to do is actually grab that session like this, and then do stuff like session.post, and then posting somewhere. Where is it that we're posting? Well, we're posting it to the REST API for SQL. So we can come into this value and we can see what the endpoint is right here. So coming back in, we can bring in that URL just like that, and that will allow us to do that query. Now, the reason I have this base URL happens to do with if you end up changing which version of MindsDB you're using, you need to be able to adjust accordingly, right? So down here, we've got a different URL, a different HTTP API route, which is just a different endpoint. That's why I've got this one up here, so that when I do a SQL query, I can easily change out the API that I end up using as we just saw. Okay, great. So now we'll go ahead and do our MindsDB and query. This is going to take in a session variable, which is going to be this. And then we will actually use that session variable, much like this. And then we'll also add in our SQL query. And that SQL query is going to be, well, a lot like this, right? I'm actually not going to do anything with that SQL query just yet, other than passing it into my post data. So what I want to do here is I'll return something like this, r.json. Okay. And so the endpoint itself, so the URL itself is going to take in this base endpoint, so we can change it at will. And that one does not end with a trailing slash, but rather it will take in just these right here. So endpoint equals to that. And I'm just trying to make it identical to what we saw in the documentation. Okay, so we're going to bring that in. And then I'm going to go ahead and pass in a JSON dictionary. So I'll say JSON equals to, and there's going to be query, and then our SQL query. When I say JSON dictionary, this needs to be JSON ready. It's actually still a Python JSON dictionary, or it's still a Python dictionary, but it has to be able to be changed into JSON, so JSON.dumps. So that actually has to work on this data. In this case, it's just a string, so we should be okay. But with that in mind, we also want to pass in our headers to make sure that we are declaring the correct content type, and that's going to be application JSON. In other words, we are sending JSON data, which typically means that we will get JSON data back. Now, this absolutely can change because JSON is not the only way to pass the data around, and therefore it's not always going to be the only way that it's supported, right? So, MindsDB's API continues to evolve, so there's a good chance that it might also accept other JSON types at some point. But now that we've got this, we have the basis for doing our query. So let's go ahead and run it. First off, let's go ahead and bring the session itself where we're going to actually execute the query. So we got our session here, and then our actual query, we already have it up here, which we called SQL query. Okay, and then I'll go ahead and close out that session after. So I'll go ahead and also call this my query response, and we'll run this, and then I'm going to go ahead and print out that query response, which should be identical to the query response from in here, right? So if I run this, the only difference being that how it's formatted might be slightly different. And so what we get back here is that slightly different format, but it is doing the prediction for us, which is great. Now we do want to clean up this one a little bit, so we'll do that in the next part. So what I want to do is I want to take this one step further, and instead of calling it just MindsDB query, we're going to go ahead and define, and we'll go call this like predict, and maybe our flight predictor, or maybe just we'll call this predict query. And again, it's going to take in session, and now we can actually bring in those variables. So I'm going to go ahead and cut this out, and I'll paste it in here just so we can start building out what those variables will be. So we've got our flight date, and then we've got our starting airport, and right now it's SFO, and then we've got is nonstop. In this case, I'll keep it in as just a 1 for now, and then we'll go ahead and say destination airport and boss. Okay, so let's break these down a little bit so it's formatted a little bit nicer here. There we go. Next up, we're going to go ahead and replace all of these variables in here. Okay, and destination airport. Now, generally speaking, I would probably change these into camel case, but for now, we're going to leave it in just like this. And then I'll say raw request being true for a moment. And you'll see why in a second. So the idea being, we are going to go ahead and run our response. So response being the MindsDB query, which will take in the session and our SQL query. And basically what I want to do is, instead of this returning back JSON, I'm going to return back the actual session request itself. This is for debugging purposes as well as other things. So that's going to be the actual response. And then we'll say if raw request, then we'll return back the response itself. Oops, let's go ahead and bring that back. And then we'll go also do response.raise for status. So I should actually bring this up right here. And then otherwise we'll return response.json, which I'm actually going to improve just a little bit. Okay, so once again, we'll do our prediction query now. So instead of passing in SQL, we will now pass in the actual SQL query. We'll actually now pass in the arguments that we want, like that. And run it again. I'll go ahead and comment out. Oh, it's already gone. I removed it already, but I was going to comment out that original SQL query here. But now we should actually be able to get that query itself. Okay, so we've got a dictionary does not have raise for status. I needed to call this again. So let's try that one more time. Refreshing essentially the MindsDB query function itself. And then we print out that response and we got 200. Okay, so I sent back the raw request, which this is what it is. So my query response.json will give me the data. And so if we actually take a look at the keys in here with .keys, we can see that we've got column names, context, and data. So the column names are going to be, looking back in the console, they're going to be these column names. And then the data will just be the rows. So I actually want to map those things together so that they're going to be more useful for us when we actually try to put them into action. So what that means then is I'm going to say my columns equals to, let's go ahead and change this to just simply data. Okay. And so now I can do data.keys. And so this is going to be columns is going to be data.get and column names. And then my data set is going to be data.get and data. Oh, and that should be column names. So go ahead and look at those columns. And there we go. So one of the bad things about these columns as it stands right now is the fact that we also have our flight date, start and airport, destination airport. We have all of that stuff repeated as well as the index value. This has to do with our query, right? So if we go back up to our query, we've got this select all here. And so this is why every once in a while, it's a really good idea to start narrowing back what the response should have. So this select all is going to just give me back everything, but we want to be more specific based off of the columns that are actually here. So the first half of these columns, the ones that end at totalfare_max, are related to the actual prediction. So all of these are ones from the prediction. So to be able to get the data that we actually want, we need to decide which columns that we want to use from here. So come back up and I'll bring it in and I'll go ahead and paste it. I definitely probably want the flight date, right? Which I might not necessarily need, but let's go ahead and do m.flightDate. The reason it's m is because that's the model predictor model, whereas before is doing m and t. Okay. So we want the flight date. We also want the total fare. So that's going to be m.totalFare. And then we want the total fare confidence. Let's go ahead and do m.totalFare confidence. Okay, so this might not actually make sense to you necessarily, but the cool thing about this as it stands, I'm going to go ahead and comment this out real quick. The cool thing about this is I can print out this SQL query. Let's go ahead and do that. We're going to run everything all over again. And so there's my SQL query that I'm actually running. I could copy this, go into the editor, paste it in there, run it, and we should be able to see the results directly in the editor just to make sure that everything's working as intended and there's not any errors necessarily. But this is giving me back all of those responses based off of that data. But of course, it's actually missing something that I do want, which would be the flight, the actual airline itself. So segments airline. So let's go ahead and bring that one in as well. So I'll get rid of the flight date because I'm actually passing that in right here, and I'll put in the airline itself and the total fare and the confidence. That's probably enough. I don't know if I need much more than that because all of the other things are going to be provided. We're going to provide those things in, right? So we're providing them as arguments. So perhaps I want the nonstop part. So we could add m.nonstop and so on. And that will give me much better data. So let's go ahead and run that again, and we'll take a look at the columns that come back now. And it should be quite a bit different, right? So the column name's in here. Here's our columns now. Much, much different because we're not selecting everything. It's only a few of the columns, which being more specific about what we want is a good idea. But again, this is going to take some experimenting with on your end on whether or not that's how you're going to want to work through it. Okay, so now also with our data set that comes back, it's also quite a bit different. It's much, much smaller now, which is, I think, a really good idea is to get it down to a much smaller level, a more manageable level for doing all sorts of things, including turning this into a list of dictionaries. Right now, we've got columns that should be mapped to other columns, basically, but these are rows. This is very raw data. We don't want raw data. What we want is more like JSON data, or at least going towards data. Let's go ahead and say this is web ready data, like our FastAPI ready data. And so how do we actually create this? Well, one of the ways we can do it is we can iterate through this data set. So for row in dataset, which should give me each one of these, which we can check out with print row. There's all those rows. And then inside of those rows, I can do something like this. So for I in, let's say column in row, or enumerate. So I is going to be the row number. So we could also call this just simply row num if you need that. But the idea being in here, we've got our iteration. This is going to be then our columns and I, and then the column value, which is, these are now key value pairs is what we're seeing here. So if I print that out, I've now got my key value pairs coming through just like that. Another way to do this, instead of writing it out all like that, is we can do a list comprehension where we use dict and zip. And then we can actually do our columns names, or rather our columns. And then we can use our row, and we can do for row in our data set. Great, and so we come in here and use our web ready data, and there we go. That is much better. That's going to be much better web ready data than what we had before. Cool. Now you could potentially use Pydantic here in lieu of this web ready data. We could change it a little bit, but I'm going to leave it just like this, right? So I could do Pydantic with the dictionary itself, but that's getting a little bit beyond what we want here. So going back into our query, our predict query, we just want to parse all of that same data out, which is going to be our columns, our data set, all of those things. So that's the data we're actually returning when we're not using the raw request, as we'll do in just a second. Okay, so the response is here. That should now give us all that data. Let's run this again. Let's turn this raw request into false, and let's see what the response will be. This time I can go ahead and do that right there, the query response, or really now it's web ready data. And then I can just comment out everything else, and we're getting our query response slightly different. So let's go back in here and see what's going on. Oh yeah, we didn't actually return it. There we go. So let's try that again. And I'm also going to get rid of that SQL query print statement, get rid of that. But there's our query response. That's exactly what we want. So this is pretty cool. Now, this, of course, is going to be doing the predictions for us, right? And we can also verify one more time by doing a different query. Let's change this from SFO to Boston and then run it again. And we run this again. And here we go. So one of the things that's not clear here is the actual date, right? So if you remember how we did make this query and how we made this model, it did project a few dates in the future. So let's actually bring in that date, bring it back. So M and flight date, run that again. And here we go with that query. And this time, based off of how it was designed, I get that flight date back. And in this case, it's actually giving me the correct date, roughly speaking, because our query itself is equal to that date. If we set it greater than that date, we will see a different response. If we see less than that date, we'll see a different response as well. So the way those predictions work is based off of that date to some degree. So all of these are 22, not the same date. We've got 23 and 24. So in this case, that one element of the flight date was actually pretty important. But I'm going to go ahead and leave it in as equals, and you'll be able to modify it as you see fit. But now we have a way to do our API calls through Python with MindsDB. And so with this, we can actually start building our FastAPI service right now. Now we're going to go ahead and create our FastAPI backend. Now to do this, inside of my AI travel agent here, I'm going to go ahead and write backend. And inside of here, we'll do main.py. And then I will actually copy my env.py over as well. The reason I'm copying it is mostly so my notebooks still have access to the one it's using. And then my actual backend API service, I could add additional kinds of environment variable loaders, like if you're using, HashiCorp Vault or Google Secrets Manager. This is where you would still use it. You'd use the exact same env.py file, and you can use Python Decouple for that as well. That right there is outside the context of this, but that's why I have those two files. Okay, so in main.py, what is it that I'm trying to do here? It's really simple. We're going to import from FastAPI. We'll import the FastAPI class, and then we'll go ahead and declare our FastAPI app. And then I'll go ahead and do my first route, which is at app.get. And this is going to be simply hello world. And then we'll go ahead and define read hello world. And we actually don't need to pass any arguments here. We just return back a dictionary of some kind. So I'll go ahead and say hello, and this is going to be world. And then we'll go ahead and also put debug, and we're going to grab a debug mode, or I'll keep this all capitalized. Now, the reason I'm doing this is also for that env. I just want to make sure that that's working. So I'm going to import that from backend.env. Backend, of course, is the name of this folder, and then .env is the module itself. We're going to go ahead and import config. So I'm not actually doing relative imports here based off of how I'm going to be running this application, as you'll see in a moment. So the debug mode, I'll go ahead and do debug equals to config of debug. I'm going to cast this into a Boolean value, and I'll go ahead and say the default being false. So like many different Boolean values, 1 is going to be true, 0 is going to be false. You could always use true or false values as well, but what this allows me to do is just come in here to my env and say debug being 1, so that value of 1 will then be cast in as being false or true, depending on 1 or 0. In this case, it's going to be, well, let's see what it's going to be. Okay, so now I've got my FastAPI application. So if you've never actually built a FastAPI application, that's how simple it is. Now in my requirements, I also have this thing called uviacorn. That's how I'm going to actually run my FastAPI application locally. If I were to go into production with this, I would use gunicorn in conjunction with uviacorn. They can work together. Gunicorn and uviacorn are web server gateway interfaces. Uviacorn is for asynchronous version of that. Okay, so with this in mind, let's go ahead and see where we are. I still have my notebook server running on purpose because we will test this out in just a moment. But the idea being, now that I'm in here, I've got my backend, so I need to run uviacorn backend.main, which is what I called my entry point application. So main and then colon, the app variable itself. So if you called this ABC, you would want to change what I'm about to do to whatever that is. In my case, it's just app. I'm also going to have in reload here. Reload will mean that anytime I save anything inside of this backend, it will automatically refresh the server. And then I'm also going to use port of 888, 48, and I'm going to go ahead and run that. What I see is address already in use. This actually isn't surprising because my Jupyter notebook is on port 888. Now, if you're not aware of this, different port values do make a big difference when it comes to running different applications on your service or on your computer. So I'm going to go ahead and do it at 880 just for that. So there it is on my local host at 880. I can go ahead and open this up into my browser. So let's go ahead and grab this one at 8080 and open up my browser. Oops, localhost and 8080. And we've got detail not found. Okay, so the reason it's detail not found is because the only route that I have is simply hello world. So if I go to /hello world, there we go. We now see debug being true. And then if I change my environment variables to 0, for example, I might need to refresh my server. So I'm just going to go ahead and do it. And then I refresh in here. Now I've got that debug being false. And then if this environment variable wasn't even in env, it should also be read as false. This is a big part of the reason I use Python decouples, because I can cast things like the 1 is not an integer, it's not a string, it's being cast as a Boolean value. But I can also set default values in there without much configuration, right? This is actually pretty straightforward. I'm gonna leave in that debug at 1. And now what I'll do is just jump into my Jupyter notebooks, and I'm gonna go ahead and do new terminal notebook. And this one is gonna be just simply our connect to FastAPI. Okay, and we're gonna import requests. And then our URL is going to be our local host, hello world, that whole thing right there. And all I'm going to do here is run a request. So request.get URL, and then we'll go ahead and do print out r.json, the actual response that comes through. We run that. There we go. Great. So we now have our own REST API service. And of course, it's through FastAPI. It doesn't connect to all the things we want to connect to, like our MariaDB instance, right? It also does not connect to our MindsDB instance either, not yet at least, but we're on that right track. And we will continue to use this Jupyter Notebook to do these API calls. Now, a big part of the reason for this is so that our front-end application, our Next.js application, will also have access to this same sort of data. So I'll kind of flush out all of the API calls in here and then have our Next.js application use those calls based off of that. So one of the key things about what I did though was related to the actual route here. Okay, so this get method, another method that you can use is called post. So let's go ahead and just change this a little bit. So if I do a post method now, when I run this request here, let's go ahead and make sure I'm restarted. So let's restart our kernel, restart and run all cells. I should get an error on that get method, assuming that everything was done correctly. Let me just refresh this page here. So I only have post method for that one, and now I get methods not allowed. If I do a post method here, then I get that data back, right? So post method is really good for what we're going to be doing with our APIs. Our hello world can be either one. But of course, if you want to actually support both methods, it's always a good idea to actually have different functions for each one. So we'll go ahead and do something like read and then write, right? So read to the hello world endpoint, write to the hello world endpoint. Granted, we're not actually doing anything there, but it is important to set up both URLs in here just to make sure that they are actually working and you understand a little bit more about these methods. We're going to talk about them a lot, so stay with us. In a moment, we're going to create our Next.js front end. This front end will connect to our FastAPI backend. But before we actually create that, let's talk about why we have a FastAPI backend in the first place. Now, first and foremost, I think Python is one of the easiest ways to write integrations to a number of different services. I think we already have seen that with our MariaDB connection as well as our MindsDB connection. But beyond that, why do we even create a REST API backend at all, regardless of if it's in Python? Now, a big part of the reason to do this is so that you can make it simple to do complex things. So in this case, what we have is we have a single URL and a single path that runs based off of what we have dictated to it. Now, if you know Python, you know that you can change all sorts of things related to what this response is. And of course, if you've built a web application before, you already know that you can also connect to all sorts of different other web applications or other API services. For us to have a backend that's decoupled from the front end allows us to rapidly iterate for the various clients that we want to support. So in our case, we're going to be iterating with our Next.js application to get that part functional because it feels great and it also will provide value, hopefully provide value to our end users, the ones that will actually interact with our web service. But beyond that, we can do more complex things. We can actually build other kinds of applications that connect with this same sort of backend API. It's going to be a consistent API that we can then build. Let's say, for instance, we want to build a Slack bot. We could totally do that. We want to build a Discord bot. We could totally do that. All of those things could then connect back to this FastAPI backend that has everything already established. Now, the big thing that's missing, of course, with our backend, well, we're missing everything, really. We have just very fundamental things. So what I'm actually going to be doing is building our Next.js application in tandem with our backend so you can feel those things being built out. So then if you need to take it further, you can. Now, we could totally build out our entire backend with Jupyter because Jupyter itself is its own client. We can see that right here. I've already set that foundation. I've set that stage a little bit, and we'll actually do that as well. We'll test a lot of these things in Jupyter as well as Next.js just to make sure that it's working in a way that makes a lot of sense, not just for us as a developer, but for people who might want to use our API service if we end up opening it up to them. So let's go ahead and actually create that Next.js application now. All right, so now we're going to create our Next.js application using the create next app command, which we'll see in a moment. Now, if you don't have Node.js on your machine, definitely download the latest version at nodejs.org of the LTS. That's the one I recommend. Now, when you do download that, it might have the same version as 18.18, or it might be different. In my case, it's just slightly different, but I am still using version 18, which is the LTS. When you install Node, you also get something called npx and npm, which in my case, they're version 9.8, which is probably a newer version, but the idea being you want all three of these things on your system before you run this create next app. Now this create next app is great because it will literally create a new Next.js application for you with all of the boilerplate that comes with it. So I'm going to go ahead and copy the command, but it's really simple. It's just npx create next app at latest. You hit enter, and this will now prompt you for a number of things. Now, before you actually run that, you can do Control-C. You can actually see where you are. In my case, I'm in the dev folder of my project right next to where my backend stuff is. So that's where I'm going to keep my, or at least start my Next.js application, and then I'll do my AI travel, and we'll call it agent-UI. I'm not going to use TypeScript. Of course, if you know TypeScript, by all means use it. If you don't know JavaScript or TypeScript, then definitely just use JavaScript. It's a lot easier in my opinion. Will we use ESLint? Yes. Tailwind? Yes. The SRC directory? Yes. App router? Yes. It's the modern version of Next.js. If you know a different version of Next.js, by all means, don't use app router. But for everyone else, let's use app router. And then we're not going to customize the default import alias. And there we go. So now it's actually creating this application for us. Notice that React and React DOM are the main dependencies to this. Of course, Next.js is as well, but those dependencies are required to make Next work. As we see, it's a React framework. Okay, great. So with this in mind, let's go ahead and open this up into VS Code so we can just get a sense as to what's going on. Oops, we need to navigate into that folder first. So if we list things out, here is that folder. We can cd, navigate into it, and now I can run, pnpm or just simply npm run, and I believe it's dev or maybe it's start, but it does change from time to time as far as what command you run. But the idea being it's going to be at localhost, and if we open that up, we should see our Next.js application in here. And there it is, right? I would imagine this is going to evolve over time as well. But going back in here, what we see is this is just a single server that's running our Next.js app. It has nothing to do with our FastAPI app at this point. But I want to combine these two projects. So if I list everything out, here's all the code that I want to bring over. And also, really important is going to be package.json, which has all of our dependencies. You can think of this a lot like requirements.txt for your Python apps, but it also has the ability to run various scripts. So I ran npm run dev, which runs this script, which is this right here, and then there's start and build and so on. So we want to bring this on over to our project. So what I'm going to do here is I'm going to open up this folder with open. I want it to be on my local drive here because of how I'm going to be bringing it into my AI travel agent folder. Now, before I actually do it, I will mention that this is not always recommended to combine your backend and your front end. I'm bringing everything together to make sure that there's one single repo that you will be able to reference, but also I actually configured it in a way that we've got our backend here, we've got our notebooks here, we've got a bunch of different things inside of this project as it is, where it's already kind of separated out. It just happens to be in the same folder that will also be monitored by Git. So let's go ahead and bring it over. The things I want to bring are pretty much everything except for package lock, node modules, and README. I don't need the README file because I already have one. But I'll go ahead and bring these things over into my AI travel agent. Just make sure it's in that root folder here. And we want to copy these folders, not add them, but copy them. And there's our SRC there. And so one of the things we'll update this in just a moment, but one of the things we definitely need to update is our git ignore here. So what we can do is back into our terminal, we can do cat.gitignore, and this will give us that git ignore file here. And if you're on Windows, you would use pipe clip, I believe. I actually don't remember, but pbcopy will actually copy that file, and we can actually bring this in to our git ignore here and scroll all the way down, paste that in there. And so now I've got a new updated git ignore file in here. And so what I want to do is I want to actually install everything from package.json. Notice that I don't have those node modules anymore. I did that on purpose because we'll actually delete this whole folder in just a moment. But for now, back into the root of my project, the entire thing, we can go ahead and open up a new terminal window here. We see that the virtual environment activates. The virtual environment has everything to do with Python and nothing to do with this Next.js or any sort of Node.js application. So what we need to do though is we need for this to run. So if I try to do npm run dev again, I'll get an error, right? And that's because my local environment doesn't have anything installed. So we just run npm install, and that will do all of those same installations that the create next app did. The only reason I didn't do the create next app inside of this AI travel agent folder has to do with the fact that it comes with a git ignore, but it also comes with a pre-existing git repo. So going back in here, if I did git status, I didn't actually change anything. I didn't add a git repo. It automatically says nothing to commit because it's bringing in a lot of boilerplate code, a lot of which we just don't need. So all of the Next.js stuff we do need, so we will keep that in our repo, and I'll now run npm run dev, and this should actually now run that dev server as we saw before. In this case, it's now in a different location overall. Now we're going to go ahead and configure our Next.js application to communicate with our FastAPI application, much like we did with Jupyter with FastAPI. We used a third-party package, we have a URL, we made a request, and we respond with that data to some sort of variable. We're going to do the same sort of thing with Next.js and a third-party package called SWR. SWR is great, as we'll see here shortly. Now, before I can have Next.js communicate with my FastAPI application, I have to implement something called CORS, or more specifically, CORS middleware. Now, what CORS is going to allow me to do is to actually connect to other web applications across the internet, right? As it stands right now, it's not going to be able to do that. So let's go ahead and just make some minor changes to our FastAPI application. So we'll do from fastapi.middleware.cors. We're going to import the CORS middleware. And what we want to do here is we want to use this app.add middleware. And we're going to pass in the CORS middleware and all of the arguments we want for this. So the first one that's important is allow origins. We're going to set it equal to all to start. We're also going to allow credentials. And this is also going to be to true. And then we're going to allow methods. And once again, we'll go ahead and say all. Once we go into production or once we get closer to what we actually want, we're going to change this a little bit to being more specific, but for now we'll leave it in as basically allow everything, right? Cool. So one of the things we will do is we'll also add in a new configuration, and we'll call this origins, or maybe front end origins. And we would set that equal to configuration. This, in this case, it's going to be, we'll have the default being an empty string, but what we want to do is we want to turn it into a list. So what we can do is we can pass in a Lambda call here of, let's say, for instance, x, and then we can do x.strip, and then for, or s in x.split with a comma here. And what this allows me to do is go into env or a virtual environment and pass in something like http //localhost 3000, and then http //localhost 9090, or any other sort of URL that you might want to put in there. And so I can pass that in as my origins there, as a list as well. So I can go ahead and print out what those origins might be. Let's go ahead and take a look at our FastAPI application. And there we go. So they're actually out as lists, which is why I did that exactly. So notice that localhost 3000 is in there, and that's on purpose because we've got localhost 3000 right there, as in where our Next.js application is. Okay, so I still have that running, and notice it's also using the same .env file, which is interesting. But we have our application running, so now we can go ahead and use SWR. So SWR is much like Python requests, but it's optimized for a reactive environment, for React.js specifically. So we're going to go ahead and install it with npm install SWR. And then in this documentation, as you'll also notice, is there's this quick start here. What do you know? We're actually going to use the same exact quick start. So let's go back into our project, and we'll go ahead and do our npm install SWR. And of course, what that's going to do is update package.json, and it'll give us that package in there. Much like requirements.txt, package.json is keeping track of all of the dependencies for this project. Next up, we're going to go into src/app into page.js. This, of course, is that index page that we've been seeing. I'm going to go ahead and get rid of everything in here except for main. And then I'll go ahead and put an H1 in here and say hello. Okay, so what we got right here is called JSX. To me, this is JavaScript HTML. Literally, you write out, you can use all kinds of JavaScript things in here, and that's the point of this, is then I can say something like const, like my var being world, and then I can use that same sort of JavaScript notation for string substitution, just like that. Curly brackets, the variable name itself, and this will actually render out everything as we need to. Now the reason for this, the reason this is important is because then I can allow a request to happen using SWR, and then the data from that request will show up here, or show up inside of that JSX, which is what this quick start is showing us. This right here is an example of what I just said, just with kind of dummy data. So what I'm going to do is take these first 3 lines here, I'll copy them, and we'll bring them into our home page. And I will also import, use SWR, the actual hook itself. We'll get rid of this image import, bring in use SWR. And then we'll also declare this as a front end only. So make for front end only. Next.js has backend support as well, but we're not covering that. Okay, so now we've got the way to actually do a request, but what we don't have is our URL. So we declare another constant here for a URL. And what is that constant? Well, it's going to be this endpoint right here. And we can pass that URL in right there. I do not have the fetcher declared, which I should have done, but that's of course coming directly from the documentation as well. So we'll go right there. Okay, so now I've got my URL, some error data, and then I can actually put in my actual data in here as well. But actually, before I put in my actual data, I'll just console log it so we can see what that looks like. Okay, and so we've got a URL, a way to call it, this fetcher. If you're familiar with fetch in JavaScript, that's essentially what's happening here, is it's looking for JSON data. It's quite literally looking for what we have designed in our REST API. It's not looking for HTML data, for example. It's not looking for plain text data. It's looking for literally JSON format, which is how this ends up working, and how this also ends up working. Great, so with this in mind, I can also say my main class so main class CSS, I can actually pass in basically these same values. And I can move them around. So inside of JSX, we use class name instead of class. And we can pass it around just like that. Again, very similar to HTML, but now we can just write it directly in a JavaScript function, which is what we're doing right here. So inside of my Next.js application, I see hello world there. If I refresh it, it shows loading. And if I choose a different URL, then we might even see error in there. But technically, that's not an error in the way that it could be. So let's change it to like 8081. This is now an error, so failed to load. And that's all coming directly because of use SWR. To me, this is by far the easiest way to do GET requests, right? So it's really important that we have this GET route here in order for what I'm doing right here to work. So now we've got this thing called data. Let's go ahead and actually render that out. In a div, I'll go ahead and say data. So if I refresh, now I get something like this. Objects are not valid as a React child. Now this is because if I inspect the element here, I go into the console and I scroll up a little bit, the console logs is actually logging out that data. So it's not a string, it's actually a JavaScript object. This object has dot notation, so I can actually do data.debug with the capital G or capital D like I did here for some reason. But we've got data.debug and now it's true, but it's not actually showing me true, right? So we can also do data.hello and we can now see that world as well. Or something I like to do when it comes to working with APIs like this is I just do JSON.stringify and then the data that comes back. So then I can see this data as a string. And there we go. So that's actually showing our data. And we're going to stick with this for a little bit. So what we see here is Tailwind CSS in action. That's why things look the way they do. And that's why they're functioning the way they do based off of these classes here. So if I got rid of something like min_h_screen, it would change quite a bit. So you can play around with that as you see fit. I'll keep it in as min_h_screen just to have all of our data show up, basically. Cool, so we now have a way for our Next.js application to talk to our FastAPI application. So let's build it out a little bit more. Now we're going to start the process of integrating our MariaDB instance with FastAPI using, of course, SQLAlchemy and Pydantic. So to do this, inside of my backend here, I'm going to go ahead and create a new module called DB. Inside of there, we'll go ahead and create our init file, and then we'll go ahead and do our connect.py. Now, you could probably put all these things in the init file, but I'm going to do it in connect and then a few others just to make it a little bit easier on ourselves. Okay, next up, what I want to do is open up the Generate SQLAlchemy models for MariaDB and FastAPI notebook, because we're going to be building things based off of this. So go ahead and just copy and paste and get this going. So we'll stop at engine and then we'll scroll down a bit to the session local itself. Great. Okay, so what I want to do here is I'm going to define get DB session. And what this is going to do is it's going to get that session local. And then what we want here is we want to try to yield that, or we will just go ahead and close it. So this is directly correlated to how FastAPI is going to handle any given database session on any given view. We'll see that very soon. But the idea here is I probably don't need the declarative base here or some of these other items. So inside of my DB, I'll go ahead and do models.py. And this is where I'll bring a lot of that in. Paste it in here. And then we'll go ahead and go back into our code or our notebook here, and I'll go ahead and copy the flight price model, and then I'll go ahead and scroll down a bit, and we will now bring in the schema itself into another location. So we'll go ahead and do schemas.py, paste that in here. And then the last thing I want to do is create something called utils.py. These are going to be our database utilities, as in our lookup functions. And so that is, of course, in another actual function itself, or another notebook itself. And so I'm going to bring those things in just like this. And from here, we'll go ahead and do from backend.db.models. We're going to import the flight price model. Great. So it's also possible that these flight price models we could put in with models.py, but I'm going to leave it in as here, and we will then import it very, very soon. So the first thing I need to do though is in connect.py, I need to update this a little bit and change this to backend.env because it's the backend module, the main one. And then I can get rid of some of the other things that I imported here. I probably don't need this base class in here, just in models.py. And there we go. And then models.py doesn't need session maker or create engine. It also does not need our configuration at all. And then our schemas, that everything looks okay there. And there's our utils. Okay, so to make sure that all of this is sort of working, I want to just import it in here. So we'll go ahead and do from backend.db.connect. We're going to import our getDB session. And then from backend.db.schemas, we're going to import, this should be from, and we are going to go ahead and import our flight prices schema. Okay, and so I just want to make sure that this is still running. Let's bring it up here. Looks like it's still running, and I just am going to verify that there are no errors to it. And so far, no errors. No import errors, nothing like that. I just wanted to make sure that these things were actually possible. Now, if I actually try to get a session, so if I do session equals to get session, this is not exactly what we're going to be doing. Instead, we're going to put it directly on the views, and then we'll go ahead and import some of those utilities as well. And so to do that, I'm going to go ahead and do from backend.db import utilities itself, the entire module. And so that way I can just call utils.get flight prices when I need to. So it's going to be in here, utils.get flight prices as a list. Not this view, but one of the views. So let's go ahead and take a look at doing that list data inside of any given view. All right, so now into our views, our actual API endpoints, we're going to go ahead and grab some of our data. So we are going to be using a few of these features right here in addition to something called depends. So if we do depends here, we will now come down and we're going to create another app route. So we'll do app.get, and this is going to be /flight prices. We could also just say flights just to make it a little bit easier on the API usage, but we'll stick with just that. And then we're going to define, and this is going to be called read flight prices. And what it's going to do is we want to grab our DB session, and this is going to be of the type session local, which I'll have to bring in my session local here. So with FastAPI and with a lot of newer Python frameworks, you'll see that you want to declare data types. And this is a good reason for it, is that we can then say equals to depends, and this is going to be our get DB session. And so that get DB session, going back into that connect method here, this will return that session local as we see here. So that allows the actual function itself to understand and know that. Okay, great. So this will give us our database session itself. So now what we need to do is return something. Well, if you recall, we have the utility, so utils dot. I'm actually going to change this import to import utils as db utils. And then in here, we can come back and do db utils dot and get flight prices and just pass in that session variable itself. We'll worry about the pagination later, but for now, this is what I want to pass in, and that's almost what I want to return. When I say almost, if you recall when we were first using this, it didn't give us data in JSON format or really match the schema that we were looking for from Pydantic, which is what we actually want to respond with. So to do this, we're going to come back in here and say our response model equals to, well, it's going to be equal to the flight price schema that we've already imported, but it's going to be not just one, but many of those. So it's actually going to be a list of these items, and we put this into brackets, And then we need to import that list from typing. So from typing, import list, and there we go. Okay, so now we have the flight prices. Hopefully everything was imported correctly and we've got it all working. So let's go ahead and take a look at this by using our Connect to FastAPI notebook real quick. And we'll just go ahead and say flights. And I'm going to get my request going. So this will be URL2, R2, and then R2.json. I'll just run that. And there we go. There's some of our flight data as sort of anticipated, hopefully anticipated as you might expect. It is directly coming from the database. And now that we have that set up, let's go ahead and update our single detail view. So like a single flight based off of the IDs that we've been passing for it. All right, so now we're going to go ahead and read a single flight price. So we're going to copy the original one of flights, and we're going to pass in an argument here. This one we can say flight price. This same argument is then passed into your actual function itself. In this case, we're going to declare it as an integer, and this is going to be get flight price, and the arguments itself are session and flight price ID, which is what is happening there. So we'll go ahead and add in our DB session as the first argument, and then our flight price ID. Great, so that should get us an individual price. Now with this, we might as well add in pagination into this function as well. So in this case, we would then say something like our, let's go ahead and take a look at the actual utility function itself, which was offset and limit. We would then bring those in as arguments here. And just like that, in offset, we would then say it's a integer, limit also an integer, and then we can just pass these values directly in. There we go. And so the flight price, I think I saw it where we actually had those arguments still in there. We definitely do not need those. That was just from the things we were experimenting with. Okay, great. So of course the final thing would be then is to jump back into our, our Jupyter notebook here, and then we can grab the URL and request, change this to 3, this to 3, this to 3, and then just grab a existing flight. So for example, flight 2, and we get a invalid value here. So we're going to have to take a look at that. We've got expected, oh yes, response model. It's not a list, it's a single item. That's what this is going to return. So we need to make sure our schema response is also a single item. Let's go ahead and run that again. This time it does give us a single item as expected. Great. What about if we went to a price or a flight that just simply does not exist? So in this case, what we would want to do, of course, is have the ability to say that our DB flight value is equal to that. And basically, if it is none, then we want to raise what's called an HTTP exception. And in this case, it would be a status code of 404, as in not found. And then we can pass in a detail string saying flight price not found. And to import this or to grab it, we're going to go ahead and import it directly from FastAPI like that. And if it is found, we can just return that value. Save that, and we'll run this request again. Notice I didn't have to repeat anything at all, as in I didn't have to refresh the Jupyter notebook at all. I could just run it. That's because they are now separated and thus sessions don't have to be refreshed at all. There we go. So one of the things that you might be wondering is like, oh, do I really want to have all of the detail here? Like, should I change the response schema that's coming through? So I'm going to just try that out by copying this schema, and we'll go ahead and say this is our flight price detail schema, and this is just going to be our flight price overview schema. Just slightly changing it, but I'm actually not going to change this name just so I don't have to adjust everything. And so I'll get rid of a few of these values in here and just leave just some of them. So with that in mind, I saved everything. It should have refreshed on its own. If I refresh in here, now that schema is just slightly different. And then the flight data, I would just have to bring that one in to main.py as one of our imports here, bring it down to that response schema, and then now do that lookup. And that gives us more detail. So just in general, when you are trying to request data, especially a lot of data, you're going to want to have as few fields in here as possible. The less fields you have in here, the better. That's just going to be a lot more efficient. Whereas when you go into a detail view, it makes a lot of sense because you're just getting one item, really, one row. And so getting pretty much all the columns in there is probably just generally fine. Cool, but now that we've got the API endpoints to read the data, let's actually take a look at how we can do that inside of Next.js. All right, so in our Next.js application, we're going to go into our home page on page.js, and we're just going to change this URL here to flights. As soon as we do that, guess what? Everything changes as far as the rendered out page. So, of course, what I want to do here is I actually want to iterate through all of this data and not just list it out like we have here. So to do that, we're going to come back down into this data here, and instead of it being a stringify of the data, we'll do data and data.map. And what we have in here is going to be the row and the index value of that row. And so this is going to be a callback function, which on one hand, we could just bring it in right here, or what we can do is say const render, our list data, and that is going to be that same function, so row idx, and then it will be passed through as we see fit. So I'm going to go ahead and try that out. So map, bring that callback function in here. This is mostly to separate the view of it all. Normally, I would have these things combined together. But what we can do in here is also return JSX, much like we did down here. This is just really the handler for that data. So now what we can do then is bring in that JSX, and we can grab the row data like our .flight data. Or if we are still experimenting and looking at it, we could do JSON.stringify of that row data. So if we save that and take a look, it's basically the same data, but those brackets are gone. Right. So now what I can do, of course, is grab the flight date and the airports and all that. So let's go ahead and just grab these. I'm going to come in here, paste it in, and just go ahead and give a p tag, and we'll do row.flight data, and we'll do another p tag of starting airport, and then another one of ending airport, and then the price. Maybe the date as well. We might as well have it in there. Although realistically, we do already have the date in there, but realistically this data we probably won't actually ever end up showing, but it is important to see how it ends up working, right? So we've got all of this data in here. Kind of looks funny. One other thing that we have is this IDX here. So if you actually look in the element, or if you look in the console log, you're going to see this each child in a list should have a unique key property. All that's saying is we are iterating through. We're doing a loop here. Each iteration needs to have its own unique key, and that's why that IDX is there. And we could even pass it further and say something like flight data dash, and then that IDX. Now each row actually does have its own index value as well. So the rows do have an ID, but it's not the same thing as this IDX. This is actually a lot closer, if you're familiar with Python, to using enumerate, because it gives you the value and the IDX value as well. So in Python, it's for I and row in enumerate data. This is basically the same thing. In this case, it's just handling it right here. And of course, it's returning JSX values. Cool, so now that we've got that, we don't need to console log anything, but we've got that data coming through. It's rendered, but of course I actually probably want to have a link here. So a href like flights / the row.id, something like this. And that would be then each row itself would have that. And then this href could be a string substitutable string like this. So this element can then actually use that row data, which we come through here. Using Tailwind, it removes the styling other than maybe the button click. And when we try to go to that page, of course, it's not found. Now, one of the other things you might consider doing here is you would say like our flight row link is equal to this data right here. And then you go ahead and put it in like that, in which case it now has that link as well. So what we see here is it's just kind of a self-contained component, if you will. It's not fully a component like a normal React component is, but it is fairly self-contained, and we can do all sorts of stuff related to the parameters that are passing through, which is really, really nice. So let's go ahead and actually take a look at how to handle the detail view of any given flight itself. In a moment, we're going to go ahead and create the detail view for any given flight. So when we go to this URL based off of the flight ID, we want to create this out. Before I do that, I want to actually improve the interface here and actually have some links coming through for one of these items or every single link. Now, the way we do this is by using Tailwind classes. So back into our page function here, I'm going to go ahead and do const, and we'll call this our link class, or our link CSS, or our link styles. But the idea being I want to do maybe like a text blue 500 and then a hover of text blue 900, something like that. And then I can use this class here directly on my element. So I'm going to go ahead and save that. I'll refresh in here. And what do you know? Here is those links coming through. Now, Tailwind has a lot of things like this, which is really, really cool because we can change it based off of what state that we're looking at. So there's even something for dark mode where you can do text like gray, 300 or 400, and then dark hover, text gray, 1000 or something like, or 900. Right, so you can do all sorts of things in here with colors, with Tailwind, and it works just natively with Next.js. And so if we actually look at the colors that you might want to use, here's a bunch of the colors that are just available to you with Tailwind on TailwindCSS. So feel free to navigate through here. You can also do custom colors as well, but these are just the default ones that are ready for you to use, and you can just play around with that. Like so emerald here, right? So if we came back in and we wanted to change this to emerald, you would just change the blue to emerald, and then we come back into our app, and there you go. There's the color change. So there's a lot of really good reasons to use Tailwind. This is just a little small piece of it among many, many others. All right, so now we're going to go ahead and create our detail view using Next.js. So of course, when we go into one of these links here, I want this to actually work. Okay, so this is called a dynamic route. So before I do the dynamic route, I'm going to do just sort of a static route. So using Next.js, and more specifically using app router in Next.js, we're going to be in this app folder here, and we're going to declare our first route, which is simply flights. That's it, just flights. I'm going to literally copy this page here, bring it over. Now, in my case, it says home. I can leave it as home, or I could call it my flight page or flight list page or something like that. Now, with Next.js or with JavaScript in general, a lot of the times when you are exporting a default function of some kind, the name of that function doesn't matter, as denoted by this right here. So this is a default function. So if I said ABC here, I would just have to change that to ABC. That's not convention, of course, but that's what you can do with these default functions. So the actual name here matters not a whole lot. So with this in mind, if I go back into just /flights, I can now see that same page rendered out. And it's based off of flights being part of the path, and then page.js is what will render out that page. So if you change this to something different like abc.js, it's not going to find it, right? So you actually have to call it page.js. That is a file convention for this. There are others that we can look at in just a moment. But with this in mind, I want a dynamic route, one that changes based off of this. So to create a dynamic route, we're going to create another folder inside of here. with brackets around it, and then the argument we want to name the dynamic route. In our case, this argument is just going to be simply ID. And so inside of this directory now, we'll do another page.js. And in this case, I'll do my export default function. And again, we can call it whatever we'd like, but in this case, I'll call this my flight detail page. And this one does have some arguments in here that we'll look at right now. So we'll do params in here, and we can also do something called search params, but we'll just leave in params and just focus on that. And this again is still going to be a function, and it needs to return JSX. So I'll just go ahead and say we'll just stringify or JSON.stringify the params themselves. We save that, and now going into a detail page, if we go in here, we now see the parameters. So if I change the folder name or the brackets, what's in the brackets there to ABC, that will change the parameter value as well. And you can have nested parameters too. So like all the way up, these brackets just give us parameters. So let's take a look at that. I'm going to paste this in again, and this will be, let's say, flight ID. Okay, so I'm going to bring this up to the root here, or rather bring the ABC into it. We'll move that in just to take a look at this. So now we got a page not found, or rather it's a flight ID page. So we've got multiple. First off, the flight ID, we've got this page here. And then inside of ABC, we've got this detail page. So I'll call this just ABC detail page. And so what we're getting with the root flight page, we've got 0 there. And if I go to another one, I now have both of those parameters. So those are the dynamic parameters. That's how they work. So I'm going to get rid of this nested one. We don't need that many. And so we could use flight ID here. We could use actual ID. I think using ID makes a little bit more sense in this case because it's in the flight directory. If it wasn't in the flight directory, if it was just on the root directory, then I would definitely use flight ID in here. But with this in mind now, I've got my flight detail page, and it's going to work just like our flight list page. That is, we're going to use our URL. We're going to go ahead and grab that fetcher. We're going to do all of the same sort of stuff. And again, we will use client. Okay, and then I'll go ahead and come in here and grab that data. And in this case, I will just, once again, render out stringify data, but this will be based off of the data itself. And div, and then I'll also grab that loading and fail to load stuff as well. Great. So we save this, and then the URL itself is not going to be flight this time. We're going to use some JavaScript string substitution with $ curly brackets, and we'll use a slash here. The ID, we can unpack it from the parameters like this. So using those curly brackets is how you can actually get a dictionary value, and you can pass this in. Another way to do that is to take it out of those brackets and just do params and params.id, and that will give us the same value. But what unpacking it like this is convention. It's a really nice way to get those key value pairs. So anyways, with this in mind, we can now go into flights/0, take a look, and we got main CSS class not defined. Yes, I used it again, but I did not define it. So let's go ahead and grab that. And I'll just bring that in, and we'll use it again down here. We might as well. And there we go. And there is our detail view page data now. So of course I could style it. I could do all sorts of things to make it look a little bit better. But realistically, I'm just trying to give you the lay of the land when it comes to using Next.js. There's a lot more to Next.js that we're just not going to cover. But the idea being that we can now actually render out this data. Now, there is one key thing that we don't want to violate, and that is called repeating ourselves. We don't want to violate that in the case of dry. Do not repeat yourself. We already repeated ourselves twice with this fetcher function here. So I actually want to change that a little bit by using a Next.js component or our own custom component that we can then reuse over and over again to actually do all of the rendering as we see fit. Now, I've been violating dry all over the place in the Next.js application. A good example of this is this main CSS class. This comes up many, many different times, and it's reused a lot, which to me tells me it needs to be in a different place. It needs to be somewhere that actually renders out all of these different pages. But we also have the index page, which is in the root of the app file, which is page.js. as well as our flights list page, which of course is /flights. And so both of these pages are identical, which is of course not something we want. So what we're going to do now is we're going to take a look at the file name conventions. So going into the documentation, if you go into App Router, under File Conventions, we see all of these names in here. Now, some of these things we've already looked at in the terms of page.js. We have these like dynamic routing pages that we can use. But then there's also something called layout.js, which allows us to adjust the layout for any given component. So what we see here is a component of app/dashboard/layout. That is not a whole lot different than saying flights instead of dashboard. We can actually change the layout directly in there by creating a page called layout.js. So if I do layout.js in here, I can actually copy my main layout.js, bring this in here, and we'll go ahead and get rid of a few things related to it. But we've got our flight layout. And in this case, we would just say section and then children. Right? And so this actually didn't really change much other than the fact that now we've got a section element around this item, which is seen right here inside of the HTML. So another reason to bring this up is, yeah, it's cool that we can change the layout as we see fit. And if I get rid of this children element here and refresh, nothing comes in. No surprise there, because that child element needs to be rendered within this layout. Now we also have this global layout, which is in the root of our project, which is exactly what I just copied. But the idea being is we can now come in here and put a main element inside of this. And then what do you know? We can absolutely reuse that CSS class or just move it into this element. So I can go ahead and cut it out of the page itself, bring it on over into that root layout, and then we can just add the class name in here for that. This also would be a good place to render out our navigation. So if we had a nav bar, we could bring it in here as well, something like this, but I'm actually not going to do that at this point. So with this main class CSS, we also want to get rid of it wherever it shows up now, because we shouldn't need it anymore. So I can go ahead and get rid of it here, I can get rid of it here, and I can scroll down. This one, I no longer need the main even, I can just call it a div and get rid of it there as well. And so we save that. And then in my flights page, same thing. We don't need that main CSS class any longer anywhere we see it. So we should only really have it in one place now. And that way we are not repeating ourselves so much. Okay, great. But I'm still repeating myself slightly. And that, of course, is the flights page and the home page are doing the same sort of thing. So what that means is it's actually a good time to import that flights function. So we're going to go ahead and import the flights list page, this function right here. We're going to import flight list page from ./flights/page, and we'll go ahead and render that out instead of all of this. So I'll just return that flights list page, rendered out as an element, just like that. And I can get rid of these imports. And what do you know? In my index page, as well as my flights page, I'm rendering the same data, same exact element, which is pretty cool. It's really nice that I'm able to do that. And that's a big function of React, is you can reuse these components over and over again. And so the page.js, there's one more thing I want to change about it, is how I'm actually importing this. Is I want to import it as @/app flights layout page, because now what I can do then is I can actually come in, and if I wanted to create another element, let's say for instance prices, and I want to copy this page on over into prices, it's going to import the same thing. And I don't have to worry about the route, like the actual folder that it's in at all. I can just use that @ sign and it'll go in the root of my src folder, and then I'll be able to render things out right in there. Now this flight prices I'm not actually going to use. This actual import itself is going to become a lot more important when we make a reusable link itself. Let's do that now. Now we're going to take a look at how to create a reusable link with Next.js. Now to do this, I'm going to go ahead and create a new folder inside of app. and I'll call this utils, and I'll go ahead and come in here and I'll just call this my navigation.js. So navigation being the link itself. Now what we've got inside of Next.js is a link element that we can use, which we can import from the next link element just like this. And so what I want to do is I want to have my own link element. So we'll call this export function my link. And it's going to be basically the same thing. So it's the function with the properties coming through here, and then it's going to return the actual next link with those properties unpacked. So, of course, the reason for this is very similar to that main CSS class, right? I want to have a default link CSS in here. So that link we already actually declared right in our flight list page. So I'm going to go ahead and cut this out, bring it into our navigation here, and paste it in. And now I'm going to go ahead and say my class name equals to that link CSS class. But the thing is, the props might already have a class name in here. So what I like to do is unpack this and say class name, and then ... props. So this now takes the class out of the props value. And so I can actually use class name and do something like this. So if that class name exists, then we'll use that one. If it doesn't, we'll use the default one, which is what we're using here. And then I'm still unpacking all of those other properties as it normally would. So I also like to do the children element in here. Now the reason for this is so that I can then render out those children or those child elements in here just like that. Okay, so we're a lot closer to basically the default link that's coming from Next.js with our own classes. Now the idea here is using the default link takes place of a anchor tag or a tag. The reason that we use that is the Next.js link is going to be a little bit more efficient for all kinds of requests. But overall, this is basically what we're going to be doing. Now I actually want to call this function link. Now I'm going to change this to being default as next link. So that takes in the default import and names it next link. And so I can just rename these things like that. And then I can call this link 2. So the other thing that we might notice here is the next/link is the import for Next.js's link. Let's copy it. And I'm going to change this to being link as well. So I'm sort of copying this mostly so I can basically have a drop-in replacement. So now I'm going to go ahead and call this my default. In other words, going back into page.js, if you already had to import the link from next link and you decided this is the way you were going to go about doing it, you totally could. Just like that. But if you wanted to use our now custom one, we would just do @/app utils/link. And what do you know? Now it's ours. And now we don't actually need that link CSS class anymore. And this should render out the same exact information, which if we go into our flights or our home page, we now see that those links are in there. And so now anywhere I want to, I can just reuse those links with those CSS classes. Now the other thing that's nice about this, something to think about, is maybe you want to monitor with the session based off of what links are being clicked and where. This would be a pretty easy way to do it. You would do it right inside of this function here. Not something I'm going to cover right now, but it is something to think about. So what we've got now is we've reduced even more of our code just to render out some of these different pages. And we've made it a lot more reusable and really easy to just move things around. So the next part of this is I actually want to do the same concept with our URL here. I want a utility that allows me to just easily call my API wherever I need to without having to have all of this redefined everywhere I go. So let's take a look at how to do that now. Now we're going to go ahead and create a utility function to make API requests for us. So inside of my utils here, I'm going to go ahead and create API.js. Now, Next.js can create an API for you. It can do the backend stuff. So I would not recommend putting a new folder in here called API. Instead, keeping it in as utils is highly recommended. And so the idea here is we're going to be doing something very similar to what we've already seen. So I'll bring it in to this API here. And what I want is to be able to recall this same thing over and over again. So this is really going to be our GET request, which we could also call our API GET request. And we're going to take in just a path here. So what I want to do is with this API request, I want to actually return all of this same data, or really just anything that comes from use SWR. So I'll go ahead and call this my SWR data or response. And then that's what I'm actually going to return here. Great. I don't need this link anymore. But now I won't have to redefine fetcher everywhere I go. I can just call this API GET request. So what I want here is this path. I'm going to use this path. So I'll go ahead and say const endpoint equals to this path. But the thing is, the path could be defined in many different ways. So users could actually say, users or ourselves, our developer, can actually say flight/flight and maybe even flights, something like that, right? So those are all potentially valid paths. And so the main one I'm concerned about is this flight right here. So what I want to do here is just say path starts with that slash. Then what I'm going to do is I'm going to take a slice of it, which is going to be basically one and then everything else, right? So I'm starting here and then going forward. Otherwise, I'll just go ahead and take that path. And then we've got our endpoint here. This is going to be our URL that we can bring in. And we'll just go ahead and change that to be $path. Great. Okay, so this, of course, is our global endpoint also. So I'm going to go ahead and say const my API base URL, something like that. And I'm going to leave it as capitalized because maybe later we'll want to be able to change this based off of other values. And so once again, I'll do $ and that. And notice that there is a slash in there because there's not a slash here. Great. And so we can also check with if our actual URL has a slash at the end, but I think our FastAPI application will handle it either way, which is something that you'd need to be aware of if it wasn't handling it. But the FastAPI application, if we take a look at that in main.py, none of these actually end with slashes. Flights does, but the actual ID doesn't, which is pretty interesting. Okay, cool. So back into our API here, we now have this API GET request that I can use or attempt to use in other places. So the first one is going to be our just a general flights here. And now I'm going to go ahead and import the API GET request from our @app utils and API. Okay, and it is my default function, so that should work. We could also consider this as our API client. Let's actually rename it to API client just to make things not confusing, hopefully ever, with some of the Next.js functions. Okay, so we've got our import API request. I actually want to call this perform API GET request, and we'll name it the same in both places. Cool. So with this in mind now, I can actually just replace this and just put /flights. Now again, that path will be adjusted as needed, and there we go. That's the same exact thing, but now I don't need that use SWR, and I also don't need that fetcher. I can now use this wherever I need. So back into my other page, I can get rid of these, import that one, and then our URL, or rather our path, is now going to be that. And then we'll just come in and say path and path. What do you know? One more step towards things being a little bit more reusable and more prepared for production. Now, we have one critical issue with our current perform API GET request function, and that is if we go to something that just simply doesn't exist, this is what we get. This is not an integer, so let's go ahead and change that to an actual integer. I get this detail price not found, which is fine, but it's also not the standard Next.js error page. So we want to actually change it so it is the Next.js error page. So to do that, we have to come back into our API client and take a look at this fetcher function. Inside of the SJR documentation, if you scroll down to the error handling and you take a look at this fetcher right here, this one is much preferred to the one we have. So the reason being, we'll see in just a moment, but the other reason I have this API client is so that I can change this fetcher whenever I need to. And this is a good reason for it. So right here, I'm going to go ahead and copy this. Even if you don't copy it, the code itself is fairly straightforward as to what's happening. The default value is going to return JSON if it's an OK request. If it's not an OK request, it's going to run an error. As it stands right now, it's basically the exact same thing. So let's go ahead and take a look as to why, or at least an example of that. I go in here, and there's that flight. Great. Put in a flight number that just does not exist, and I get failed to load. So definitely slightly different. So let's take a look as to how I can better address this. So now what it's doing is it's actually rendering out an error because it is an actual error now. This error is coming from that fetcher. It's also coming from our response from our API. So if you remember back into our API itself, what we did was we raised an HTTP exception 404 with this detail in here. So it is giving us detail back, which we just don't see yet. So going back into that page, if we wanted to see that data, what we could do is do JSON.stringify the error itself. And now we can see that data all over again, right? It's slightly modified because of what we did with our fetcher. The reason it's slightly modified is we are creating the error here, and then we're also adding in additional data. So this info here, this is the actual data from the backend, and then we've got a status code as well. Now, of course, it's really important that the API itself returns back JSON data. Otherwise, this fetcher will also have an error because it's trying to return JSON. So we could have additional checks in here to make sure that the content type that's coming back to us is JSON, but that's just not something I'm going to cover right now. Okay, but we do get a status code now, which is what is the whole thing that I was going after here, is having some sort of status code. So in this error clause here, I can now come in and bring this in and change it slightly. So the default value that I could use is just rendering out the error directly from Next.js. So I'm going to go ahead and import error. Actually, I'll bring this above here. I'm going to import the error class, and this is from next/error. And this error class here, I can render out this component instead of what I have. I can return, error just like that. And what that's going to do is we get this client-side exception. It doesn't really give us a whole lot of detail. But what we can also do is bring in something like a status code. And now I can do that error.status. Great. So I refresh in here, and there's my 404 page. Now, since I actually used what was inside of SWR, I just copied and pasted stuff. I actually would prefer it to have .status code like that. So let's see if we can do that with our API client, just changing this to status code itself. And there we go. So it's still that same sort of status code that's going on in here, which is great. Now, the way it's rendering out is based off of the layout, of course, right? So that's something to be aware of as well. Now, the other thing is we can use something called not found. There's another function called not found. So we're going to import the not found function from next/navigation. And this one, I'm actually going to say if the error.status code is equal to 404, then I'll go ahead and call that not found error, that not found function. So re-rendering this out, same sort of thing going on here, still that 404 page, but what I can do now is use those file conventions again. You may have noticed this not found.js in here. I can now use that same sort of idea, copy and paste it, bring it into the same route as the ID itself. So we can do not found.js in here. We can paste this in, and now I can say the flight was not found. Please try again. or something along those lines. And once again, the link itself, we're going to go ahead and do from app or at app/utils/link. And then that way it actually renders that out as well. And in this case, I can go ahead and just do return to flights, something like that. Great. So with this in mind, let's go ahead and take a look. Flight was not found. Please try again. Return to flights. And there it goes. It brings me back to flights. And again, if I do some gibberish here that doesn't exist, once again, it works. Whereas all of the other pages don't do that, right? They still go to that original 404 page, which I could also modify with the same not found in the root of our app. The reason I call not found here, let's go ahead and comment this out for a moment and see if this same error will render out the not found as well. So going back into flights, going back into a single flight and running some flight number that doesn't exist. Oops, that was me pressing all the keys and getting gibberish coming back. It does that 404 page, right? So if we want to render out our own 404 page, we use that not found function, and that will go to the closest not found inside of the folder that it's in, which is what's happening here. So even on our flights page, if we wanted to adjust that, which in this case, it doesn't actually make sense because it's not dynamic, we could potentially do it. But the idea being we now have a much better way of handling request errors based off of a GET request in this case. Now we're going to go ahead and create a form inside of Next.js so we can send a post request to our backend, a post request with data that we're looking for from this form. Initially, I'll just do a basic form and then we'll modify it as we see fit. So first and foremost, what I'm going to do here is I'm going to come into flights and we're going to create a file called forms.js and we're going to start creating our form. So export default function, and this will be our flight predict form. And we'll go ahead and pass in props if need be. And then we're going to go ahead and return back a form element here. Okay, so we could wrap it into a div, but I think just the form is probably fine. Now, what we want to do here is I'm going to go ahead and also put in my input type of text, and I'll give it a name of, let's just call it our query. Okay, so we'll probably have to adjust what queries we're actually doing, but for now I'm just going to leave it like that, and I'll add in a placeholder, and we'll go ahead and say your query. And with any given form, you would also have a button. In our case, we'll give it a button type of submit. And we'll go ahead and add in the value here, and we'll just go ahead and say send. Great. So within React.js, and also, of course, within Next.js, what we can do is we can actually handle the submit when it happens. So to do that, we create a callback function called handle submit. You can call it whatever you like, but it will pass in the event here, and we'll go ahead and handle this submit event. So we'll go ahead and say on submit, the event itself. This is going to handle the event, and we'll go ahead and console log event.target, just like that. Cool. So with this, let's go ahead and render this out inside of my home page. I'll just go ahead and copy this import a little bit and say forms, and it's going to be our flight predict form. And so inside of my home element here, I'll go ahead and create a new div element, put in our flight predict form, and right above our flight list page. Save it, and let's go into our home page now, and there we go. So here's our query. We can run that, and it automatically does a GET request. If we inspect the console and preserve the log and hit send, we've got our form coming through in there. Okay, so back into my forms here, then I want to do event.prevent default, which will mean that it won't automatically do that GET request like we saw up here. So I'll go ahead and get rid of that. And then I'll just pass this in and submit it, and there's my form. Great. Okay, so I want to convert this event.target into the actual values itself. To do this, we're going to go ahead and first off say const form data equals to new form data from event.target, and then const form object from, this is going to be object.fromEntries, and that's our form data entries. And then finally, we'll go ahead and do JSON data equals to JSON.stringify the form object. And then we'll go ahead and console log this out. Save that. And let's refresh in here, run it, send. There's our JSON data that I can now send back to the backend. Great. So in this case, the backend itself, where we're going to be sending this. So back into our utils, we've got this API client for performing a GET request. So now, do we want to actually perform a GET request as well, or do we want to perform a POST request? I'm going to stick with a POST request, but I will export the API base URL from this API client. So back into my form, I can now import that base URL, and this is going to be from our app / our utils and link, or rather API client. Okay, great. So with this in mind, then I'll go ahead and say my endpoint equals to the base API URL / and this time it's going to be predict or something like that. We don't have it set up yet, but we'll leave it in as predict. Then we will go ahead and use fetch right in here. So what this is going to look like is just simply calling fetch with a asynchronous handler. Using the asynchronous handler handles it in a way that I really like. So we'll call this async. And now we'll go ahead and do const response equals to await fetch to this endpoint. And then we'll pass in some options here. The first option is the method being post data, because it is going to be post data in terms of our form. We want to send it in as post data. We don't have to put quotes for key value pairs here, except for if we have something like content type. In this case, it's application JSON. And then we'll go ahead and pass in our body data, which is that JSON data. And so that should give us some sort of response, which we can console log out that response. And then we can also go ahead and say const data equals to await response.json. And then once again, we can console log this out. Okay, so if we didn't use async, we would actually have to do something very similar to our fetcher function. We would basically use it almost like this, but again, this is also using async, so it's not quite the same, but our old fetcher function that we were using was not using async, so you could take a look at that if you're familiar or not familiar with fetch. Okay, great. So now that we've got this should be application JSON, not SJON. Okay, save this, and we'll go ahead and take a look at our form itself. We'll do a quick refresh in here. We send it, and we get a CORS error, type CORS, status 404, and then also a detail not found. So the actual request itself is not a CORS error. I made a mistake there, but rather it is a cross-origin request. The response itself is. So the predict method doesn't actually do anything yet. So let's go into main.py, and I'll go ahead and copy my post method here for hello world and just change this into predict. And we'll go ahead and say write to predict. In this case, I'll go ahead and respond back with just prediction and world. Not really valid prediction, but we can now actually have an endpoint to use. So let's go ahead and refresh in our next app and hit send. And so our prediction comes back as world. It's still a cross-origin request. The status is 200, and we've got everything working as we want it to in the sense of the functionality is there. We still need to finish out the FastAPI stuff, but that's how we actually create forms with Next.js. Now, this is not the only way to do it, but to me, this is the most functional way because we can add in other arguments. So arg2, right, something like that, and then we can come back in here and pass in two queries, send that, and that will send back into our backend appropriately. And we can actually console log out the JSON data again, just so we can see that it is sending both data in there with that new addition. So we send it in, and there's that new data coming in there. So other methods might handle the inputs directly, which you can do with something called onChange, having a callback handler and all that. But this right here is, to me, the most flexible and therefore the one we're going to end up using. And so let's go ahead and actually build in the backend part of this to make sure that that's working as well. Now it's time to bring our MindsDB API calls into our FastAPI service. So what we're going to be doing here is going based off of our MindsDB API calls notebook, right? So it's going to be a lot of these same sort of things repeated into our FastAPI application. So jumping into backend here, I'm going to create a new folder called AI. Inside of here, I'm going to have two files. One is going to be connect.py. The next is going to be predict.py. Great. So what we want to do here is the first one is connecting to MindsDB, which happens inside of this notebook as well. So I'll go ahead and bring all of this stuff over, just copying and pasting, and then we'll go ahead and grab this get MindsDB session. Great. Now, before I go much further with this, I also want to grab my DB here and get DB session. I'm going to bring this on over as well so we can discuss that in a moment. Okay, so the idea here is we probably don't need to assert that these are not none inside of the function itself. And we also probably don't need the base URL inside of the session, but rather inside of predict. Okay, so coming back into the session, this is going to be from backend.env, and then we've got our requests here. So the get MindsDB session, we're actually going to call it init MindsDB session so that we can have our get MindsDB session here. And this session itself will be calling the init session, and then it's going to close it once it's done, right? So we can actually reuse this a few times, hopefully, based off of our various requests. This is identical to what we did with the database as well. So this is what we'll actually use on our views. So back into main.py, we can import this now. So coming in here, we'll do from backend.ai, we're going to import, or ai.connect rather, we're going to import that get MindsDB session. Oh, inside of AI, I also want to add in one more thing in here, and that is going to be the init file. So addender or two underscores init, and we've got our get MindsDB session. So the same idea from our flight prices, roughly speaking, in terms of the DB session, right? So I could copy this and paste in here. This time it's not DB session, but rather AI session. And this is not going to be session local. We'll have to adjust that, but it will depend on the get MindsDB session. So what is the actual session itself? What's the class that we need to declare this as? Well, it's request.session. It's right there. So that's the actual session that we need to use, that exact class. So back into main.py, I'm going to import that exact class. So we'll do from requests import session as requests session. Okay, and then we'll bring this down, and there is our AI session. We're really close to what we need to do. The next thing is going to be predict.py, the actual execution of those predictions. So first off, the MindsDB query, we'll bring that one in. Next up, we're going to go ahead and bring in our predict query, just like that. The raw request one, we probably won't need to use very often, so I'll leave that in as a false response. Okay, so we've got our predict query here. So now back into main.py, I can bring that one in with from backend.ai.predict, or we'll import actually predict like this, much like we did with the utils down here. And then I'll go ahead and use this function in here. So I'll call, let's give the response or the predictions equals to predict dot, and it's predict query. And we'll actually use all the defaults. So let's go ahead and use those for now, because we don't have arguments coming in yet from Next.js. Okay, great. So those predictions are then going to be returned back through here, which should be a list of items. So we'll go ahead and say predictions. Great, so with this in mind, let's just make sure that we have no errors here. As far as Next.js is concerned, doesn't look like I have errors. As far as FastAPI is concerned, doesn't look like I have any import errors either. Predict.py doesn't really need much in here. In fact, we could probably put it in the same module as connect, but maybe we want to have other predictions in the future, so we'll leave predict.py itself as is, right? So this might be predict flight prices in the future as well, not just predict query, but we'll leave it in like that as well. Okay, cool. So with the request coming through, and since we now have that Next.js app function, I'm going to go ahead and do perform this. And I'll hit send, and I get an error. So let's go ahead and see what the error is. Console log. We got failed to fetch. So let's go ahead and refresh the page again and see what's going on. Once again, we got failed to fetch. Okay, great. So I see why. This predict query is missing the session. So let's bring that in first, as it says right there. Cool. Easy enough, but notice that Next.js raises this error on the failed to fetch. Cool. So at the very least, it's going to give us, our users, a better interface than just some random server error or whatever. It just says error. Granted, it's not that great of one, but it is one. Okay, so I sent this, and it actually is performing the request. It just takes a little bit of while because it's going to call our FastAPI service, which is going to be pretty fast, but then it's going to call the predictions, which does take a little bit of time, as we've already seen inside of the Jupyter Notebook, but there's all of our predictions right there. So once again, I can actually iterate through here and just kind of give suggestions or kind of just say, hey, this is what it's probably going to cost based off of that route that you're trying to go in. Now, we're going to have to sort of ignore the flight date because, well, this isn't the most recent data, but what we do have is the actual fares themselves and also different airlines that we might end up using based off of this as well, which is pretty cool. So granted, I have to build out my user interface quite a bit more inside of Next, but we now have the groundwork for creating those, this actual predictions based off of some input data that we just use default for now. Our dataset doesn't have very many airports in it. We only have a handful of them, but the actual data we have about those airports is minimal. So what we're going to do now is we're going to extract some of that data so that our user interface can be a lot more user-friendly. In other words, I don't want to have my users type out SFO to use the San Francisco airport or BOS to use the Boston airport. Instead, I want them to select from a dropdown as to what airport they want to use and where they're going. So this is going to be done using a bunch of things we've already done. So I created a brand new notebook that basically is building off of previous notebooks that you could duplicate the transform price data notebook and basically get a lot of the same things we're going to be doing here. We're also going to be using the airports data, this Python package that will help us enrich our data, as we'll see in a moment. And we're using the IATA, the 3-letter location code that is available to us. Notice this one has over 7,000. We have like a handful of that. So with this in mind, we're going to go ahead and run a few of the things that we've already done, loading in our flight price data, and then we will see all of these values here. Then what we'll do is we'll get our starting airports and our destination airports as unique lists, and that's how you do it. And then if you turn it into a set, you can subtract from each other and see what's missing. In this case, we have nothing missing. That means that our starting airports go to our destination airports and our destination airports go to our starting airports. They all kind of intertwine. Granted, not all airlines will go to all of those places, but at least the airports themselves are unique, or they actually match in this data set. Okay, so after we have that, we're going to go ahead and install the airports data here. With this in mind, I'm also going to go ahead and jump right into requirements.txt and add that in as well. Now, a big part of the reason is because this same data set, perhaps I want to load it again in FastAPI, perhaps not, right? You could use this data set for FastAPI instead of what we're doing, which is we're going to load it into our MariaDB instance. So with this, we can then map the values from the airports data package to either our starting or destination airports because they're the same airports. So once we do that, we then get this out. What we see here is JFK. That's the John F. Kennedy Airport. I already know where this is. A lot of people do. It's in New York. But if we scroll down a bit, the Boston Airport has a completely different name than just Boston Airport. Because of course it does. No airport is called the city name airport that I'm aware of. Maybe there's probably some out there, but generally speaking, the airport names themselves are slightly different. So we want to keep this in mind when we're building this out. and when we actually start using this data. So next up, I turn this into a data frame so that I can see the data types, but then also so I can easily export it to our database, which is what we do here. And notice there's only 16 rows, not a whole lot. So next up, what I want to do is just model out the actual SQLAlchemy model. And I'm just going to go ahead and copy and paste this based off of this data. So here's all the data I'm using, and here's how I actually implement it in terms of SQLAlchemy. It's not any different than what we've already seen. I can obviously reuse this table name here and here, and we want to be explicit about this table name because we're going to use this elsewhere shortly. So now that we've got that, the next thing would be to turn this into a schema. So with our Pydantic items, I'm going to go ahead and do this. Now you might recall that perhaps you want to have all of this data, perhaps you do not. In my case, I do not. Instead, what I want is I want a label and a value. So the label itself is going to be probably our name column, whereas, we don't need duplicate ones, but the label itself is going to be the name of the airport. The value is going to be the code that we're using. The reason I'm just calling it label and value is it's going to be a lot easier to render this out when we bring it into Next.js. But of course, we could change the schema how we see fit later if we decide. So to change label to being mapped to name, we just use the field class in here, and then we just put the alias itself, and we put it into what we want to alias, which is the name itself. And we can do the same thing with the value. In this case, it's the IATA. That's the code itself. Okay, and so now we're going to reuse that session that we've done before many different times, and I'm going to go ahead and paste it in with the airport schema as well. And so we've got model validate, the row value, and then we're dumping the JSON data. Now, what I did before was essentially from ORM, which is the old way of doing it with Pydantic, and then printing data.json, which would have given you, a deprecation warning that those values are not going to be true any longer. But one of the things that is true is we need to update our Pydantic to have the class config of from attributes being true. And now if we run that, we can see all of the data that we're going to then send to Next.js. And so now we're going to go ahead and grab these things and add them into our project. So the first thing that I'm going to do is bring in the schema, jumping over into our schemas here. I'll just paste this one in. Notice that I have field as a new import here, so we can replace the other one just so I can have that alias data. Next up, of course, is going to be the model. So let's go ahead and take a look. We'll scroll up to the model itself and come back into our models here. Right below base, we'll go ahead and paste this one in. Float is another thing that I need to import there. Not a big deal. Then, of course, I need a utility function to actually call these things. So I'll go ahead and copy the get flight prices to being get airports. And, of course, this is going to also import the airport itself. And we'll bring this in. We probably don't need the offset at all, but I'll just leave it in there if I actually added more than 100, airports themselves. Okay, so with this in mind, I'll go into main.py and I'm going to copy flights here. Right above it, I'll go ahead and do airports. I'll get rid of the trailing slash in both places, actually, and I'll explain why in a moment. Next up, we need to grab this schema itself. So at this point, I'll probably just import the schemas directly. So we'll go ahead and do import schemas as DB schemas, and then we'll use DB schemas dot as I continue to build out more and more schemas. There we go. In every place. So DB schemas dot. Probably should have done this in the first place, but now we've done it. Okay, great. So we'll get rid of that. And then the airport one, I have it incorrect. This should be our airport schema. And then our DB utils should be get airports. Everything else is basically the same. Let's just make sure our schemas are correct. So first off, our airport schema, this looks correct. Our model also looks correct. We just tested it. Utils, airport, everything looks good here. And it's imported. Very good. So now back into main.py. Let's go ahead and just go into /airports on our rendered out item. And there it is. Okay, great. So we've got IATA and name. So it's not actually giving us different field names as we see here. And while the model dump JSON ended up doing the correct key value names, the way we change it in our field is actually swapping these out. So label and label, or IDA to be in value, and then populate by name being true, saving that, and then refreshing in our endpoint. And there we go. So now we've got those key value pairs, and this is coming directly from the populate by name configuration. You can also declare the configuration slightly different to what I've done. Pydantic has changed a little bit over time, but overall now we have our values coming through for the various airports. I probably don't even need to display the ID realistically. I probably just need the name itself of any given airport, because we're going to use these values as dropdowns, essentially dropdowns inside of our Next.js application, which is something we need to do now. Now we're going to go ahead and create our airport dropdowns inside of our Next.js application. So let's go ahead and jump into Next.js inside of app here. I'm going to go ahead and create a new folder called airports. And inside of there, I'm going to go ahead and put dropdown.js. Okay. So what we want to do is similar in some sense to grabbing the API data. So very similar to this, but then we will actually create a dropdown field. So go ahead and copy some of the things that I've already done before with the API request here. And we'll call this our airport dropdown. And what we want to return here is a select with different options. Okay, so the data itself is going to be coming from airports. And then if there is an error, we'll go ahead and say if error. Then we're going to return a empty dropdown option being error, something like that. And then if it's loading, we'll just go ahead and say loading. Okay. And let's bring this into our form. So go ahead and make sure it's the default function here. So let's go ahead and import it with import airport dropdown from @app airports dropdown. Okay, so airport dropdown now will come in right there. So we refresh and we got nothing because it's no longer loading or anything like that. So what I want to do then, of course, is grab that data and we'll go ahead and say display data is equal to that same data. We'll explain this in a little bit, but for now we'll go ahead and do our display data and we'll go ahead and run display data.map, and we want to map through all of the data here as different options. So we're going to return those options. And if we have to remember that the airport itself, or the first item in there, is going to be the actual data. The second item is going to be the index value of that data inside of the array or the list. And so what we've got here is our key. Then I'll go ahead and say my value is airport.value, and then the label itself is airport.label. Okay, so with that saved, now I can see, what do you know? There's my airports with the actual value. So one other thing that you might consider doing is including this airport value as something that comes in there as well, so that the dropdown shows those values also, right? And so I could absolutely improve this overall, but right now it's not listed out in alphabetical order, at least based off of the airport or the airline itself. So like what might be a good idea based off of this particular data and the fact that we're not trying to make this too advanced here, we're going to go ahead and just put the airport value first so then you can pick them, and then I'll order them by that airport value. So that means that in here then I need to have some sort of sorted value in here, which I'm not going to do quite yet. But what I will do is I'm going to come in and bring in another airport drop down here. So we want to have 2, right? Sort of makes sense. So then that means on my form, if I change that data, I want to be able to update the state of that data. So how I'm going to handle this is going to be, first off, I want to give each one of these a name. So the name being, let's say, for instance, our starting airport, and then our destination airport. Okay, so that name I want to bring in. So I'll go ahead and unpack it from the arguments that are coming through, the property values or the props. So then I'll give the select value itself a name there. So if I refresh in here and let's do these 2 and hit send, if I look in the console, I should be able to see that same data. And there we go. So there's our starting airport and our destination airport. Now let's just verify in our backend that that's essentially what we want as far as the data is concerned. Starting airport, destination airport. Great. Okay, so that's a good start as far as those things are concerned. But something that I want to be aware of is the fact that these 2 probably can't be the same value, right? So that's definitely something we're going to want to change in the near future. But I'm going to go ahead and get rid of this right here, save it, and there we go. Okay. So of course, the other thing that we want to be aware of is possibly the airline that we want. But in this case, I'm going to skip the airline mostly because we're going to be basically going off of the date, the starting airport, the destination airport, and a few other Boolean values that we might want to add, like if it's the non-stop, for example. Great. So now that we've got this form, let's actually implement some handler for this data. Now we're going to use a Pydantic schema to serialize the requested data, as we'll see here. It's also validating it too. So what we want to do here is I'm going to take the flight price schema. I'm going to copy this and we'll paste underneath here. And this is going to just be our predict schema. Just like that. Of course, we don't have the integer in here. We don't have a flight date just yet. I will set a default value for right now, which is going to be based off of this value right here. So we'll go ahead and set that. The is nonstop, also a Boolean, default value being true. We don't want the airline name or the total fare. And we also don't need from attribute. So I'm going to keep that commented out. And I'll actually keep these in here as well. And I'll leave these as like false and false. Great. Okay. So these values are the ones we need to set. So with this in mind, let's go back into main.py, make sure we've got DB schemas here. And so what we want is our prediction request, and that's going to be of that data type. DB schemas dot our predict schema. Okay. So we'll go ahead and print this out in a moment. Let's go ahead and run that post request. From our application, we'll refresh here and just select whatever. Inspect the console. We've got our post data going through. Look into our console for our actual data otherwise, and there we go. So I'm just going to change this to, let's say, for instance, the Denver International Airport, and we'll just verify that that's coming through. Looks like it is. Great. And the default value for the flight date is also coming through. Also great. Okay, so next up, what we've got with these predictions, we can now use them. So we'll go ahead and say request data equals to predictions, and we want to grab the model data. So it's going to be .model and dump JSON. Okay, so in here, I can go ahead and grab that and then get the arguments and then grab the destination, also get that same argument. In fact, I could actually most likely unpack all of them because they all map. So let's just go ahead and unpack all of it. I'll comment this out and we'll just unpack it all as a Python dictionary would. Okay, so let's refresh in here, and this time I'm going to do LaGuardia and Chicago O'Hare. We'll send that, and we get this is coming back, but what we don't have correct is we've got an issue with our data. So Predictor must be after, oh yeah, we did model dump JSON, which I think just model dump is actually what we want now. We want the dictionary value itself, which I believe comes from model dump. Let's try it again. Same send request. And our prediction query does not actually handle all of those arguments. So let's go back into that prediction query, into AI, predict. And so we've got this right here. I'm going to go ahead and say keyword args, just capturing all of my other keyword arguments in here, as we might adjust the various things in here in just a moment. But I just want to make sure that this is working. So we'll go ahead and try again, hit send. Looks like it's sending, and we should get a response here in a moment. And there it is. And there's our predictions. Great, so that's actually working as we would have hoped. So of course the other arguments that we want in here are the basic economy and is refundable. So let's go ahead and add those in now. And I'll go ahead and say is basic economy 0, and then is refundable also 0. And then we're going to pass those in to our statement here. And t dot is basic economy equals to that value, and t dot is refundable equals to that value as well. Now, of course, these things need to exist actually as a part of our data set, right? If they don't already exist, then we are going to run into issues. But I'm really just going based off of what everything is basically based off of the original data set itself. So I didn't really modify anything there, although you definitely could have. But that was a big part of the reason why we started with the data set and worked up this way. Okay, now we can go ahead and try this out. Hit send. And once again, I should get a new prediction set based off of this stuff. And in this case, I do. Cool. And there we go. So O'Hare to Charlotte is about $200. Not that bad, $230, depending on these two airlines. Now what we want to do is ensure that our starting airport and our destination airport are just not the same. So what I'm going to do is, using the starting airport, I will then refilter out all of the destination airports so they're not the same at all. And so I'm going to do it based off of this code here, which of course is the value that we have in the airport itself, so airport.value. So what I'm going to do then is pass in a new parameter that we can have, and I'll call this filter val. Now, the reason I put this display data in here just like this is so I can do a .filter command on it, which allows me to filter data kind of like this. But basically, the idea being x being related exactly to the values that are in there. So x.value is available. If I had it with its old thing, it would be something like a TIA or something like that. I don't remember what it was, but it was something like that. And we do value. And basically, we want to say it's not equal to the filter value, whatever that argument is coming through. So if we save it right now, it doesn't matter because there is no value there. So it's definitely not equal to that. But what I want to do is I want to have the ability to come into my form on either one and say filter val equals to, let's say, for instance, JFK. And so if I run that and refresh in here, I should not see that value. But the way it's done right now is if I have to have like a capitalized JFK. So I don't want that. I want the filter to be a little bit more dynamic than that. So I'll go ahead and lowercase these two values with this string substitution and to locale lowercase. And we want this on both of them. So $ and filter, there we go. And so now what I can do is in my form, I can pass in that lowercase value. And like I said, I want the destination one, to not have what the first one is. But of course, right now it's just filtering JFK out. This still needs to be dynamic. So in order to make it dynamic or reactive, what we're going to do is we're going to import the useState hook from React. And I also want to just verify that this form is doing useClient as well, which it should be, but in this case, it's definitely going to need to be with useState. So with this in mind, we're now going to go ahead and say const And this is going to be my start airport val. And we'll do set start airport val. And this is going to be use state. And we'll start at JFK. The next one, we're going to go ahead and do that same thing. And now it's going to be end airport val and set end airport val. And this is going to be something like ORD. Again, we can grab whatever values we want to start in here. And at some point, maybe you want these to be incredibly dynamic to where they are changing based off of the user's IP address, but we're not going to be doing that here. Instead, what we're going to do is take this start val and we're going to bring it down to our filter val for our destination airport. And so I'll bring that in just like that. Now, I also may want to do the same thing with my end airport. I might want to change the starting airport filter based off of that as well. But the thing is, with my starting airport, I want that one to actually control how things are changed. In other words, I want the starting airport to always have all values in here. I don't want to filter it down at all. And so now, of course, what I need to do is be able to change the state values, the values of these based off of the changes in the dropdown itself. So to do this, we're going to come back into that dropdown and we're going to add a method here for the selector, for the select value. And this is just going to be simply on change. And we want that to pass a change value. So I'll do const handle change. And this is going to be equal to the event. And then we want to pass this here. But I also want to pass it one layer up or to the parent value, which will be on change as well. And so we'll go ahead and do if on change, then we will go ahead and call handle change with the event, or rather on change with the event. So this we'll call the parent version of on change basically. And now that we've got this, we can go ahead and come back into our forms.js. And on each one of these, I can now do on change and pass in that event. And that event itself is the same exact event it would be if there was a normal dropdown, which means that I can use the set start value, and this is going to be event.target.value. And that's what we can use for our on change event, which will definitely change my filter value in here. So if I refresh in there and I change this, they both change. Now they both might not change every single time, but certainly if I hit JFK, that one's going to change and so on. Now I did notice that there is something where it does kind of change. Let's say for instance, I go here and then I want to go here. It does seem to change every once in a while as well. So what I'm going to do then is I'm going to just break this down a little bit like that and like that and like that. And so what I want here is I want to actually monitor the changes, and basically I'll say value equals to and value equals to. The value itself, of course, is going to be the start airport. So just the start airport value. And then the destination airport will be the end airport value. And then I do also want to bring in this on change here to the airport value. And this one is going to set the end airport value. Now, why is it that I'm doing this? Well, what I'm doing now is I'm actually passing in the value that I want to display inside of here, which is the current value, whatever that might be. So that's this right here, right? So that value is going to then be basically used inside of this option key. And so I would then go ahead and just grab this one and say that it's checked. And this is going to be equal to value equals to the airport value. This should not be checked, but rather selected. Great. So selected value. And then we come in here and we do DTW. And let's go ahead and Dallas Fort Worth. Move it right above, and now it should stay in as Dallas Fort Worth, unless I actually select Dallas Fort Worth as the starting airport, in which case it then changes back to JFK or something like that. All right, so let's go ahead and run our prediction from JFK to LaGuardia. Those are really close airports. So I'm going to go ahead and send this, and I get an error. So if I open this up, it says, it couldn't fetch anything. So let's actually take a look at what that error might be. Now, first off, I already know it's not Next.js. What we see in here, Next.js is fine. I also know it's not Next.js because the error was rendered as like just this notification over here in Next.js. But of course, if I go into my, FastAPI application here, I see that I've got an error in this predict query here. It's saying that none type object is not iterable. So if we go into predict.py and scroll down to where that error is happening, which is right here, we see that none type is not iterable. In other words, this data set right here, we can't iterate through it. So what we want to do is say if dataset is none, then we'll return a empty list here. We also want to say basically if data is none too, or data is none, then we'll return an empty list. So with this in mind, let's go ahead and try it again. This time I run that and I don't think I have an error. So let's go ahead and inspect the element here. And it looks like we get a response back with predictions. Okay, so that's good. That also means that I am now ready to do some of these other arguments in here based off of the schema that we've got right here, which is just these three, Boolean values that we want to pass in. These are actually pretty simple to add. So back into our form, what I'm going to do is just copy and paste a bunch of checkboxes, a bunch of input checkboxes that we can just bring in. Now these checkboxes are basically HTML data that we can just use, and we are assigning each name according to the schema, right? So is nonstop is going to that schema, and is basic economy, and so on. And of course, that schema is then translated into these values right here, which is now what we can do. We can bring these in as well, do that same sort of request. In this case, it's not going to send anything back, but I don't see anything. So that's another problem that we absolutely want to fix with this. Now, the first way I'm going to fix it is by going into page.js. I'm going to get rid of that price data because we don't need that anymore. Instead, I'm just going to be showing my predict form. And so back into forms.js, this is where we're going to go ahead and add in additional data related to this request. So what I want here is I'm going to go ahead and say predict data, set predict data equals to use state. This time I'm going to use an object. So the first part of this object is simply loading, which will be false. It's going to be true as soon as the submit happens. So I can grab this set predict data, and basically anywhere before the actual request comes through, we can call set predict data previous value, and then do prev, and then the loading being true. Okay, so whatever we put towards the bottom, oh, and this has to be in parentheses here. So whatever we put towards the bottom of this will override any previous value. If you reverse these, the reverse will happen. So the idea being now that we have this loading value that I can use pretty much anywhere on my application. So for instance, if I did predict.loading and we do a div of loading, or rather instead of and we'll do question mark. So if it is loading, it's going to run this div here. Otherwise, it will allow us to submit that button. So we do this, and now it says loading, and I can't press anything. Great. So there's a lot of different ways on how we can handle that with the button itself. But what we can also do then is we can put the actual data that comes through. So with this in mind, we'll go ahead and grab this set predict data, and underneath the response itself, we'll go ahead and add in loading being false and the predictions being related to the data. Now the data itself, if you recall when we console logged it, is actually data and data.predictions. So if that's true, then we'll go ahead and unpack data.predictions. Otherwise, we will just return back an empty array in the case of JavaScript. Cool. So what that also means then is if I'm setting this to loading, my submit button should only work when loading is false. So what that also means then is we'll say if not loading, then we'll go ahead and be able to resubmit this form altogether. Cool. I'll get rid of the console logs in here. And now I'll go ahead and show these predictions underneath the form itself. So we'll go ahead and add in a new div here. Scroll on down. And basically we want to do the predictData.predictions.length greater than 0 and predictData.predictions. So then we'll go ahead and map that out, which if you remember, we are going to pass in the prediction and then the index value of that prediction in this array, and then we'll return back some data here. Okay, and so we need to make sure that we close this curly brackets off here. And so what I want here is basically I'll just stringify my prediction. So we'll do JSON.stringify and the prediction that's coming back, and then put the key value for that index in there as well. Okay, great. So let's refresh in here. Looks like we've got an error. So I'm going to go ahead and do prediction data and then prediction data all across the board like this. So all of those need to be true in order for it to start mapping out any sort of data. So now we'll go ahead and do a nonstop flight from, let's change it from LaGuardia to LAX, and then we'll go ahead and run this. This will take a moment because of course it's doing all of those API requests, and we're trying to find a prediction based off of this. And what do you know? There are some predictions there as far as the various data set is concerned. So with this in mind, I'm going to actually go back into my form, and I want my default value, default starting airport and end airport to be JFK and LAX, so that they actually are going to provide some sort of prediction in here, which in airport value is not actually showing up. So let's see why. And yeah, so let's go back into the airport itself. It might be just because of the value itself doesn't necessarily change the drop-down airport value itself. Yeah. We need to adjust this similar to that same filter that we had in here. So we'll go $value and to locale lowercase, and the same thing over here. And we'll just bring that in like that. There we go. And now we've got LAX in there, and we can adjust this a little bit better. Go to refundable, and now we will be able to do our various predictions through FastAPI, and then of course on to MindsDB. Now we're going to implement Tailwind global styles. So if you don't know that much about Tailwind, but you still want to use elements of it, I think this is what you're going to want to do. And so the idea here is if we go back into our flights, we've got these links here, right? These links are fine. They work really well. And this is really a React approach to having these sort of global links and their colors based off of what we had. So what we want to do is actually modify that so that the links by default, or the anchor tag, the A tag, by default uses this class right here. So this is actually pretty straightforward to do. So if we go into globals.css, which came in with our creation of Next.js, we see a bunch of different classes that we could actually use. And one more in particular is we can actually add in something called a layer, and it's going to be our base layer. And here I can now apply to my anchor tag specific different Tailwind classes with @apply. So the class I'm going to use is this one right here. I'll actually cut it out altogether, and then we'll bring it into the global classes here. And instead of emerald, I'll go ahead and go back to blue. And then again, I'll use that hover, and I'll do text underline. So all of this stuff is referenced in a lot of different places. But if we save this and do @layer_base and refresh in our Tailwind class, or maybe it's not, maybe it's just underline. Yeah, it's just underline. Okay. And so now what we've got here is the actual class being applied to all anchor tags, regardless of this link here. So this link function is probably not necessary anymore. You could probably just use the next link altogether because this is doing the same thing. So that changes a number of things related to our Next.js application that we're just not going to touch right now because we're really working on the Tailwind of it all. So what we've got is this now this anchor tag will apply everywhere that we want. So the reason I'm doing this is mostly for our form here, right? These elements here have a bunch of sort of standardized elements. And so I want to actually apply classes to them directly. So to do this, we're going to go ahead and use a tool called Flowbite.com. So Flowbite has a bunch of different Tailwind references. Even if you don't actually use Flowbite itself, it has a lot of really good Tailwind references, which is what we're going to start out with. So the first thing what I want to do is the buttons. So if I come in here to the buttons, I can see the default buttons. Here's a bunch of different colors, but these are just Tailwind classes right here. It's really easy to then use these. So let's go ahead and grab this blue one here. I'm going to go ahead and copy this whole thing and come into our globals.css and do .button-primary. And we'll go ahead and apply all of those classes. So for those of you who are very familiar with Bootstrap, you can now use the Bootstrap name for a class. But really, we're just customizing a class name based off of a bunch of other classes, which is really nice. So with this in mind, I can then bring this into my form, the actual button itself right here. I can go ahead and say class name equals to btn primary. And then we've got that button showing up as you might expect. Now that, of course, doesn't really solve the interaction of that button. So if I click it, it now still says loading, which this comes directly from the React component, which is doing this right here, right? So I'm going to go ahead and just cut out this predict button loading part and just leave in the button itself. And then up here, I'll go ahead and do it a little bit differently. So I'll do class or rather constant. And this is going to be our btn class name. And it's going to take in that loading element, and we're going to go ahead and give it some sort of class for that. Otherwise, we'll do btn primary, right? So this will allow me to then just toggle between the class states themselves. And so I can now add in a default class for that. So we come back up and we add in btn disabled, for example. Now, another thing about that btn disabled, I can also apply disabled to the button itself. So we can put it on the HTML element, and it will be disabled when it's loading, which makes a lot of sense. The label itself, maybe I want a btn label based off of that as well. So I come back up, and we do const btn label, and by default, it's going to be like help me, for example. And then, of course, if it is actually loading, we can just say loading, and there we go. So now with that in mind, I don't have the disabled button class just yet, but if I hit help me, it does basically the same thing, but it actually has that class there, and it still is a button here. So let's go ahead and add in that disabled class. Going back into Flowbite and scrolling down to the bottom on the right-hand side, go into disabled. Here's that class. We're going to go ahead and grab this and copy it. And notice that the disabled element is on the button element as well. We'll go ahead and go back into global styles here, do btn-disabled, and then apply those changes. And so now going back in, we can hit help me again. Now it looks much, much better. Cool, so we can take this same concept to other elements in here. Our select element, our radio or our checkbox, and our labels. We can do all of those things. And of course, Flowbite has a bunch of examples for this. So if we scroll down to the bottom on the left-hand side, we can grab the select item here. And I can go ahead and look for the select element and grab all of the classes that are in there. I'll copy that. I'll bring it over into these global styles, and I'll call this select. Again, I'm doing a global change here, and we're doing apply. And let's just make sure we get only the class names there. Next up is going to be the label. We've got a label right above it. Let's go ahead and just use that label. Grab that, and we'll go ahead and say label. Once again, apply. There we go. Next up is going to be our checkbox. So we go into checkbox, and we scroll down a little bit. Well, the checkbox itself is a little different than the select one, right? So it's got a input type checkbox. So this one is fairly straightforward. Let's copy the classes first, and then we'll go ahead and do input bracket type equals to checkbox. And then once again, we can apply these classes. And now if we take a look at our app, it looks quite a bit different. It's not quite what we see in Tailwind CSS, the Flowbite Tailwind of it, right? It doesn't look quite the same. And that's because of this right here. So there's a number of things we'll do related to that. But the thing we can do right now to make it a little bit closer to that is going back into our form and actually moving the input out of inside the label, which is not actually what we want to do anyway. But this is a good time to just readdress that. So the input right above the label, and finally the input right above the label. And so now it's getting closer to what we want, but it's still not quite there, right? So we still need to actually update and adjust for all of this. Let's make sure our global styles checkbox is working correctly. And yep, so I'm able to select all of these things. So to improve this, we're going to go ahead and come right back and actually take a look at how to handle various form elements. Now we're going to go ahead and update the styles for our form to match a little bit more of the examples in Flowbite and of course using Tailwind. So the idea here is if you search for forms, you'll find this right here. Here's the default form. So what I'm not sure is whether or not the label class here is the same as the one that I have put in my global styles. It might be, it also might not be. So that style seems to be okay for this one, but what about the actual input class itself? So let's go ahead and try that one instead and see if that actually makes a difference or changes anything. And it does. So I go ahead and save that and we refresh that. It looks a lot better. Great. So again, we can actually apply these different styles to the various labels as we see fit. But back into our form elements here, there's something else we want to add is labels to our dropdowns. It sort of makes sense that if we look at our dropdowns here, this doesn't really tell us a whole lot. So we want to label those as well. And to do this, I'm going to go ahead and bring a div around each one. So we'll go ahead and do a div around the airport dropdown and a div around the destination airport dropdown. And we'll go ahead and put in our labels next, right above the dropdown. And of course, those labels are going to be based off of the elements it's looking at. Okay. And we'll go ahead and do that same thing down here. Perfect. Refresh. That looks quite a bit better. But it's also like very scrunched together. Now, when we go into something like this, it's still very scrunched together, but it's a little bit better than what we have currently. So what I want to do is I'm going to go ahead and bring in our div class here. And I want to just bring these things out slightly. So let's go ahead and unscrunch them, essentially. So to do this, I'm going to go ahead and put these drop downs, these selectors, into their own div itself. And I'll open this up a little bit. And right here. Okay, so now we've got our starting airport, these selectors in their own div, and then we'll put all of the other elements in their own div as well, including the button tag. And we'll take a look at that in a moment also. Okay, so with them in their own divs, what I can do is I can create something called a grid. So I can do class and grid, and then I can do grid columns, like how many columns I want it to be. Let's say, for instance, we want it to be 6 columns, and just leave it like that. So what happens is it actually separates things out into 6 columns, which is what's shown here. These bottom ones aren't in that same grid. So we can take a look at that same thing and copy this and go into those divs. And this should be class name, actually, not class. It's a React issue there. Okay, so this one, let's go ahead and put it into 2 grids or 2 columns. And now we see it in 2 columns. And of course, the first one, the top one, is what I actually want in 2 columns. So let's go ahead and scroll back up and change that to be in 2 columns. Cool, that looks great. But of course, when I break it down really low, I want this to then be separated back out. So in other words, I want it to be stacked like it sort of was. And the way we do that is by using what's called breakpoints. So I can do MD, and that gives me breakpoints so that when I change the browser size, it actually changes as well. So MD, the medium size, actually looks pretty good. And what we also see because of this grid is a very slight gap here. So we can change that gap based off of the breakpoint to doing gap like 3. And now you've got something a little bit closer to what you might want at the end, right? And then if I break it down, the gap goes away. It's completely gone. Okay. So of course, this is all referenced in various places on Flowbite, especially the grid itself. That starts to get a little bit tricky if you've never done it before. But we're going to do it again, so hopefully it sticks. But the idea again is if we come down here, we've got these grid columns. Once again, I'll do the medium breakpoint. And once again, maybe I'll do my gap being 3 as well. So I refresh in here. I don't actually want 2 columns. It's close, but it's not quite there. What I want instead is probably 6 columns so that 3 elements can be over here, and then maybe 1 element will be over here at the end. So instead of it being 2, we'll change it to 6. But you can play around with that number to see exactly what makes sense to you. So with it being 6, this help me is not exactly where we want it, so we're going to want to bring it all the way over here. And so one of the ways we can do that is by putting it into its own div. And we can actually have this one span multiple columns. So we can again do MD and column span. And then how many do we want it to span? Well, we want it to span half the amount of columns. In this case, we've got 6 columns, so I can span it to 3, and it's basically the same, but it's still not quite there. So I want this to float on over here, which we do with a float class. So in addition to the button class name, I'm going to go ahead and add in one more element. So we'll use some string substitution here, and we will close that one off, and just add in float right, save it, and what do you know? It's now looking quite a bit better. But there's still one more element that's missing, and that's the fact that this is touching this. And if I break it down, it's not exactly bad, but it's also not great. Now inside of Flowbite, what they use is this MB6 class, which actually makes margin around the bottom. That's what MB does. It pushes everything around just like that. But we could actually do this a little bit more globally for all of the elements using a space class. So in the form itself, we can do class name, and we would do space Y, so it's top and bottom elements, dash, however big we want it to be. I'm gonna make it the same length as the gap itself, which will be 3. And then we're gonna go ahead and take a look. And now we've got space elements. This space and this space is roughly the same, if not the exact same. And when I break it down, it still has that space on purpose because I wanted it to be that way. You know, perhaps you change it to being MD, and then when it's all broken down, you just do space of 2 or something like that, or space Y of 2. You know, that might be another option that you bring in there as well. But this looks so much better. And then now it's got this user interface. Like this is like a lot more professional in my mind based off of what we had prior. And of course, now we just need to update how this element is rendered out. Now we're going to convert our actual flight response data into a table. So to do this, we're going to be using our Flowbite CSS. So if you do a quick search for tables and then go down to the hover state table, this is the one we're going to use. So I'm going to go ahead and copy this and bring it into flights. We'll go ahead and do tables.js. And then we're going to go ahead and export the default function, and we'll call this our flight result table, or maybe more of our prediction result table. So let's do prediction result table. Okay, and then this is going to return back all of that data. Now, normally, of course, when you copy standard HTML, you get class equals. This is not valid React, so we need to change that. It's not valid at all. We need to change it to class name. So we do a quick search for that, and then just change it into class name, same exact way. Boom, now it's ready. Great. So with this in mind, let's go ahead and import this into forms.js. I'm going to go ahead and import the relative import in this case. And just do our tables, and then I'll bring this in down here. Okay, so there's my prediction result table. So what I want to pass in here is going to be specifically my predictions. So I'll go ahead and say this is going to be equal to my results are equal to, well, basically if there's predict data, then I'll go ahead and pass in the predictions themselves. Great. So with this in mind, I'll go ahead and cut this out and we will bring it into our tables themselves. And we're going to paste this in here as reference. And I named the attribute results, so we'll call it results as well. And so what I want to do, of course, is get my columns from these results. But the first thing I'll say is if not results, then we're just going to go ahead and return an empty div here. And then I want to go ahead and assume that I do have results. So I'll go ahead and say the first result, and that's going to be equal to results of 0. All right. So again, I need to make sure that the results are more than 1. So if results dot length is equal to 0, then we'll go ahead and return that div. Great. So the first result then will give us our column names. So we'll go ahead and do const col names equals to object.keys column names. Okay, so with these column names, I can then iterate through the TR of it all. So we'll go ahead and do column names dot map, and there's going to be column and IDX. Let's go ahead and do 2 parentheses here, and then we'll go ahead and run this through around a TR, and then grab our TH here, and we're going to get our column name. We'll also return that value. So we'll get our column name in there. And then we want to also have our, oops, this should be an arrow function there. So we got our column name, and we also want to have our key in here. And there's going to be IDX. Great. So with that in mind, I'll go ahead and cut the rest of those out. We don't need them anymore. This should give me all of my column names. Now the format of these column names is not great right now, and I'll let you play around with that another time. The actual output of these column names is going to be funny looking, as we'll see. We can just go ahead and run this right now and see what that does. So the next thing is going to be our actual results. We'll go and iterate through those for any given table row. Okay, so we'll go ahead and close out or exit or delete the other table rows. And then we're going to come in here and do our results.map. And this is going to be our, our pred and IDX. And then we'll go ahead and do that arrow method again. And it's going to return something, which is going to be the table row itself. Okay, so I'll go ahead and cut this out and paste it in here. And then the values, well, the actual row itself will need to iterate some more. So we'll go ahead and do const vals equals to object.values of the prediction itself. So these are going to be our TR or table row values. And doing dot values will be mapping to the column names. So then inside of here, our TH, we'll go ahead and do table rows and table rows.map, and this is going to be our, our TH or column, or I'll go ahead and do table row column and table row IDX. We should actually change this from IDX to our table row IDX, so it doesn't conflict with the other one. And I'll give that key right here. And now with these mapping values for each column, I'll go ahead and bring those in as well. And I'm just going to use this sort of standard column here. And we'll go ahead and give this a key. This is going to have 2 key values here. And it's going to be $ the table row IDX, just like that. Or rather the table column. So this should be table column IDX. So we've got the table row. And we'll do dash table column IDX. And then our table column value. Cool. So we can now get rid of all of those. Great. Okay, so this mapping is, I wouldn't say great, but it is at least going to give us the table row in here. So let's just go ahead and verify a few things about it. We've got column not defined from here. Let's go ahead and make sure it's running. Like I had a few things that were not defined because of all of the replacements that we're making. So let's go ahead and run this now. And there we go. Here's our response. We've got the correct columns and the correct names and stuff like that, at least as it's currently set up. But of course, it's missing some data and it's missing the basic economy, refundable, and all that. So what we can do is we can absolutely change this a little bit. We also don't need the total fair confidence. Perhaps you'd want to use it, perhaps not. But I'm just trying to go directly from the prediction to just some sort of table here. So that means that then I'm going to go back into predict.py and we're going to do a couple changes. First off, the flight date we can set as date, the segment airline as airline, and then is nonstop we'll say as nonstop, the total fare as price, and then we'll get rid of the total confidence there altogether. Now the other ones that I want still are the basic economy and refundable, and I'll put it in this same order here, so basic and then refundable. So we'll do basic economy right after nonstop, m dot basic economy as basic, and then m dot is refundable as refundable. Great. So we save that now, run it again. This time we should get all of the column names just slightly modified to being, well, a lot more user-friendly. And this will be done based off of how we map out this various data. So one thing I want to point out is the date column, the actual row itself, the index value for this column here matches the column name column, right? So the important part about that is for the date and the price. So we want to actually render those things out first. So we've got our column names here. What I'm going to do is I'm going to say my price column IDX based off of the column names. So we'll do column names dot map x and x dot to locale lowercase and then index of the price. And then I'll go ahead and copy that, paste it again, and we'll go ahead and say this our date column index, index of date. Now again, those names are corresponding to this name and this name, right? So once we have these values, then I can actually come in here into where I'm iterating through each table row column. I can now say, for instance, I can say is date column, and that's going to be the date column index equaling to this current index. And I can do that same thing with is price column, right? And use the price column IDX. Great. So then I'll go ahead and say, let's do rendered date equals to, of course, if we have it as that actual date column, then we're going to use date.parse of the tr column. Date.parse is built into JavaScript. This actually will give me a timestamp, so it's not that great. So I'll use new date around that date.parse and then .to locale date string. This will give me that render date if it's available. Otherwise, we'll go ahead and say it's just null. Now we can take that same concept with price column. So we'll do const rendered price, and this is going to be if it is a price column. Then we'll go ahead and do new, and this is going to be our intl dot number format, international number format. In this case, I'm in the US, and I can pass in the style it is, which in this case will be currency, and then I can do the currency I want to use, which in this case will be US dollars, and then I'll go ahead and do dot format of the column itself. And then once again, I'll go ahead and return null if it's not the price column. And so the same idea being if it's a Boolean value, so basically if it is 1, then we'll go ahead and say our tr column is equal to 1, and then in which case we'll say our yes value is going to be is 1, then we'll go ahead and say yes, otherwise we'll say null. And we can do the same thing for is 0. And the reason I'm actually having these things separated out is just to make it more clear to you. That's all. Hopefully it's more clear. But basically we've got these now new rendered values that the table row could possibly be. So that means then I'll just say my rendered column value, and we can go one by one. So we've got rendered date. If that's available, then we'll use rendered date. If it's not, then we'll check if price is available. If that's available, then we'll check out price. If it's not, then we'll check out if this is available. And if it's not, then we'll check out, or rather if it is with that question mark, then we'll go ahead and use it. And if it's not, we'll go ahead and check if no is available. And if it is, we'll use it. Otherwise, we'll just fall back to our original column value. And now we've got a new rendered out column. While it might seem like it's more complex, I think it's not as complex, but we can go ahead and run this, and now we should be able to get this stuff rendered out just slightly better than what it was before, or maybe a lot better depending on your vantage, especially with the price column actually showing up as a price column and then nonstop and so on and so forth, right? And so of course, if I want more data here, I could just go into my predict.py and get this flight date, and we'll just do greater than or equal to that flight date. And then maybe we set a limit in here as well of, I don't know, 20. And so we only, maybe 10. Let's put our limit at 10. And then we can run this again. And then that will actually show us, 10 new values in here and all formatted and all of that based off of these predictions. Now, in many cases, you might actually want the prediction side to do all of this formatting. But having it on the JavaScript side gives us a little bit of flexibility with what we end up doing with that data, at least for how we present it for the user, which is kind of cool, especially with like the price. If we wanted to be able to have support for, converting this into another currency as well, which would be pretty interesting. Not something I'm going to do in this one, but we now have a better display as to what's going on with all of this data. Now, one of the things that you might want to add in, which is something I'm not going to do, is a date picker. React.js has a lot of really good usage of these date pickers. And then once you do that, you would just pass it in as one of the arguments, make sure it's the correct format, but you'd pass it in as one of the arguments to this SQL query, so then you can adjust things as you see fit there. So now, with all of this data in mind and the user interface improved, we now want to actually use this to ask an AI to pick for us. As one of the final predictive steps, what we want to do is we want to take in our user's preference and the forecast response that we have, and then give them advice as to what they should pick. Now, we're going to do this using OpenAI and, of course, MindsDB. So we'll pass in both of that contextual data with a question so that OpenAI can actually make a prediction for us. Now, what will be really cool is if we had not just our forecast price, but then the actual price, right? So this forecast price is like kind of a predicted price, right? It doesn't really give us the actual price. And then we'll let OpenAI's API actually make that call for us once we get there. So with this in mind, go ahead and jump into OpenAI.com, log into your account. If you don't have an account, you might have to actually enter a billing credit card of some kind so that you can actually use the API. What we're doing here shouldn't cost barely anything because we're just testing some things out, but it will be really inexpensive as far as from my testing is concerned. Okay, so once you actually log into your OpenAI account, navigate into your API keys in your account. I would imagine the navigation to getting here is probably going to change over time, but you just want to get your API key and you're going to want to generate a brand new one, which I already have one with it generated, and you'll see something like this. You're going to want to copy this. I'm going to leave this window open myself so that if I have to come back to it, I will. Next up, of course, log into MindsDB, the cloud editor, and you're going to want to create a new query sheet here. And this is where we're going to go and create our AI model. So we'll just type out create model and get this autofill thing coming, and we're going to go ahead and fill it out. So the first thing is we're going to call it an AI travel agent. This is not coming from a pre-existing table. Next, what we're going to do is get rid of these things right here and just pass in something called using. This parameter will allow us to declare the engine we're going to be using. In our case, it's OpenAI. Make sure you're using single quotes there. We'll go ahead and pass in our API key, just like that, using that comma at the end. Then what we're going to be doing is question and context. So this is a answering service that goes based off of the context we provide for it. So the first thing is we'll go ahead and say what our question column will be. In our case, it's simply question. The next thing is going to be our context column. In our case, we'll call that just simply context. And then the prediction result that we'll just name it, the column we'll name it, is just simply answer. You can pretty much name it whatever you'd like, but that's what I'm going to go off of. I'm going to run that, and this should actually create that model for us. It should happen really quickly. As soon as I create that model, I get rid of my API key. I don't necessarily need this in here for this question answer model itself. The only reason I'm leaving this in here is for reference for later if I need to change that. But you don't want to leave your API keys in here for any particular reason. So that's why I got rid of them. Okay, great. So now what we want to do is actually run our first test here. So I'll go ahead and do select, and we want to select the answer, which is this predict, column here. And then where it's from, of course, it's going to be our AI travel model, and then our columns. So the first thing is going to be our question. The second one is our context, right? And there we go. So we need to have our values in here. So we can say something like, what is bigger, A or B, if B is 10 and A is 1, right? Or we could actually pass in that context, what is bigger, A or B? And then we'll go ahead and get rid of this if statement here, cut it out, and just paste in here. And we can see what the result of this value will be. Hopefully it's correct, but we get the answer back. This is kind of the idea, right? We want to just send it a question and get back the answer. So I'm going to go ahead and take this same idea and then come into my MindsDB API calls inside of our Jupyter notebooks so we can actually run this again and start to actually formulate our actual queries. So once again, the actual SQL query that we're going to use, I'll call this my rec SQL query. We'll do 3 quotes here and just paste in. We don't need to create the model, but rather we'll just paste in the answer part itself. And again, I'll use string substitution. So what is it that I'm trying to get here? First off is going to be, what is the best flight option, right? Next up is going to be the actual response and my preferences. So I'll go ahead and say, up above this SQL query, we'll go ahead and add another column. Oops, I didn't mean to duplicate it, but we'll go ahead and say user, or let's just call it pref, as in user preferences. And this will be this same data that we're passing in here. So I'll grab this data, just these things, and we'll just go ahead and say dict equals to that data. And then the choices, or the options rather, are going to be this response here. So really the query response. What I want to do though is I want to convert both of these things into a dictionary that is a JSON dictionary so that my raw SQL query, the context that I'm passing is just a JSON dictionary. So we'll go ahead and say that my, predict context or recommendation context is going to be json.dumps, and we're going to go ahead and pass in the options being the options, and then preferences being pref. And there's our context now. So let's take a look at that. There we go. Okay. Next up, we're going to go ahead and say, we're going to pass this into our SQL query here. So we'll pass that context in. And these should be single quotes actually. I think we actually can still use double quotes, but let's just stick with single quotes, which is better SQL. And now that we've got this query here, I'm going to go ahead and submit this query to the API. So let's go ahead and scroll up to the MindsDB query, this right here, of course, and we'll go ahead and run our session. And let's go ahead and grab that, which is right here. So our session, and it's going to be the recommendation with that session, and then session.close. And we'll take a look at the response, or the prediction response, or the recommendation prediction response. Run that, and then a table or a column right above that. We see that our response is 200. Great. So let's take a look at the JSON data that comes back, and we get the error SQL statement cannot be parsed. So let's take a look at the SQL statement, and I got this pipe here. That was a typo. So let's go ahead and run that again and see what our response is. Now we see that our data is basically giving us exactly what we wanted. right? Based on your flight preferences, the best airline would be the Alaska Airlines flight with the total fare. Okay, great. Let's go ahead and change our question a little bit. We'll say with minimal response, what is the best flight option? Let's try that query. So basically, I don't need it to be restated. The best flight option with a minimal response. So we can really play around with this as far as the data is concerned. But let's go ahead and say be concise. What is the best flight option, right? So this is where the prompt kind of goes back and forth, but that I think is pretty good. The best flight option is with Alaska Airlines with a total fare of so on and so forth. Great. So I don't know if that number is accurate. It looks like it is right here. That looks like it's that one. But of course, I want to actually implement this into the UI, which means that we're going to have to implement this on FastAPI as well as our Next.js application. But at this point, we actually have the ability to change this data and get pretty realistic responses. So let's go ahead and change the start and airport to LAX, and then we'll do JFK as the destination. Let's actually put these preferences somewhere else, as in we'll go ahead and grab our query response here. Put them together, basically. So these preferences then will come in right here. We will unpack them. And I'll go ahead and allow that raw request being false still. Or I think it should be false in here. Let's go ahead and make sure it is false. Okay, and we'll come back down here. Do a quick prediction here with this new data. And then we should be able to get the rest of the data as well. Okay, the session, I think I actually closed out the session, so it's interesting that it still worked. So let's take a look. Looks like we've got JetBlue, and the best is JetBlue with the total fare. Cool. So that's exactly what we're looking for, is that best flight option with JetBlue Airways. And it's doing it in a way that it's just kind of getting rid of everything, which is pretty cool. So let's go ahead and implement this into the UI now. Now what we want to do is put our recommendation query into our API as well as our user interface. But before I do that, I want to change the format response here. So I put be concise for the question on purpose so that it really just narrows down what's happening here. If we actually ran it without that conciseness, the response values is going to be maybe a little bit different. So what I want to do is add in the question of respond with JSON only, and then what is the best flight option. And then now what it's going to do in theory is only respond with JSON data. So I might have to parse this data further, but the general idea here is responding with JSON data so that it actually gives me the same value, or at least one of the same value, back with this particular question. Now you will be able to experiment with this question all that you want. But for now, I'm going to go ahead and implement this in predict.py. Of course, it's very similar to what we've already seen before. So I'm going to go ahead and grab this predict query here, and I'm going to copy it and paste it again. And it's going to be our recommended flight query. And it's going to take in the same sort of data, which I called our preferences. So I'll go ahead and say preferences here. Or let's say user data, actually. And then our actual response back, our predicted data here, is going to be our forecast data. In this case, it's going to be a list there. Then we'll go ahead and do our question, which once again, I will go ahead and leave in as respond with JSON only. There we go. And so granted, this can open it up to make our SQL query quite a bit more flexible in terms of what we might end up wanting to do with our users. As in, you could actually start maybe have it be a little bit more conversational here with your query itself. But with this in mind, I'm going to go ahead and bring in my query in here. Okay, there's my raw SQL query. And then we want to grab our context, which I called in here as rec context, but I'll just call it context now. And once again, we will go ahead and pass in the same sort of ideas here. We've got preferences and options. Forecast data is the options, and then our user data is the preferences. So that will be the context that we want, but I'll go ahead and say context data equals to json.dumps of that data. We need to import JSON into this. This is just to make sure that it's formatted correctly and it's just a string, so it doesn't have any issues with our Python data at all. So this will be our context data, of course, and then our question here, I'm going to go ahead and bring this in right here. Great. So very similar thing that we're going to be doing as we're going to be running this response. I'll call this back the SQL query itself. We can have the raw request come through as well, and then we're going to have our data set in here. Now, we don't need the columns, so I can go ahead and get rid of that because it's really going to only respond with one thing, or at least I believe it will. So basically, we will return back the data set. Okay, so let's go ahead and take a look at what that data set was when we actually did respond with it. It is a list with a list, and then that single list is a string, basically JSON string data that's coming through. So that means then I'm going to go ahead and check if is instance, this data set is a list. Then I'll go ahead and say my sub data set is equal to that data set, the first iteration of it. And if that is a list also, then I'll go ahead and do my sub data set. And that's going to be just like that. We probably don't need the sub. We can just go ahead and return that data set. Otherwise, we'll return that one. Great. So with this in mind, I can obviously go ahead and copy this and bring it into my MindsDB API calls. We'll go ahead and paste that in, and we'll run this again with very similar data. Okay, so we've got our query response and our preference here. So I'll go ahead and grab those. Query response. We need a session as well. And our user preferences. Let's make sure we have the correct keys in here. And our user preferences, which was just pref. There we go. And let's try and run it. I'm not positive if the session will end up working, but there it is. And so this data is not great in the sense it has these /ins, but let's see if we can actually end up using this for our project itself. Let's see if the front end can parse this data pretty well. Which in terms of, we could try json.loads with Python of that data as well, and see if that actually does load that data. And sure enough, it does. Okay, cool. So that's nice to know that it actually will load that data in for us, and then we'll be able to respond that back. So this might be a good place to do it, is we could then just try to say the JSON data equals to this sub data set. And then we could do try JSON returning json.loads of that JSON data. Otherwise, we'll just return, we'll pass through, and we'll just return the sub data set. Cool, making sure JSON's still in there. Cool, so with this in mind, let's go ahead and add this into our API now. So in main.py, we'll call the same stuff. So back in here, I'm gonna go ahead and grab this recommended flight thing, and we will put it right here. And it's gonna be predict dot, and it's going to take in our predictions. The user data is going to be the request data. We can get rid of these print statements now and this commented out stuff. Okay, the session is going to be that AI session. And then my recommendations is going to be related to that. And we'll go ahead and come in here and we'll see if that data ends up coming correctly with the form itself. So back into forms.py inside of our app here. What I want to do with this, set previous data here, I'm just going to go ahead and try to unpack the data as well and just get rid of this. Okay, let's see if that ends up working for us for our predictions. And then I'll also just do my JSON.stringify of that data again. Hopefully everything is working correctly with our front end. Okay, so I've got loading false, that's good. That's showing that part at least. So now we'll go ahead and run this, loading true. Again, you might want to put some sort of indication down here that it is loading. I'll let it finish. And great, so now that it's done, we've got our recommendations here, which ends up being a number of things as far as our recommendations are concerned, which is, oh wait, nope, it's just one. There's our key for predictions, and here's our key for recommendations. It probably should just be recommendation as the response. So let's change this to recommendation, based off of our question that we're asking. What's the single best option here? The other thing is if the length of these predictions is equal to 0, we should just return back an empty dictionary. Maybe with a message and all that, but if there are no predictions, we can't give a recommendation in here at all. Okay, so with this in mind, now I can then come in and have a new div here and say if we've got our predicted data and we've got our recommendation, well, we could actually pass it into our prediction table. But first I'll go ahead and do JSON.stringify of that data, recommendation. And let's go ahead and make sure that we are doing the question mark here. Otherwise, we'll just go ahead and return nothing. Okay, and so the recommendation, I will go ahead and pass it into that table as well and say recommendation equals to that data. And so let's go ahead and make sure everything can render out and with the parentheses there. Okay, great. Cool. So let's go ahead and run this again. And now it should give us that recommendation based as a string. So it should be one value there and then all of these other values. Now I could turn this from being JSON to being just like, hey, the best option is this. But I actually want it to show up down here somewhere, right? I actually want to show up on the table so that it does give me an actual recommendation of what I should purchase based off of all of these user preferences. But it's pretty cool that this is working now. And so maybe if I can do the recommendation instead of stringify of JSON, we can try the recommendation and get the airline, for example. Let's go ahead and do .airline, given that it was sent back as JSON data. So once again, there it is. It's actually rendered out already. I didn't even need to do the request. But that's now giving me that airline, which leads me up to one other challenge that I have with this current data is it's not giving me any sort of unique ID for this data, which is something we want to fix in the next part. At this point, there's no real unique way to identify this forecasted data. So we just want to add some uniqueness to it in this forecasting, as in assigning a random ID to these things. And so that our recommendation can use that unique ID with, highlighting the one we recommend or something like that. So now what we're going to do is go back into MindsDB web, and we're just going to experiment with this select column here. And we're just going to add in some built-in features to SQL to do something called concat and then cast the random selector here. And we multiply this random by a large number. And then we'll go ahead and declare it as an integer. Now I can concatenate it with other values from the actual response itself, but I don't need to. I'm just going to leave it like this. And I'm going to say this as request ID. And so this right here will give us somewhat of a unique ID per row, right? So now if I run this, the ID is going to be unique, at least for that specific request. And we'll see this column in just a moment up here. And so there we go. So now we've got unique objects here that we can use over and over. So with this in mind, we'll go ahead and bring this into our predictor response as well. So inside of predict.py, in the predict query, we'll go ahead and add that in as a selector here, and we'll save that. You can change the limit if you want. It probably makes sense to have like maybe 5 at this point. We don't need that many predictions in the future. And the less predictions or the less response we have, the faster and less expensive our OpenAI requests will be. So with this in mind, and of course, in my case, the forms.json, the actual recommendation, I turned it back into stringified data. So let's go ahead and take a look at it now with this new ID. I'll go ahead and run this. And what we'll see is a new column for that ID, as well as the one that's up here, which, maybe you want that column in there, maybe not. But here we go. We now have that request ID there, and it gives us the exact value that we're looking for. And granted, it's less items in here, but notice that it actually gave me a little bit more of an expensive one, which is interesting that that's the prediction it did versus this one. Now, of course, the reason it did that is because of the date, right? So perhaps you don't want to delay a date, right? And so that's where other preferences in here would play a factor. For example, if you can, if it doesn't have to be exact date, true or false, right? And then that's where that date dropdown might come in. But having this request ID now, I can then just highlight the one that we recommend. And that's the point, right? We want to have that highlighted one in there. All right, so now what we're going to do is highlight the recommended value that we have wherever it is, and then we're going to get rid of this request ID here. We don't need that to show up. So to do this, we're going to jump into forms.js, and we're going to get rid of the recommendation stringified data and only keep the table. In this case, I do have the recommendation coming through. And so back into the tables itself, I'll go ahead and bring in recommendation here. And what we want to do is we want to figure out which column is actually using the recommendation or the request ID here. And so that's going to be the first thing is we'll do our request, and this is going to be our ID column IDX, and it's going to be the same ID as this, but now we'll go ahead and use request ID. Now, this index value could change. It could be different, right? Which is why I'm doing this version of it. So that we come in here and we'll just say if this column is equal to the IDX, then we'll go ahead and return null. And that gets rid of that entire column in the header, but it doesn't get rid of it in the row itself. So inside of the results rows, first off, this will give us each row, and then TR is the actual value that we're going to be looking at here in terms of the columns themselves. So we'll then go ahead and say if the T column IDX is equal to that same exact one, which was the request IDX column. Now we've already seen this multiple times. We'll go ahead and return this as null. So that should get rid of that column there, but the value is still there. So we can still use that value. So to actually go about doing this, what we want is we want to check the row itself. So I'm going to actually change the class name in here. And I'll go ahead and say const, or let's do let class name equals to this value right here. And we'll come in, paste this in here. With this in mind, what I can do then is I can take the TR values here, or more specifically the prediction values, which are still those key value pairs. Now what I can do is say prediction, basically if prediction.requestID is equal to what's being passed in, which is going to be this recommendation here, dot request ID. Then I can change the class name to something different, which I'll use basically the same stuff, but just change the background. Let's say change the background to BG blue. Let's do 300 just to start out, just to see if that ends up working. And so when I first do that, it gives me all of them being the same. So the request ID, the prediction, this is not good, right? So we want to change that, and it's probably related to this right here, because those are both incorrect. The key values were incorrect, and thus when I change it, it actually highlights the correct one. The reason it actually changed it is because when they're both incorrect, they're both null, and therefore the actual condition there is the same and actually ends up working okay. Next up, I'll just change the text to being black and maybe the font being bold, just to make it slightly different. And then perhaps you want to change the highlight value. But the last thing I want to do is actually show maybe right next to the date, the recommended one, right? So like actually put something like recommended next to it. So the way I'm going to do that then is we would come back up here and say const is recommended, and that's just equal to this value right here. And so this entire row is now recommended. So then down here, what I could do is say, if it's the price column, then maybe we put a check next to it or put recommended, right? So basically we'll say that if it's the price column and it's recommended, then we'll go ahead and say yes, or pick this, or something like that. So we'll say is price column and is recommended. Then we'll go ahead and say, you know, recommended. Otherwise, we'll just do null. And so now I've got my price column in here saying that it's recommended, and there we go. And of course, this doesn't look great. So what I want to do is actually reintroduce that column that we had just with something like recommended, or I'll just put like a temporary sort of arrow function, if you will. So what I'm going to do here is when it is the request ID column, instead of returning null, I will return the same TD. But this time it's going to be just slightly different. So first off, we'll go ahead and say TD like that. That should give us that column back. We'll adjust the actual column names in a moment. But with that column back, I'll get rid of this recommended here. And then I'll go ahead and come back up here and say that basically const the value, the rec value or rec label is going to be equal to, if it is recommended, then we'll go ahead and just put a temporary value here. Otherwise, we'll put a string and an empty string, and then we'll render it out like that. And then therefore, it's like looking a little bit more like, hey, this one's recommended, so use that one. All right. And of course, we could do it on the other side of the table as well if we wanted to. I don't want to at this point. But the other part is this th here. I'm going to go ahead and put that up here as well and close that off also. So we refresh in here, and now it's a little bit better, right? This is now our recommended one. We could put icons, we could put all sorts of things right here to just further prove that it is the recommended value. And then, perhaps that hover, we want to change it from BG gray, which is this right here, to maybe back to that blue, and maybe even make it darker or something like that. We can leave the dark values as is, but there we go. So now we've got our recommended value showed up, and we could then use it. Now, off the recording, I created these purchase links right here as a way to just kind of show you some of the challenges that would come up with trying to get the actual data, the real data for these various routes. So if we go to any given airline, in this case, I'm going to start with United because it's the most simple. But if you go to united.com, at least right now in October 1st of 2023, you can do this search here. And once you do that search, you get this URL right here, which has a bunch of different arguments into it. We'll look at that in a second. If you do the same search with something like Delta, you will not get those same arguments in there. But you will get results back, but you just won't get those same arguments. So let's go ahead and jump into the United one, for example. I'm going to copy that URL, and I'm just going to paste it into an empty string or an empty page here. And we'll go ahead and start separating it out by URL parameters. So if you're not familiar with this process, basically you want to look for the question mark and then the ampersand or the and sign, and just go ahead and break it down. And here's all of the parameters we've got, right? So each one of these parameters, you should already look at it and go, oh, wow, I already know these ones right here. That's the F equals to, well, from, T equals to, well, to, and then destination and so on, or rather date and so on. So these other arguments, I can make the assumption that maybe I don't need them. So let's say, for instance, I wanted to change these arguments in here like that. And so to do that, going back into my actual United search, I could actually come in here and change this to LAX and JFK and hit enter, and it'll actually perform that search and it'll do it correctly. So these URL parameters are fairly straightforward to then modify whenever we need to, which is what actually builds up these links here. Not all airlines do this as easily as United, as we saw with Delta. Delta doesn't have it at all. It has a cache key suffix. Now, maybe there's a way to reverse engineer what this actually means where it can actually be parsed out into the actual query, which is probably the case. But what we don't have is a very straightforward way to do that, which is why I actually gave you a lot of the different links in here in link.js. If you go in here, you'll see the various options. So if it's American Airlines, we will see that that has a bunch of different arguments that come in here to build out that URL for that same kind of search. United, same thing. JetBlue, same thing. Now, the idea here, though, is I'm almost certain that the way these URLs work will change in the future, because these, airlines don't necessarily want you price shopping. They just want you using their website to make a purchase on their website. Now, I realize there's third parties that also work with some of these airlines to give you some of these same results, and perhaps you would scrape these. This might be your best option, is to scrape these and then just figure out the data from there and then bring that back into your database and all that. But that's not actually what I'm going to do. I just wanted to talk about these links here because it's actually not trivial to scrape this data and to do it reliably so that this actual purchase would actually go to the cart to actually check out to purchase the actual flight itself. So maybe at some point the airlines will open up an API where we can build on top of it and be able to actually accomplish these things. If you're an airline, you're listening, please do that. That would be fantastic, because then a lot of us could start building out these AI agents that are just that much better. They could then just be regularly looking for flights for us on, places we might want to go. But at this point, what I want to do is I want to emulate getting that data. I want to emulate actually being able to scrape the data or getting it from an API by having synthetic data. So we'll use synthetic data to actually improve or change the results of these flights and the starting and destination airport and all these different routes right now using something called Gretel. We need a way to handle new data into our system. With this new data, we will obviously put it into our MariaDB instance. We will also need to use MindsDB to create a new forecasting model and then implement all of that so it ends up working in our web application. So the idea here is we want to make this as general as possible for pretty much any data set, mostly because we started with that housing data and now we're going to use our flight pricing data, but also because if we have this foundation, then we can start using this same concept on any kind of application, not just our AI travel agent, which is the point. So in other words, if we go into our app, you might be like, oh, well, why don't I web scrape all of these different airlines for the real data? Well, that's a great idea. It's not that trivial to scrape that data. So it's outside the scope of this one. Instead, what we're going to do is we're going to create synthetic data. We're going to be using Gretel.ai to create data based off of our current data set, based off of that snapshot we've been using, so that we can then modify maybe a few things about that data to emulate what new data might look like. And this will be true for any data set. So if you wanted to switch it over to that housing prices instead of this AI travel agent, you could build your real estate AI agent with this same sort of foundation. So at this point, sign up for Gretel.ai. We are going to be using their free tier to build out the data set that we want. Once you do, it's going to look like this, and then we need to actually grab the data set that we want to grab. Into the Gretel dashboard and then into projects, you're going to want to generate a new project. I already did. Mine's going to be called my AI travel agent data. And what we want to do here is we want to implement a new data source. We want to upload a data source as a CSV file. Now, for me to do this, I'm going to jump into my Jupyter notebook here, and I'll use Jupyter to export the data from my MariaDB instance into a CSV file itself. So I'm going to go ahead and actually duplicate the transform flight price data because that's where we loaded the data in. And I'll duplicate this and we'll rename it. And I'll just call this my export flight price data from MariaDB. Let's go ahead and open this up. It's a lot easier to rename it inside of the instance running. So we'll go ahead and say from MariaDB via Pandas. Yes, once again, it will be via Pandas. Great. So what I want to do then is I want to actually go to the bottom and copy this right here. We're going to go ahead and bring it up a bit. and bring it all the way up to the top or right next to the engine itself, as you'll see why in just a second. And there we go. Okay, so what I'm trying to do here is I want to grab that same table. And so this is going to be pd.read_SQL, and this is going to be our data frame now. Okay, it's going to be the engine and all that. So let's go ahead and run a few of these items here just to make sure I can grab that. And then we will go ahead and do our df.head. So once again, we've got all of that data. No surprises here, hopefully, but if there is a surprise, then yeah, I mean, one of them might be the index column here. So maybe we say index column equals to index, and we run that again, and there we go. So that's a little bit better. We now have our index column in there as well. Okay, so of course I want to output this data. So this is gonna be our, let's call this our SQL dump CSV or something along those lines. And then I'll go ahead and say SQL dump.csv. Now this is not an actual SQL dump, it's just a CSV file, so perhaps that's not the right name, but I'm trying to use these general dataset names mostly so that when I change it to another dataset or another table, it's gonna be super easy for me to do that. Okay, great. So with this in mind, I'm gonna go ahead and then I can obviously go through all of the data, but I'm gonna delete a bunch of it with DD, because I don't really need to go through all of the data. All I need to do is I need to output it to that. So to do that, we do df.toCSV, that file. I'm going to say index being false, and this should actually dump it to that file, which is in that same database directory. And so now that I run that, I can go into my project itself and take a look at my data sets in here. And there is my SQL dump right there. Okay, so I'll go ahead and reveal this in Finder, and we'll go into our data sources on Gretel. I'll choose this data set. Oh, it's already there, so there we go. It's already on the correct notebook location, probably because I've tested this a few times. If yours is not, obviously navigate to it and then upload this data. And so once it's uploaded, we're going to jump into our model, and we're going to go ahead and train our first model. So we'll go ahead and say new model. And what I'm doing here is I'm going to be using the synthetic data. So there's a lot of different options in here as to what you'll do. And these will continue to have more and more options, which is great. But I'm going to go ahead and use this first one. So I want you to experiment with these ideas. One of the things that you might be wondering is like, oh, why not use DGAN, the time series data? While you can do this, it actually requires a lot more configuration just to get it working. And this synthetic ActGAN at this point goes really, really fast. So again, I want you to play around with the various items in here. You also might use the tabular one, but I'm going to use the first one that's there. We'll go ahead and hit continue. And then I already have a data source, so I'll go ahead and select an existing one. There's my CSV there. I'll go ahead and continue that. And here is the setup, right? So if you want to make it a little bit more advanced, you can then edit these settings here to just choose different properties and different options that you might need within Gretel. Now we're going to keep it simple and not touch any of that. We're just going to let Gretel do its thing. So I'm going to go ahead and run this model now. And once this is finished, we'll go ahead and actually create our new data set from it or take a look at that new data set. Okay, so after a few moments, 3 minutes, we have everything all trained out. And we can see that it was created. It went through a number of training epochs, and we also have some results here with a synthetic quality score and the ability to download results. While you can download the results right here, I actually recommend going up and clicking on the tab for records and downloads and then downloading it here. This is because I'm going to go ahead and generate another 5,000 items here. So it's going to take from the exact model and then download or at least generate another one, and then we will download it once it is finished working. And so once we do that, I will also go into my actual datasets directory in my project, and we're going to create a new directory called Gretel here. And this is where we're going to put these dataset items in there. And so I'll let this one finish and then we'll come back. All right, so our new dataset is done. I'm going to go ahead and download those records. And both of those downloads I will bring on over into my project here. and just like that. Okay, so what's important to note about them is they are .gz or gzip files, but they still have .csv here as well. So loading them is very similar to the itineraries.csv, just one more step. We have to open it up with gzip in Python. So I'm going to do all of this as a Jupyter notebook. So we'll do it very similar to loading the flight price data to MariaDB. So I'm going to do it very similar to loading the flight price data or the transform flight price data via. So I'm going to do it very similar to what we've already seen, the load flight price data to MariaDB or the transform one. Either one you could use. I'm going to use the transform one because I know that's the most recent one I did. I'm going to duplicate it and then open this up. And this one, I'm going to change it from transform to simply load Gretel flight price data and get rid of that dash copy there. Okay, so with this in mind, I want to load in my current data set. That current data set is going to be loaded in very similar to how we dumped it out in the first place. So go ahead and cut this out and bring it to the very top, right underneath this PD here, this read CSV. And this time it's going to be df.pd and read SQL. I will also leave in the out one as well. So it's going to be very similar to that. So eventually we'll have out df and to SQL, but not just yet. So I'll leave that there. So to read SQL, we just need the table name and the engine. We don't need these items right here. Okay, so get rid of that. And let's go ahead and read this one in. So we've got df.head and we run that. Looks like I didn't do all of my imports. So let's bring this to the top. And let's run this again. And so there we go. So there's our data set. Everything else I'm going to kind of get rid of because we don't need it any longer. And I'm just deleting them with DD. Okay, so this is our original data set. There's information about this data set we will need. But the first thing is I need to make sure I'm declaring my index column. So in here, we'll do index column equals to the column name of index. That way that is valid in there as well. Okay, so what we want to do is we want to read in those gzip files. So going back into our project here, it's inside of a directory inside of our datasets directory. So what that means is I'm going to come back into this right here, this variable. I'm going to change it from that to being Gretel dir, and this is just going to be /Gretel. And I just want to make sure it exists. And sure enough, it does. Underneath my loaded data set here, I want to take a look at something called a .glob. So if I put it into a list element, I can see all of the gzip files in there inside of this directory. Now, the reason I have two of them is to show you that the method we're about to do can really help us append a lot of data to our data set that Gretel is helping us generate. So the way this is done is we say for path in that same Gretel.glob, right? We can print out the path itself. And it's the same data that we had in this list element here. So that's what we're going to work off of. So the next import I need is gzip. So we're going to go ahead and import gzip here. And I'll scroll back down. And I want to open this up. So we'll say with open, or rather with gzip.open. And that's going to be our path here. We're going to go ahead and say as f. So from this file path, what we could do is we could say new df is equal to pd.readcsv of that file. And so I could actually iterate through each one and read the data frame or the pandas data frame just like that. Once I actually read it, I can actually concatenate it with another one. So in other words, I'm going to go ahead and say my Gretel dfs is equal to an empty list. And then each iteration, I'll go ahead and add the data frame to that empty list. Now be careful with this method if you have huge data sets, right? Huge data sets, this probably won't work. The memory will be too great. The memory requirements will be too great, and thus the actual computer that you're working on most likely won't be able to load it like this. So you might have to look for another way. But with this in mind, I'll go ahead and say new df now is pd.concat, and bringing in or concatenating all of those data frames together. And we can do df.head just like that. And it should be pd.concat. There we go. Not contact. There we go. Okay, so the data should look very, very similar, right? This one doesn't actually have an index column because we purposefully left an index column out when we did it. But if you did have an index column, you would just delete it. So you would do something like delete new df and index. But of course, since I don't have one, it's going to give me an error. So I'm not going to do that. And just for testing purposes, you can delete the total fare just to see what that looks like, right? So there, it's gone. Okay, so granted, I don't want that. I actually want it there. And so what we're going to do now is we are going to actually combine these two data sets. Now we could, once again, do concat and just add it to this data set and then, dump everything and then rewrite everything. I don't want to do that. I actually want to rewrite it based off of a specific index value. So in other words, what I can do inside of my original data frame, I can say my tail, I can look at the very end and see that this is the last row here. So another way to think of this is to come in and say last row equals to that right there, which also gives me the value to do last row.index, which gives me a list back. So if I just do 0, I see that's my last row index. So we can say last idx equals to that, right? So where I want to pick up from this one, I want this index to start at this plus 1. That sort of makes sense. So to do that, we do new df.index equals to new df.index plus this value and then plus 1, because all of these start at 0. So you definitely have to add in 1. Otherwise, you might override the last row value. And so when we do that, we now have these new index values. And it seems like we're almost done. It seems like, okay, cool, now I can just load this data in. But the reason I'm bringing those index values is so when I actually, put it into my database, those are correct. Those are actually incrementing. But the problem that I have is the flight date. A big part of the reason I created this synthetic data was so that I can change the flight date to be more current. So I could do this same sort of process over and over again until I get to today, which is not something we're going to do on the video, but it's definitely something you could do. So in other words, I need to change this flight date. So how do we do that? Well, first and foremost, we can grab the flight date itself from the original data frame, and we can do .flight date and then .max and run that, and it gives us the maximum flight date. If I do .date, it will give us a datetime object of that maximum flight date. If I do this same thing in my new data frame, let's go ahead and bring it down here and do flight date.max. I get that almost same value, but this is a datetime object. This is just a string. Granted, it's the same value, but it's not the same object type. It's not the same data type. So once again, what I need to do is I need to change this to a datetime object, just like we did before when we initially loaded it in the first place. So that's really simple. It's just that, and then pd.to datetime of that. And so once again, we can see that's the same value that we had up here. And of course, if I change it to .date, it will be literally the same value because the Gretel synthetic data did not change the dates at all. It did change them for any given row, right? So it is synthetic dates, but they still fall under the max and min of the original data frame. So now, just like the index value, I want to update the flight date to be different, right? I want it to be after the maximum flight date itself, right? What we have right here. So to do this, I'm going to go ahead and create a new column. This column is going to be very similar to this flight date column, but we'll just call it flight date new for a moment. And then we'll set it equal to that flight date, and then we'll do apply, and it'll be lambda x. And initially, we'll just go ahead and say the max flight date itself. I'll go ahead and run that. And now what happens is every single row in here has the same date. It's the flight date, the original flight date, the maximum original flight date. So what I could do then, of course, is import date time like I have here. And I can actually add in date time.time delta days equal to 1. And what this will do is, of course, increment this. So now it's at least a later date than the max date, very similar to like what we did with the index value, but it doesn't take into account the original delta. In other words, I want to take the delta from this date to the maximum flight date. I want to see how many days that is. And then I want to add it or subtract it from what's going on here. So what's actually going to happen is I will go ahead and add it. And what that's going to mean is going to take the original flight date minus the value of every given row, which is going to be simply X. So it's going to be subtracting, it's basically going to be, this date right here minus this date, which will be some value. And that's going to be added to the original max date and thus changing everything else. So if I run this, I now see what the new date is. If I look at the minimum date, it's now 1 day later than the maximum flight date from the original one. And then if I look at the maximum date, it's going to be several days in the future, which is great. So now we know that we've pushed all of this data forward into the future. So we can also then reiterate this over and over and over again until we're all done. Okay, cool. So what I'm actually going to do is change the actual flight date. The new DF's flight date column is going to be this new date here with all of those new values. So there we go. Okay, so the last thing, of course, is to then bring this into our database. So I'm going to go ahead and copy this, and we're going to scroll down here, and I'm going to use new df to SQL, table name same, engine same. If exists, we'll use replace, and then we'll do the index value, and I'll run that. And it should give us, 10,000. So that means I added 10,000 to the database. So let's go ahead and reload that database. And let's take a look at what happens here. I'll just do df.shape. And actually, we'll do df.head to start. And what we see is the very top has the wrong index. So maybe it's just reordered wrong or something like that. Let's go into the tail. Still the wrong index value. So replace is actually wrong. We don't want to replace it. We want to append it. And it might feel like we lost all data. Like, how do we actually get the data back? Well, if we open up the transform flight price data again, you can actually just run through this all over again and get that same data set back to where it was. And then eventually it will write out. It's going to replace everything that's in there, which is important. And then we're going to go ahead and load in this data again. Now I'll go ahead and append it and run df again. And this time df.tail. This should be the final values that were from our new one, and .head should be the original values that we had here. So one of the things to consider is to basically run all of this as a single function and then delete the Gretel data frames that come through, simply because we are appending these values. Now, another option, of course, would be to combine this data frame with our new data frame and then overwrite those values. So the actual way you're going to do this is completely up to you, but do keep in mind, the more times you combine data frames, eventually you might run out of memory on your computer and thus cause a lot of issues. Append is also a little bit more efficient when it comes to dumping data than overwriting the entire database itself. But that's all stuff that you'll have to play around with as far as efficiencies are concerned. But now we have all of this data in place. It's time to then train our new forecasting model like we've seen before. Back into MindsDB, we need to create a new flight price predictor. But before we do this, we need to think about our actual application. So when it comes to a web application, we want to make sure that everything's available as needed. In other words, I'm going to need to oscillate between two different flight price predictors, the actual model itself. So that means then in my .env, I'm going to go ahead and create something like my flight price predictor model. And this is going to be A or B, basically. So I'll come in here and comment out B. Now this is so that I can train one and have the other one in production and then swap them whenever I need to train the other one. So that means then I will go ahead and train A inside of MindsDB first. So we'll go ahead and run this, and that's going to take a little bit of time, before it's done. So that also means that this environment variable, I want to actually bring into predict.py. So to do this, we'll go ahead and do from backend.env import config, and we'll go ahead and say the model, or rather we'll call it the flight predictor model, and that's going to be config. And this is going to be basically that value, the default being also basically that value, but without the underscore of A. I do want a fallback value if for some reason the env is not there. And this one still exists. It's not great, but it still exists. So I could always update that one as well. So at the end of the day, I'll end up having 3 different models, which you probably only need 2, but I will have 3. So with this in mind, down in my predict query here, the model itself is going to be just simply that. Cool. So in theory, at this point, I should be able to just still run the exact same predictor that I had before. So let's go ahead and come in and let's just double check in here that I've got everything loaded and running. Looks like I do. So back into my app itself, I'll go ahead and run a prediction. So I shouldn't get an error here if I did everything correctly. It should just run. And it looks like maybe I did get an error. So let me just refresh in here. And we'll go ahead and do help me. I actually might have accidentally deleted the old one too. So let's go ahead and just take a look and see if the old one still exists in there. Looks like it does. And so the predictor model is not actually loading it in. So let's go ahead and see as to why. So predict query, that should be coming in correctly. So let's go ahead and try it again. And it's doing a prediction. Let's take a look at the actual query itself. So we'll print that out. And we'll refresh in here. Do a quick load. And yep, it is loading it correctly. Great. And so there's the data. Okay, good. So it's still loading. And then now with the other one done, I'll go ahead and describe it. Let's just make sure it's done. It's still training. Okay. So we would actually have to check this fairly often to make sure that we are doing the predictor. We're making sure which one's done before we promote it to being in production and being the one we end up using. And so the idea here is actually to duplicate our MindsDB API calls. We'll go ahead and duplicate this, and we'll rename this. And we'll go ahead and say train flight predictor via MindsDB API calls. Let's go ahead and open that up, and we'll rename this. And here we go. So first off, what we'll do is we will bring in those same things. And I also want to bring in the environment variable that we just created. This right here. So the model we're going to train, so we'll go and say toTrain is going to be equal to, if this model is basically, we'll say toTrain is going to be flight predictor A. Okay. And then we'll basically say if this is equal to toTrain, then toTrain will be B. And that's it. Okay. And let's make sure we set that equal. There we go. Then we're going to grab this SQL here. And what we want to do is add this in. And I'll say my new SQL command equals to triple quotes, paste that in here. And we need to actually separate these commands here. So the first one is going to be the drop model. So we'll go ahead and say drop SQL command 1 and then SQL command 2. Okay, so we don't want to chain these things together. But basically, we're going to drop the one that we want to train now and then actually train that one. And of course, we could change all of the items that are in here as need be. But once we have that, then we've got our session and our query. So I can run those things. I'm going to delete a few of these other cells in here. and just get in the habit of running those predictions or running that training. And then of course you could also do that same query for the status itself. So with this in mind, we'll go ahead and do session equals to get session. The query itself, it's going to be that first query. We'll go ahead and run that one. Let's go ahead and just call this commands to run. And it's going to be command 1 and command 2. So then we'll just loop through and say for cmd and commands to run, cmd, and then session.close. So right now A should be training itself, right? And so we probably don't really need to train A again. So let's go into our environment variables and change this back to being A. So we'll save that, and then I'll go ahead and run print, and we'll go ahead and say training. There we go. So let's run this again. Notice that it's actually incorrect based off of the environment variables of this kernel. So we're going to want to restart and clear outputs. And we'll run this again. Now it's going to want to train B because of the environment variables. And then we can run these commands, and this will now train B for us, which we could then verify with this describe predictor. So let's go ahead and do that command as well and come in here, and we'll just call this our status. So, SQL command 3 equals to that. And let's grab the toTrain variable. Okay, and once again, we will use this same session idea here. And we'll go ahead and get that status. So this is going to give us a response, as you may recall. Of course, it's up here. So we'll go ahead and run that again, and we should get our response here. And we'll just do response JSON. We got our response and then our data in here, and we see that it's training. So we've got the data and the columns. So let's go ahead and say response data equals to response.json, column names equals to response data, column names, and then the actual data set equals to response data and the data. So for I and column in column names, we'll go ahead and print out the column itself and then print out dataset I, so we can get some of these values back. And I've got too many values to unpack here. So let's see why. I'll look at the column names first. There's our column names. Let's look at our, oh yeah, I needed to do enumerate here. Okay, and we'll run that again. And we got index out of range. So let's go ahead and print out the data set one more time. And that's why. So the data set should be basically a few items in here. So we'll go ahead and do dataset 0. Let's see if that's going to be closer to it. I think that's the right value now. So let's go ahead and do that again. And there we go. Okay, so now I can actually see the status of it, which is really just status training, right? And so I could just keep doing this basically until it's finished, and then I can promote the other one, so then my application will work based off of the other one. So if we want to check the status of the other one, let's go ahead and check the status of A, and I'll just come in to MindsDB for that, and we'll see that it's complete. So now this one should work off of A as it has in here. So now if I do another search here, it should give me the dates based off of the request that I'm doing, which at this point is still going based off of that one single data point, which was this flight date right here. But luckily we still have it as greater than or equal to. If we change this limit here, maybe it'll give us other data points as well. But notice that we've got the 27th now. So it's actually giving us other kind of data. Granted, we've got a price of $0, which is not great. But generally speaking, we now have a number of those elements that we needed to get to the point where we can start to actually train everything as we see fit. So the $0 price might have to do with something with our data itself, which we would have to remove Like if there's inside of our Gretel data, if there's any $0 out there, we just need to remove all of those values. All right, so there's two final kind of cleanup things that I want to do. One of them is the user interface here. When I actually do go to do a search of some kind, I want the table to go away and say like thinking or something like that. So to do that, we're going to jump into forms.js and we're going to go ahead and grab that same sort of loading label that we did for the button, which was this right here. And so basically, if it is loading, then we'll go ahead and do some sort of thing like, thinking. Otherwise, we'll go ahead and render out that table if there is any data. And using the same logic, you could definitely update how that ends up working. So now when I go ahead and do a search, I can say, oh, cool, now it's thinking. And of course, we can always reformat that and check out Flowbite for other options for the loading part itself. And so, of course, once that's done, actually loading, then we should see our data itself. There we go. Adding a little bit of an animation might be a good idea just to make it not feel so much like you're waiting for things. But in this case, we now have a way to predict stuff. We have a way to add new data to give new predictions based off of synthetic data. The last thing is that this still says create next app. And so I want to change that. So going into our layout here, we can change that inside of our metadata. And this is going to be our AI travel agent and generated by Justin Mitchell and CFE. And there we go. There is our AI travel agent now. And that's what I'm going to call the end of this project. But I still have some suggestions as to what you can do from here. Thanks so much for watching. Hopefully you got a lot out of this one. The challenge I'll leave you with is to build your own data set, something that you're interested in, to make forecasts off that data set, but most importantly, to actually have some sort of web scraping involved so that you can have a delta between the forecasted price, which is what we see here, of course, and the actual price. And if there is a difference, as in the forecasted price is higher, then maybe it means to buy it. If it's lower, then maybe it means to wait. That is the challenge I leave with you. Now, of course, you could absolutely do this with airlines. You could do it with the housing prices. You could do it with pretty much anything that has a price. And then if you are doing that web scraping, you could do it on a schedule where it's sort of regularly happening and thus creating that time series data you need to do that forecasting model as we've seen throughout this one. Thanks again for watching, and thanks again to MariaDB as well as MindsDB for making this project happen with me. Really appreciate it, and I look forward to seeing you all next time.